Hello friends, this is Rupesh and I'm watching CPU Nerds video series on C++ interview questions, and this is about use of friend function and classes in C++. So lots of people get confused like where to use friend function, and let me tell you, this is my opinion and I found some of the statement on internet, especially on Stack Overflow, and people are talking about this with their own experience. So there is no straightforward answer for this question, but you can convince someone by.
This video is sponsored by Dev C++, a fast, portable, simple and free C and C++ IDE and code editor for Windows. Dev C++ uses MingW GCC as its compiler, and it can also be used in combination with Cygwin or any other GCC based compiler. Dev C++ have low memory footprint because it is native Windows application and does not use Electron. And it is immensely popular due to its light footprint, yet giving you all the features you need, not to mention that it's free. So download the latest release for free by clicking the link in the description field.
So let's start. So first of all, we'll see a friend function. We'll talk about the classes later. So let me write a class here. Here you're having base class. And let's suppose you're having one integer x, and we got this constructor. And let's assign some value here. So x. Okay, so this is what it is. You have this public here and you're creating b with value 10, and here is this function. Let's create that function void set, or let's keep this as function. Okay, and what you're doing is you're getting this base reference obj, and inside obj you're having this x is equal to 20. Okay, so let me do this like cout obj.x and deal first, and cout obj.x here. So this is before and this is after changing. So we all know that it is not allowed for this function to directly access .x of this base, because this .x is a private member inside class and you cannot use this x outside this class. Okay, so let's make this function as a friend function, and you're done. Base ref. Okay, so if you will compile this code, everything is fine. The only thing is we have not called this function yet, so nothing is printed. So let's give this b here and rerun this again. See, it is 10 and 20. So this is what this friend function does. And some of the people get confused by saying that this is breaking the encapsulation rule in C++, but it is not breaking, because this function is not telling that I am the friend of this class. Actually, this class is telling that this guy is my friend. So you are the owner of your class and you are defining that some function is your friend. So there is no break of encapsulation, right? It's you who is telling, not the other way. So this was about how friend function work. Okay, so let's look at where to use this feature of C++ and where comes this handy. So let's suppose there is a class called employee, and this is a class. It has ename, which is employee name, age, and all that stuff. Okay, so this is your employee class. Now there is another class. Let's call that class an admin. So here is the thing. You are an employee. You are allowed to change the details about you, whatever is there inside this class. No one else can do this, because if you are an employee, you will be having login ID and password. Like that, you will log in and you will change your stuff. Okay, like details in your company, correct? But what if admin wants to change something in your detail? That admin should have the rights to change these, right? And until unless that admin got that username and password, admin cannot change this. But as this is admin, admin should have all the rights, right? So what we generally do, we make this admin class, or if it is function, okay, we make this as a friend. Okay, so by saying that this admin is my friend, now admin class has all the rights what this employee class has. Okay, there are a few other stuff, like if this is the hierarchy of inheritance, like A, B, C and D. Let's suppose you are here, I mean this C class, these are classes, okay, A, B, C, D. This C class is making some function. Let's suppose there is some function fun, and this C class is making this one as the friend. Then this function has the rights only to access the stuff, I mean the private, protected and public member of C class only. This function cannot access what is coming from B and A. Let's suppose this B is having some data member X, or let's call that data member a small b, and this one is having a small a, integer a, integer b. This function will not have access to b and a. If you want to remember this, there is very good statement that if someone is your friend, you are here, and someone is your friend, then that friend will be your friend, not your daddy's friend or your mother's friend. I know this relation is not daddy and mother relation, but still, if you want to remember that, this is very good way to remember. Your friend is only your friend. So your friend can come to your home and can access whatever is there inside your room, not your daddy's room. Okay, he can use whatever belongs to you. Okay, not anyone else in your whole relationship. Okay, so that's the way to remember this. So yeah, we were talking about this friend admin thing, right? So this is one of the way you can use a friend class or friend function. Okay, if you are defining some class as your friend, then that whole class has the rights to access your private and protected and public data. But if you are creating some friend function, that only that function, particularly that function, is having that right. Okay, that's the only difference between function and class making as friend. Okay, and the guy who created C++, Business Struct, if I pronounce correctly, he said in one of his blog or website that friend keyword is mainly used for giving the rights explicitly. And I have seen so many people talking about that they are using this friend thing in testing. Let's suppose there is some class. Let me just remove everything. So let's suppose there is some class here. Let's call it base, and there are a whole bunch of data member, data functions and everything is there. This full class is ready now, and you want to test this class. Okay, so here is your int main function. You started your program, and let's suppose your program is ending here somewhere, and this is maybe calling here and there, so many places. And let's suppose here somewhere you want to check the status of this base class object, and you don't have getters and setters for all the variables, I mean data members of this class. Let's suppose this is integer x, and you don't have the function which will give you the x, like get x. This function is not available inside this base class. Then how you will test this class? So this is the way. What you will do, you will make some function here. Let's call that function. You will grant this function by saying that, okay, friend function. Okay, so this function will become the friend of this class. Now inside this function you can happily use obj.x, and you can print this, do whatever you want to do. So can you see that you are not messing with this class? And by messing means you are not including extra code what it doesn't require inside this base. Okay, that extra thing you are doing outside your class. Few people say that for testing purpose they use this friend keyword. Okay, so this is another good way to use this. And for testing purpose, let's suppose you are having so many test cases, like suppose you are having so many functionalities here, having so many data members, and depending on situation you might be having some values, and if the situation changes you might be having some different values. So all those testing code can go here, and you will make this one as a class, and you will write different functions, and all those functions will have rights to get the private and protected and public member of this class and do whatever they want to do. So if the test cases are bigger, you will go for friend class. Got it? And another use can be, let's suppose you are having 10 to 15 or 20, or let's suppose 20 classes, A, B, C, D, E and all that, and you want one particular function or one particular intermediator which will be the intermediator among all these classes. So it will become very simple if you will make this as a friend inside all these classes. Okay, then this will become a super function which can access all the data members inside these classes. So these situations can arise in programming. There is ocean in programming world. You cannot imagine what could be the requirement. So there is no hard and fast rule that you have to use friend function or friend classes in such a way, but these are the scenarios. Okay, I hope you like the video. Don't forget to hit the like button if you like the video, and if you haven't subscribed it, go for it. It would help me a lot. Thanks for watching. I'll see you in the next video. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is auto keyword in C++? And so the answer is, it is used for type detection. Okay, so what is this type detection thing? We'll just see that here. So if you notice here, I'm keeping auto 3 times, and this is 20, this is 20.5, and this is base. This code will really work. So we'll just see that first so that you can just be sure about that. So as you saw, it is compiling and it is running. So here what is happening? This is nothing but replaced with integer here. So if I'm writing auto instead of writing integer, when it is compiling, that compiler is generating integer code here. Here it is double, and here it is, if it is base, then the base will come here. And if I'm writing it something like this, like new or something, then this will become base pointer. Okay, so if you see here, this is for 4 base, and if you notice, it is not exactly telling you the type here. I'm giving you the output type, like this is another method of getting the type of your object or your variable. I have explained this concept in my previous video. If you have some doubt, you can just go and check that. So this type ID will get the type of this X, and we are just printing the name of that. So in this case, it is printing I. I stands for integer, D stands for double, and this 4 base is nothing but our base only. So they are changing the name, but throughout whole application the name will be same. So that you can be assured of. Okay. So right now I'm working on Linux. If you will go for Windows, then the name might change, but that name also will be there throughout whole application same. So if I'm getting this base type anywhere in this whole program, like I have thousands of functions, and if I'll get the type, then I will always get the base, like 4 base only. And if it is pointer, then let's see what it is giving you the output in that case. So we'll compile this now and we'll check that. So if you will notice here, it is appending P here. If you notice here, it is P4 base, and before it was 4 base. So as you can just think of, like P stands for pointer. Okay, so this is how this auto work. If you have defined auto, it will deduce the type automatically. Okay, so this is new in C++. Before in legacy C++, it was a simple auto okay, but now in C++11 we are not using in that simple way. This has some different meaning, and it is really very powerful when it comes to generic programming, okay. And this mechanism is called resource acquisition is initialization. How this is understanding that I should keep this as integer, not float or double or something else. It depends on what you are initializing. This 20 is of integer type and this 20.5 is of double type, and this new base. So what is this type? This is something like you are creating a pointer of this base. Okay, so this has to be a pointer. So this is how this compiler interprets and deduce the type of that. So we're done here. Thanks for watching, and make sure you go and check out my other playlist so that you will get the questions like this. Bye bye.
Hello friends, this video is about code bloating. Maybe some of you guys would have already heard about this code bloating, and maybe you don't. So let's just check out what is code bloating. And I have this definition for you. Code bloat is a production of code that is perceived as unnecessary, long, slow, or otherwise wasteful of resources. Okay, so what do I mean by that? So first of all, I will just write a simple code like this: string str Rupesh Yadav, and I'll just print this. Okay, so what do you think? Is there any problem in this code? Yes, there is a problem. Actually, the problem is not you are doing some logical error or something. No, the problem is something else. I will show you that. First, I will just compile this code. So there is no error. It is working fine. But there is one error which is called code bloating. Okay. What you are doing here is you are unnecessarily creating this string variable here. So the result of this line would be you will call a constructor of this string class, okay, and you will initialize this constant character string into that, okay, and this whole thing will take some time, and you are just printing that, okay. So instead of creating this variable, you could have just simply put this here, okay. No need to create this string. You can just simply put this here, and yeah, it will compile. And which is an obvious thing. And don't tell me that that string is useful for, let's suppose I might give some another name to this string. No, I'm not arguing about that. I'm arguing, let's suppose there was a big program like this and thousands and lakhs of lines program, and when it ended, you just printed something like exit. Okay, and you did it like this. You wrote that exit into some string and you are printing that string, and after that you are returning from the function, I mean the main, and everything is over. So there was this waste initialization. There was no need of doing this, okay, but still you did. So this is a code bloating. You are unnecessarily writing extra code, okay. So this is called code bloating. There are another example also. I'll tell you that also. Okay, so this is first example, and second example is something like this. Let's suppose you did like this. There is a requirement for you, like you need to create a address string which is composition of www.google.com, and this is how you are doing it. Okay, and this is not going to change because this is Google address. Okay, so this is Google address. It is not going to change. It is always going to remain google.com. But still you are doing these much thing to get this Google address. But instead of doing this much, you could have simply written this www.google.com here itself. Okay, or just here itself. Okay, are you getting my point? What I'm trying to tell you? We are not supposed to create variables and any resources which is really not required, and if you are doing that, then you are coming into the code bloating stuff. Okay, so this is second example. And what do I mean by you could have just simply written here? Oh my god, I use 2-3 laptops, keywords are different, that's why I face lots of problem here. Oh my god, instead of writing this, I could have just simply www.google.com. okay, so you could have written something like this instead of doing this much. Okay, remove all this crap if you really don't want that. Okay, and why? Because Google address is always going to be same. I mean the Google search engine, google.com. okay, so no need to take www separately, Google separately, com separately, after that adding and all that. No need of doing stuff. So next time if you write program, you keep this in your mind that are you going to create a code blotting? If not, go ahead. Okay, so this is a kind of question mark in your head whenever you write any API or something. Okay, so this is second example. Third example is inline functions. We all know if you are writing some class, let's suppose base, and if you are writing something like print in this function, I mean the class, and this is printing some value, let's suppose x, and there is this underscore x here, and it is something like this. Okay, so we all know this print function is inline function. Okay, whatever the function is there inside class, I mean the member functions are automatically inline functions. Compiler write inline like this, like this. Okay, when you go for compilation, it will append this inline in front of all the functions, I mean the member functions. So by default all member functions are inline functions. Okay, and whether it is inline or not, it is compile time decision. Okay, so if you are using this like base b1 and b1 dot print, then it might replace this b1 dot print with this whole code here. Okay, and let's suppose you are writing something like this: cout, hey, I'm going to print underscore x. Okay, so you think instead of one line you will be replacing two lines. Okay, this is two line, actually there is a semicolon here. Okay, so let's suppose you are doing this for 1000 times. So for 1000 line you are doing for 2000 line. Okay, so that is becoming code blotting. Your image size will increase, I mean the executable size will increase. So this is also a code blotting example. Okay, so I think I'm done here. I just wanted to show you a new word in programming, code bloating. It is there, and this is taken from Wikipedia, this definition. So if you like the video, like and subscribe. I'll see you in the next video.
Hello there, this is Rupesh and you're watching CPP Nuts video series on C++, and in this video we will be learning about constant cast in C++. So we all know there are four types of cast available in C++: constant cast, static cast, dynamic cast, and reinterpret cast. So first we'll see this one. In later videos we'll be looking into all those casts. Okay, so this is a little bit of note. I will be discussing 2 points. This is first point and this is second point, and lastly we'll be discussing about the bottom line. So let's start this. So first to read this note here, the expression constant cast can be used to change the constant or volatile qualifier of pointers or reference. So we all know this is the syntax of typecasting. So see, you can typecast const cast, and this is the syntax for that. So this is the destination type and this is your source. So what this line is telling, that your source should be either pointer or reference. Okay, and where t must be a pointer, reference, or pointer to a member type, whereas this one, this t should be either pointer or reference or a pointer to a member type. Okay, only these type can be converted using constant cast. Okay, so let's see what is first point. The first point tells when the actual referred object or variable is not const, then only use constant cast. What it does, it removes the constantness of your variable or pointer or reference. Okay, so this is the first case and this is the second case. Both are exactly equal. The only difference is this variable is constant here. Okay, you're creating a constant variable, you're taking the address of that variable inside another constant integer pointer. So this is okay. Now what you are doing, you are removing the constantness from here so that you can ultimately change this variable. Okay, that's what we are doing here. Got it? and now we are changing that variable, and the comment says invalid and undefined behavior, because there is one variable, this is a constant variable. Now you have taken the address of this variable, so let's suppose the address is f and f into some another variable, and this variable is a1, and this will be b1, and 0 cross f and f. Initially you told that this is a constant variable, okay, with this. Now you are removing that constantness and trying to access this memory address by this one. So you're dereferencing this memory address and you're pushing the value, whereas the original memory, which is this one, is constant. So this case is totally invalid and undefined behavior situation. Okay, you should never use something like this. Even though it is allowed, I mean, it will compile, but you should not do that, because this type of situations are invalid and not defined in C++ compiler, so you might get some weird result. Okay, so let's see where you can use this constant cast. This is the situation where you can use that. See, the original address is not constant, so here it is like this. You have this a2, and let's suppose this is ff0. This is not constant. You are storing this address somewhere here, 0 cross ff0 into b2, and you're trying to cast away the constantness of this pointer, which is this one, and dereferencing this operator, I mean the address, and you are changing this a2 itself. And this is a valid code, and you can do that because the original address is not constant. Here original address was constant, so there was a problem. Okay, so this is how we do this. This is the first case where you will use such things, I mean constant cast. This was the first scenario. Let's look at the second case, or before going to that case, let's compile this. See, it has compiled successfully and there is no error in this. Now you guys might be thinking that what actually it will print. So let's print that. So if you have printed a1 and if you have printed this dereferenced d1, then what would be the value? Okay, let's see that value would be little shocking for you, I know that, and I will demonstrate why it is like that. See, a1 is 10 but d1 is 15. How is it possible? If the underlying address, which is this one, is equal, so how this one address is holding two value like 15 and 10? How is it possible? How is it happening here? No, it is not like that. Actually, what happens when you have defined some variable a1 as a constant, compiler will try to optimize your compilation, and instead of a1, when you are compiling, your compiler will directly write this value here. So instead of a1, it is writing 10 here. And this d1, what you did, ultimately changed this address. Okay, and instead of 10, now a1, which is this 0 cross ff address, is actually holding 10. Okay, not 15. So that's why you are getting 10 and 15 like this. And I think we understood this first one, so let's go for the second one. Second one tells you use constant cast for this purpose. When we need to call some third-party library where it is taking variable or object, whatever you are passing, as non-constant but does not change that. What do I mean by that? Is this code. You have this constant variable. You have pointed out that constant variable with a constant pointer. Now there is a situation that there is this third-party library. Actually, in third-party library, you don't have the definition. You just have the declaration part, and you just include the library so that you cannot change that. Here you can change it, but in actual third-party, you cannot change anything. Okay? Like in C, if you remember, there is a sorting function qsort. That function parameters are fixed. You cannot change that. So the same way you cannot change this one, but I don't have any option, so I'm just taking this to demonstrate that. So the situation is you're having constant variable x, you're a constant variable, the pointer variable of that x. Now you are holding this one right now. And the situation is you have to pass the value to third party library where it is not taking constant integer pointer. It is just taking integer pointer. But you have a constant integer pointer. And if you are not using this one and passing this px, which is a constant, to non-constant, it will throw an error at compile time. So I shall just simply remove this, and if we will compile it, it will throw error. See, it is telling that invalid conversion from constant integer pointer to integer pointer. Okay, and if I will use that, now let's again compile that. See, it has successfully executed and the answer is 30. So you will use constant cast when there is some situation like this. Your third party library is non-constant and your data is constant, so you will cast away that constantness from your data and you will send that. Okay, but yes, that library should not change that data, otherwise it will become undefined behavior, what we learned in the first point. Okay, see, it is not changing, it is just taking the value at that address and adding with k. Okay, so ultimately it has become 30. We saw that. So this is the second case. I won't be showing the situation where it can remove the volatile qualifier. You just assume it removes the volatile qualifier because this volatile is generally used in embedded systems where you don't want to optimize any variable. You tell to the compiler that please don't optimize this variable, and sometimes you want to remove that volatile type from the variable and you want to tell that okay, now you can optimize that variable. Okay, so that was the second point here. Now let's look at the bottom line. Bottom line says that never use this because it will compile, as we saw that in our previous first case. See, this was executing, but this was undefined behavior. Okay, so you might think okay, it is working, so it is allowed, but it is not allowed actually. Okay, so never use until unless you have to use it. Okay, second point is use only when the actual referred object or variable is not constant, that we saw in first situation. Okay, and third point is use when we are dealing with third party library and some API wants some data non-constant form, but we have it in constant. That also we saw in our the second point. Okay, so to recap that, constant cast removes constant or volatile qualifier from the variable, and what you are typecasting should be either pointer or reference, which is this v here. So this is the source, what you are typecasting, and what you are typecasting into, that should be either pointer or reference or a pointer to a member type. Okay, and constant cast should be avoided until unless you really need to use that. Okay, so I think we're done here. Let's look at the next video about static cast, and link is given in the description field. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is one of the use of decltype in C++? So just notice this, I am going to explain one of the use of this decltype, and the answer for this is, it checks the type of the expression, not anything else, the expression. Okay, we'll see that in a moment. So what problem is solved, we'll just see the problem first. So if you see here, I have created this add function, which is a template function. So I'm passing this 1, 1.8. Wait a minute. And this time I'm passing 1.8, 1. So what do you think what should happen here? T1 and T2 both are different type. One is integer type and 1.8 is a float type. So in this case, so what do you think? What should be the output of this program? So let's compile and run that. So the first output is giving 2.8 and second is giving 2. What is the reason behind that? The reason is this is integer type and this is float type. So the type substitution here is like integer and float. So as this is T2 is float, I am returning with float type, it is returning 2.8. Okay, whatever the type of this expression is, because this T2 is a float type, and here it is giving 2 only, if you notice here. And the reason is you are giving T2, and in this function substitution call, this one is of type T2 and this type T2 is an integer type. Okay, so that's why that 0.8 is getting truncated here. So how to solve this problem? That's where this decltype comes into the picture in C++ 11, okay? And that solves this problem. I'll show you that how it does that. Instead of writing it like this, you can just simply write auto here, and the full syntax is something like this. Decltype, and you will just give the expression. And if you see here now, we will compile and we will run that. In both cases it is 2.5, 2.5. So how this thing is working here? This particular thing is called trailing return type syntax, okay? So you are giving in the trailing afterwards the type of the return. And as I said, it is expression. And as I said, it checks the expression type. So this expression type is coming as float, okay? So that's why it is giving you the float output all the time. And this auto is nothing but type substitution mechanism, or you can say type deduction mechanism, okay? This I will explain you in some another video. This was the problem in C++, which this decltype solves in C++ 11 and further. So thanks for watching, and make sure you go and check out my playlist so that you will get the videos like this. Bye-bye.
Hello there, this is Rupesh and you're watching CPU Nuts video series on C++ interview question. And in this question, we'll be learning what is the difference between reference and the pointers in C++. So sometimes we use reference, sometimes we use pointers. So first is memory address. When you create a pointer like this, let's suppose you're creating an integer pointer, P, and you're storing the address of I inside that. So here we are creating a reference here, and here we are creating pointer, okay? So what is the difference between these two? So first point tells that P has its own address, okay? So let's print that, like we'll print the address of R first, and we'll give one space here, and then we will print address of P, okay? Then we'll check whether it is really working or not, okay? So let's compile this and see. There are two addresses, but this R and I are having equal address. I mean, both are sharing the same memory location. It's just an alias, like you are referring I, and that's it, okay? You don't have your own address, okay? So if you will print I address here, address of I, and let's give some space here, and we'll compile this, we'll see that this one and this one both are equal, okay? See, so here comes the first point. Memory address is not given to the references, okay? Because it is referring to this address only, okay? Actually, what happens when you create a reference? When you create a reference, the symbol table is getting created in computer for all the variables, and the memory is allocated, like it is allocated for I. What is the size of the memory allocation? 4 byte. And that address was returned. So there will be one table which will hold the variable name and its address. So if you are accessing that variable name, ultimately you are accessing that address, okay? So this variable and this variable both are pointing to the same memory location, but in pointer case it is not true. Pointer holds its own memory address. And let's see what do I mean by that. So whenever you are having these variables, it will create one table, and that is called symbol table, that generally look like this. There are lots of entries in that. I will be showing only 2 entries, so it will be very simplified here. So we are having this I, okay? So this is the name of your symbol, and this is the address part. So whenever you are creating any variable, it will have its address like 0x20. So this is the address. And if you are creating a reference, in that case, this will get copied directly here, okay? So 0x20. And if you are getting any pointer, then it is like this, 0x something like 30. This 20 and 30 is not the point here. The point is these two memory locations will be equal and this will be different, okay? So this is how this whole thing is working, and we have seen this memory address. So the second point is reassignment is not possible with reference. And let's see what do I mean by that. If you will write R is equal to, let's suppose something else, VAR, and you're having this VAR like this. Let's suppose it is holding 90, and you want R to point VAR, okay? Not this I, but it is not possible. This will compile. The only thing will be this 90, what this variable is holding, will get assigned to R, and R is referring to I, so ultimately I will become 90. Okay, but if it is pointer like this one, this integer ptr, no, here it is only p. So if you want this p to hold some another address like var, this will hold the address of var. Okay, before it was holding the address of I, now you can reassign. Okay, and if you will dereference p is equal to, let's suppose 60, okay, then this 60 will get assigned to the var variable, not I. But in case of reference, you cannot do that. Once you have created a reference, you cannot change by saying that, okay, now I want to refer something else. No, it is a tight bound, you cannot break it. Okay, so that was the second point. Third point is null value. So let's see, what do I mean by null value here. Whenever you create any pointer like integer pointer, if you don't want to initialize anything inside that, you generally initialize null to that, okay, like this. But that's not the case with reference. You cannot make it like this, and after some time here somewhere you are assigning I to R. No, that is not possible. You cannot have reference empty, or you cannot initialize it to null. Okay, so the second point is, this third point is, you have to give the variable name to the reference whenever you are creating the reference like this. Okay, but that's not the case with pointers. You can create pointers here and you can assign it anywhere. Okay, like p is equal to address of I, and that I could be somewhere here. Okay, integer I is equal to 10. So this is not possible and this is possible. So third point was, you cannot initialize null to reference, and you cannot make reference empty and initialize it later. No, you have to define what you are referring when you are creating any reference at the same time. And the fourth point is arithmetic operations. So let's see what these arithmetic operations are. Fourth point is that arithmetic operations are not provided for references. Okay, and let's see what do I mean by that. If you want to increment your pointer, so what generally we do, we write like this, p++. Okay, so it will point to the next memory location, but that is not the case with R. Okay, so references cannot point to something else. The only possible way to do that is, you can have the address where it is pointing, and then you can increment that address by 1 or by any number. Okay, but this will not do anything. Okay, so that's the difference in terms of arithmetic operations, and that is not a very big difference. Okay, and last is indirection is not given in references. Okay, and let's see what do I mean by that as well. That is something like, you have the level of indirections in pointers. You create double pointer like ptr, and inside that you will initialize your p. So this double pointer will hold the address of single pointer. Okay, and let's suppose you want to create a triple pointer. Okay, ptr1, that will hold the address of ptr. Okay, so this triple can hold the address of double, and double can hold the address of single, like that. Okay, but this type of things are not possible in reference. Okay, there is only one level of indirection in reference, but in pointer there are n number of indirections. You can have multiple pointers to hold the address of multiple pointers. Okay, so one level of indirection means you can refer r1 is equal to r. Okay, this is possible. There is no problem. This r is referring I, and this I is a normal variable. Now you can use this r to refer this I and initialize this to some another variable, and this is also a reference variable. Okay, so there is no problem in this case. So if you will print r and if you will print r1, both are same. Okay, let's check that. See, 10 and 10. Okay, so these are the differences of reference and pointers. So let's quickly recap all these things. First difference is memory address. You cannot have different memory addresses for different references. Okay, because they all point to one single variable But that's not the case with pointers. Pointers have its own memory address. Second is reassignment is not possible with references. Once you created a reference, this R is pointing to I. Now you cannot make this R to point something else. Okay, so that is the second point. Third point is null value cannot be initialized to references. Okay, you cannot initialize null here like this. Okay, but pointers allow null initialization. Fourth is arithmetic operations are not possible on references until unless you use the address operator. Okay, and indirections is also not given to the references. It is only possible with the pointers. Okay, that's what we saw here. And if you're interested to know when you should use pointer and when you should reference, please watch my next video, because this video is getting a little bigger and it is really not a good idea to dump everything in one single video. And if you want to watch that video, link is given in the description field. Okay, so I'll see you in the next video.
Hello friends, welcome to another C++ interview question, and the question is, what is the difference between range based for loop and the foreach in C++? Okay, so these two are introduced in C++ 11 and further. Okay, so we'll see the difference and we'll see the sum of the difference. Okay, not all the difference, because there would be lots of differences in the depth which I'm not going to cover. I'll be covering 2-3 differences which will be sufficient to answer any question in C++ interview. Okay, so let's go ahead and check out this code here. So I'm not doing anything special here. This is just a vector of integers. I'm pushing back I element in this from 0 to 4 time. Okay, and I'm just printing these values here. So this is one type of foreach, this is another type of foreach, and if you don't know what is this lambda expression here, then I'm using this print, this function pointer thing here, which will just print out this. So in first glance you will be seeing that okay, these three are working equally, but they are not equal in all the cases. Okay, so we'll see that line by line. So first we'll print this code so that we can see that it is working correctly. We'll compile this and we'll run this. So as you see here, these 3 for loops are responsible for printing this. Okay, whatever the value is there in this vector. So from 0 to 4 one time, from 0 to 4 another time, and from 0 to 4 third time. Okay, so we'll see this for loop first. So what is happening here? If you are new C++ programmer, then you might find this interesting. This is nothing but you are saying that I want to iterate over whole vector and I want to get one element each time and I want to print that. Okay, so it is nothing but saying give me one element line by line. Okay, so this is what it is happening here, and this is also the same thing, but this is for each loop, and you are saying this will be the beginning point and this will be the end point of this vector, and then you will call a function. This is a function. Actually a lambda expression is nothing but unnamed function. So you are passing the element here I and you are printing that element. Okay, so it is nothing but just a function here. Okay, so this is just a function. You can just think like this. This is a function. You are passing integer in that and you are printing that integer. Okay, it's like that. And if you are afraid of using this lambda expression, then just forget about that. You can just simply use this print function here, and this will automatically call this print function and pass the argument, and you end up printing that. So that is what happening here. Okay, we already saw this. Now come to the difference point. What is different in between range based for loop and the for each? So the first difference comes, if you are using range based for loop, you cannot define the range. What do I mean by that? So if you want to define the range, you have to do it like this. Suppose you want to start from 2 here. So we will see the output, then it will be more clear. Now see, from 0 to 4, this range based for loop printed from 0 to 4. Now I kept this range for this for each. So I am printing from 2 to 4. Okay, not from 0 to. And this particular case is not possible in this one. Okay, so this is one difference. And another difference is you cannot use something like this, integer and array of 10. You can use it like this, array of 10. So wait a minute, I will just change it a little bit so that you will understand it a little better. And instead of this, I can just AR and I and I. And instead of this, I will make it 10 times. So now we'll compile this. and run. See, from 0 to 9. So this is happening here. So you're just printing it 0 to 9 times. Okay, but if you want for each to accept your normal array, you won't be able to do that. Okay, because for each always requires this begin and end. This is the syntax for this, and you don't have any begin and end for this, particularly this your traditional array. So we'll repeat this. What was the difference? In this case, you are not allowed to give any range. It will be looping over all the elements. In this case, you can give the range. So this is the benefit of this for each loop, and the benefit of this one is you can iterate over normal arrays. Okay, one more difference is there. I mean, actually that is not the difference. Let's assume you are having something like this, and one for loop is there, and let's assume you are using it like it is very big for loop. Okay, and whatever is written here, you are writing somewhere else also. You are iterating the same thing and doing the same thing in another for loop also, like this one. Okay, like this here, but not exactly after this. Maybe after calling some function, in that function you are doing it like this. Okay, so instead of calling and writing whole loop 2 times, you could have just simply put this whole thing into one function like this, and you could have just used this for each loop and you could have just called that. Okay, so that would have been little more readable and elegant. Okay, so that is another difference I can think of. If you can think another differences, please comment out so that other users will get the benefit of that. Okay, so I think I'm done here. Thanks for watching, and make sure you go and check out my playlist so that you will get the videos like this. Bye bye.
Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++. Previous video we saw how to use constant cast and static cast. So let's start this video. So why we use dynamic cast? Dynamic cast is used for only one reason, and that reason is this. You have a base class, there are derived classes D1 and D2. We all know that if you are creating a base pointer like this, base ptr, then you can initialize either D1 or D2 inside base pointer. Okay, so D1 or D2. But let's suppose you initialized D1, and after some point of time from this base pointer you are typecasting into D2. So D2 is equal to base pointer. We know this is not good because actually this base pointer is holding D1 data, but you are typecasting that data into D2, and this is wrong. So to find out this problem in your code, we use dynamic cast. Okay, this is the only use of this dynamic cast. Base pointer can have either D1 or D2. I mean derived 1 or derived 2 or derived 3, because there could be n number of derived classes. In that case, all classes what belongs at this level can be assigned to base pointer. But if you are getting back from there to this class, you might assign this data inside this data. Okay, so to avoid that problem, we use dynamic cast, and we'll see how we do that. So before going further, let's read some points so it will be a little easier for us. So dynamic cast is used at runtime to find out correct downcast. So that's what I told. This is called downcast. You did upcast, and from here you're doing downcast. Okay, so note number 0 is you need at least one virtual function in base class. So in order to use dynamic cast, you must have a virtual function in your base class or your inheritance hierarchy. Okay, then only this dynamic cast will be able to find whether it is really the same object or not. Okay, so first point is, if the cast is successful, dynamic cast return a value of type new type. So new type is this one. So if cast is successful, like you are casting D1 into base pointer, and if this cast is successful, you will get this type of data. Okay, and third point is, if the cast fails and new type is a pointer type, it returns a null pointer of that type. So if this cast is failing, then this will have a null pointer. Okay, that's the note number 2. Let's look at note number 3. If the cast fails and new type is a reference type. New type is always this type, okay? Don't get confused. So if it is reference type, it throws an exception that matches a handler of type bad cast. So it means it will be throwing an exception of bad cast. Okay, there is an exception called bad cast we will get if we are typecasting into reference. So these were some point. Let's look at the classes now. This is the base class. We have derived base into D1 and D2. Now see, you are typecasting derived one object here into base pointer. This is a valid code, no problem in this code, okay? Now this base pointer is holding derived one object, but you are typecasting that base pointer into derived two pointer and assigning into this. This is not correct code, okay? And this is where the dynamic cast comes. So what I said, if the cast fails and new type is pointer, it return null pointer. So as we know this cast will fail, we can just simply check that. So if dp2 is equal to null ptr, we can print something, okay? Null, we can just simply print this, okay? So let's compile this code and see it is printing null for you, okay? It means that this is not working, okay? Let's add else case also and print something else like not null, okay? And if this is the case, then it is failing. Let's typecast to the perfect type like derived one itself, and we will see whether it is compiling or not. So let's compile and run this. See, in this case it is not null. It means you have got the perfect typecast, okay? So this is the only sole purpose of dynamic cast. There is no other use. And don't forget, you have to use virtual keyword, okay? So let's remove this virtual keyword and see the difference. So if you will remove this virtual keyword, if you will compile, it won't compile itself. The error is cannot dynamic cast base pointer of type class base pointer to class derived pointer. It is telling the same thing because source type is not polymorphic. So by adding virtual there, we make this polymorphic, and that's how we are able to achieve runtime checking. And what is that runtime checking? Let's read out this bottom line here. We'll understand it really good. Bottom line tells work only on polymorphic base class. At least one virtual function is required in base class because it uses this information to decide about wrong downcast. It is used for upcast like derived to base and downcast like base to derived, but it is mainly used for correct downcast, okay? And using this cast has runtime overhead. This is also a very important point. Runtime overhead means it will check at runtime that the object you are really typecasting like base pointer to derived pointer. So in this base pointer, what type of object is, okay? So if it is derived one, so you are typecasting into derived one, yeah, then it is okay. So this happens at runtime and you need virtual keyword there, and we all know why we use virtual keyword. Using virtual include runtime type information and it uses that, okay? So this was the main point. So let's look at the fourth point. If we are sure that we will never cast to wrong object, then we should always avoid this cast and we should always use static cast instead of dynamic cast. And there is only one reason to not use this, because we have runtime overhead, okay? It will be little bit slower than static cast. Static cast will also cast this one into this one, but it won't check at runtime, okay? So you don't have that luxury of finding out at runtime that it is really typecasted or not, because the static cast is a compile time cast and it will check, okay, base pointer and derived pointer, okay, no problem, because base inherited into derived 2 or derived 1 in that case, so it is okay. But it is not okay if base pointer is pointing to some another object, okay? And let's look at that reference case, I didn't discuss that, right? So let's create a reference like derived 1 reference r is equal to dynamic cast derived 1 reference and d1. Okay, so this is r1 and we will check this one with try and catch. So try, and after that we will write catch block. Here we will write std exception reference e, and we can just simply print that message. Okay, so our class is okay. Now we have to use that exception header file, include exception. Okay, and I think we are good to go. Yeah, it compiled, so we are not doing anything bad, so it is just simply compiling. Okay, so if you want to do something weird, you can just typecast into something else. So if this is d1, which is of type what? Derived 1, and typecasting into derived 2 reference, in that case it should throw an exception and we should come here. Okay, so let's see we are coming or not. And as we can see here, we are having this std bad cast. Okay, and there is one warning like dynamic cast of derived 1 to class derived 2 reference can never be succeeded. Okay, so we saw that how to use dynamic cast, and I think you enjoyed the video. So the next video is about reinterpret cast. I'll see you in the next video. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is explicit constructor in C++? Or you can ask like this also, what is the use of explicit keyword in C++? Okay, and the answer is, it avoids implicit call to the constructor, and we'll see what is that implicit call. This is main. You're constructing that object, passing that 10 here. Now you're constructing another object, and what is this? You're initializing 20 to this object 2. This object 2 is of type base and this is of type integer. So how could you do that? So here comes the implicit call to the constructor. And another example could be like this also. Function you are passing 30, whereas this function is expecting base. So first thing, is this code going to be compiled? And the answer is yes. We can check that. We compiled and we run that. Now we are passing this object 1 which is initialized with 10. So we are printing the 10 here, and after that we are passing this 30. So what is happening here? Okay, so first I will talk what is that implicit call. So when you are having constructor with one parameter, and whatever the parameter you are passing or you are assigning to that object, if that type is same, like this is integer and this is also integer, then what compiler does, compiler implicitly call this constructor. Okay, to avoid that or to stop that happening like that, you use explicit keyword here. Okay, so now we'll see our code will not compile. It is telling that error conversion from init to non-scalar type base. So what you said, now I don't want anyone to construct this base with this integer implicitly. Okay, so this is not allowed now. Even this is also not allowed. You can see the error here. This is the error. Okay, so that's it. Thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is when to use extern C in C++ code. Okay, and the answer for that is when you are writing C++ code and including C code in that. It could be a library also which was written in C before, okay, and you want to use that C library which was compiled in C language, I mean using GCC or something, and you want to use that library into your C++ code. So you have to recompile your code and include that library's header. Okay, so there comes a linker problem. I'll show you that how that linker problem comes. So let's understand this code here first. So this is my application. This is my C++ program here, app.cpp if you notice here. And this is using some C file.h, and this is C file header. it is giving you the declaration of function which is defined in this file. Okay, so this is your library which was written long back, and now you are using this library and creating this application. Okay, and this header file is including just the declaration part of that library function. So this is just the function you want to use in your app. Okay, so this function is nothing but this function you want to call here, okay, in your application. Then you have included this header. So it looks pretty much okay here, but when you will go and compile that, it will create problem. Why it will create problem? We'll see that. So first we'll go and compile our legacy code. Okay, legacy code means our C file. So it should be compiled like this. So we'll compile it. So if you will see here, this object file is created. So this object file could be used in any C++ code. No need to compile this again. Okay, so I won't go into much detail of this compilation. So we have compiled this C file. Okay, so now you think you have this library in your hand. Okay, and now you are building your app.cpp here. Okay, so now we'll just go ahead and compile our code, I mean the app file also. So app.cpp, and we will compile this. So it is compiled, so no issue till now. So it is compiled. If you want to check, this app.o has come here, so that both files are compiled. Our legacy library was compiled and our just current application is also compiled. But when you will go and link these two files and try to create executable, it will create an error, and that would be a linker error, and we'll show that what is that error here. So let's go ahead and -6, I'm using the latest one, and just app.o and cfile.o. okay, if you link these two files, which means you want to create some executable out of it, it will create problem. It will say undefined reference to function here. Why it is saying like that? Even if you have included this header file here, why it is showing you that function is not declared anywhere, I mean the defined anywhere? So what could be the reason behind that? So till now it is giving you the undefined reference error. Now we will use some command and check the object file of that. So what is the name of that function in that? If you see here, this is our main. Okay, you will never change the name of main in that object file. Okay, but your function, this function is changed, like it is appended with some extra character here. Okay, this is just because C++ uses name mangling so that it can achieve function overloading, okay, which is in C++, which is not there in C at all. Okay, so this is the reason it is changing all the function name by its own way, and this is the way. Okay, if you will see another compilers, they might be attaching some other name. Okay, so the whole idea is, if you are writing two functions, I will just show you very quickly, like integer a. So this is surely the case of operator overloading in this. Okay, so we'll just go ahead and compile that code again so that we will get the idea here. So we'll compile that. Now we'll see the symbol table in this case, then object o. If you see here, your add has changed. This is one add, which is f. F means it is having float, and another one add is there which is having integer as a type. So this is how compiler knows at what situation I am supposed to call what function. Okay, so that's how it discriminate, okay, between all these functions. So add became float in float case, and add become integer in this integer case. Okay, so this is how this work. And why this function is getting mangled? Because this is the way C++ deal with all the functions in that. But our library which we are using is compiled using GCC, okay, and it was not compiled with G++, so that name mangling will happen there. So that's why we don't want to change the name of that function. Okay, we want to tell anyhow to the compiler that I don't want to change this function name because I have not mangled this when I was compiling that C file here. Okay, so how to do that? So there is a way, just writing extern C, which will tell to the compiler that don't change any name which comes under this. Okay, so whatever is under this, don't change the name. Okay, so we'll see that how it will work. Now we'll again compile this code and we'll again dump that, Now if you will find that function is simply the fun here, and if you will go back and you want to check that function was something like this. Okay, so now we have tell to the compiler, I don't want you to change anything which is coming from here. Okay, so this is how it will work. And now you have got the function here, and this object file, I'll just show you. This object file is containing function name as function only, I mean fun only. So we'll check that also. Name C object file. So if you see here, this is one function, and before your compiler, C++ compiler was creating this name and you wanted to call this function, so that's why this linker problem was coming, because it was telling that function is not there. Okay, whereas you have changed the function name, then how you are supposed to get that? And that is called name mangling, and that is how compiler achieve this function overloading. Okay, so previously you saw that there was some error coming. So now if you will compile that code, let's say our app.o and cfile.o, if you will compile, there won't be any error. See, there is no error, and you can just simply go ahead and run that. And this function is simply calling this function. I am in C file. Okay, so one more time, if suppose I am not writing it like this, and I am going to compile my code which is in C++, so that G++- 6 app.cpp, and I am going to compile that -c. It will compile. When I am going to link this, then it will show you the error. It will show this undefined error. So, and if I will write this extern C here, in this case, if you will compile this code and again run that, it won't show any error. Okay, so we have achieved our function call with help of extern C++.
Hello friends, welcome to another C++ interview question, and the question is, what is function chaining in C++? So you might have heard about this or you might not have heard about this, but still, yeah, let's go. We'll see how this will work. So function chaining is nothing but it looks like this. You will be having chain of functions, like you are having one object, you are calling some function on that, then again you are calling some function on that, and then again you are calling on some function, and then you might be calling again and again and again. So this is like chaining the functions, okay? And to achieve this, you just only need to return this reference, okay? We use function chaining just because we want some kind of intuition that in order to complete this one, like setting B, first you have to set A, okay? Then only you should go for setting B. Or in order to print this object, you must have set both the variables. So this is some kind of message to the user or the developer who is going to read your code or something. This is some kind of message to that guy, okay? You could have achieved the same thing by just simply writing like this. Like you are writing b.set A and setting some phi here, and then again b.set B and setting 19 in that, and then b.print. Okay, so this is also the same thing, okay, but this is not showing that there has to be some sequence, because maybe developer can insert any number of code here or do something with this b which he is not allowed to do, or we can say he should not do. Okay, so to give that kind of message, we simply use this function chaining. Okay, that is a good way to give this kind of message that please call this function first, after that you call this function, then only you should call this function. I am taking very trivial example here, but you can think of any great example where first you need to set some variable, then only you should like perform some another operation. Okay, or let's suppose you are doing some animation, and first you want to animate something like b.animate this one, let's say animate 1, and then after that you want to do animate 2, okay, then again animate 3, so like this, and on and on and on. So in that situation, this function chaining comes very handy. Okay, so there could be lots of ways you can think of this function chaining could be useful. And again to say, if you want to achieve function chaining, you need to return the reference of your original pointer. Okay, so first of all, this b calling this set A function where you are passing this 5. So this 5 is being assigned to this A, and in completion of this function, you are returning this, and this dereference means you are pointing at the object itself and you are returning the reference of that object. Okay, why reference? Just because maybe you want to change that particular object, and as you can see, you are changing only the particular object. Let's suppose if you are not returning by reference, then what could be the output of this? So first we'll go and check the output of this program. Okay, it would be 5 and 19 only, but still we can check that. So I will just simply compile this. What is the name? app2.cpp here, and we'll just simply run this. So as you can see, A is equal to 5 and B is equal to 19. Just in case you are not returning by reference here, now let's see what will happen here. Okay, we'll just simply compile and check, and the output is same. Here it is not giving the difference actually, but let me call this print function again. Okay, so here we'll get the difference now. Yeah, see, B was called here, b.set A. So 5 was set and the object was returned. Here the copy of object was created. Okay, and now you are calling that set B on that copy of the object. Okay, not the B itself. So after that you are setting 19 on the copy, not the actual object. Okay, and after that you are printing. So in that situation you are printing the actual value. Okay, but when you are coming and printing B again, which should have 5 and 19 both, but in this case it won't have both, because when this set A was setting this 5, that time it didn't return the actual object. Here the copy of the object was created. Okay, so that's why 19 was set to the copy of the object, which is nothing but the temporary object. That's why it is showing 0 here. Okay, so this is how we deal with function chaining, and you should always return with reference only. Okay, so that you won't end up doing something which is really problematic. So see, if you are changing with this reference, you are having this correct output. Okay, all the time. So I think I'm done here. Thanks for watching. Bye bye.
Hello guys, this is Rupesh and watching CPP Nuts video series, and this question is about function hiding in C++. And this is pretty uncommon question, and if it is uncommon, you should be knowing that, right? So let's try to understand what is function hiding. So this is your base class. You have this function in base class, and this is derived class, deriving base class, and the same function name, but the parameter is different. Okay, don't think about this integer return type. I could have written void, doesn't matter. And here you are having derived object D and calling function with 1, which is integer. So it is this function, and function with character, which is this function. So what you expect? First it should print base and then it should print derived, right? Because this function has come here because we have derived it, correct? So let's run this and check it. Okay, we have derived and derived 2 times. It means both the time it is calling this function only. So this is called function hiding. I'm telling you, when you have the same function name inside your derived class, then all the similar name from base class will be hidden inside your derived class. Okay, so it doesn't matter your parameter is different, you have 2-3 parameters, doesn't matter. You cannot use that function inside derived, I mean using this derived object. You can do one thing, you can just simply call like this, base function, I mean by using the scope resolution operator. So if you will do this, see, the answer is base and derived. So there is another way of doing that actually. You can use something called using, which will be used like this. That's it. So now what you're doing, you're telling that I want base class function scope should come here. Okay, so what you're saying, all the functions which have this fun name inside this should share the similar scope what derived is sharing. Okay, so ultimately this function scope will become local here. Okay, so now you can use this, just run this,
See, it is base and derived, and you are not using that scope resolution operator here, okay? But still it is working. Why it is working? I told you. Using this, you are telling that from base, whatever is there with this function, there could be so many functions from base here. Let's call some another function here, and this is, let's call this a void function. Void, okay? And if you are calling this here without any parameter, let's run this, you will see that this void is coming, okay? So what you are saying is, I want all the functions with fun name inside here, or you can say you are making those functions scope local to this derived class, okay? And as I told you, if you are not using this one, then you need to use scope resolution operator, then it will work, okay? So let's run this. See, derived and derived. So for these two, it is calling this only, but as you are using the scope resolution operator here, it is calling the void one here, correct? So to bring these functions scope local to this derived, we use that syntax. And another thing is, if you are creating some function, let's suppose you are having this one, okay? So you might think, okay, because of this one parameter only, it was getting confused. So let's pass two parameter, it will call that function, okay? But no, it won't call that function, and this is a compile time error, okay? Why? Because this function is not here if you are not using this one, okay? So let me clear that. And if you are calling this function 1 and 1, it means it should call this function, but it won't call that, okay? So let's check that. See, you got the error here. So what we learned from this video, that if you are using any function name in derived class, it will hide all the functions coming from the base class with the similar name. So this is called function hiding. And to overcome this, we use this one, using base and that function name, okay? So you learn a new thing, right? Function hiding. I think we're done here. Thanks for watching. And yeah, don't forget to subscribe for videos like this. Bye-bye.
Hello guys, you're watching CP Peanuts video on function pointer. So we'll try to answer these questions here, like what is function pointer and how to create them, and calling a function pointer using a function pointer itself. And last, what is the actual use of function pointer, where we should use function pointer, not anything else. Okay, so stay with me and let's start it. So first of all, what is function pointer? So I have these questions and answer here. So as we all know that normal pointers variables store the address of another variable. Okay, so if you are writing something like this, integer I and integer pointer p, so this pointer p will hold the address of I. Okay, so we all know that very well. Okay, now what is function pointer? If it is function pointer, it will be storing the address of another function. Okay, so first you remember that. Now the question is how to create them. So we'll take the example of this normal pointer itself. So let's suppose you have some function which will add two numbers and return the addition. Now you're going to create a function pointer which will store the address of this add. Okay, so how do you do that? So let's take an example of this one here. You wanted to store the address of I, so you created integer pointer. See, you didn't create a character pointer and stored the address of I. No, you did this. Okay, you created integer pointer and store the integer data type's address inside that. Okay, so if you want to store this type of address, then you have to create this type of pointer to hold this address. And what do I mean by that is the function pointer what you are going to create should return integer and should take two integers like this as a parameter. And it is really very simple to create function pointers. Why? Because what you did in case of normal pointer here, you just created a variable and at front of the name you just put this star mark. Okay, so we'll do the same with function. Let's suppose you have this function name and it is returning two integers, and you will write this pointer at front of this function name. But hold on guys, this is not done. If you will see something like this, what would you think? There is a function. That function is taking two arguments as integer and returning integer pointer. It is looking like you're returning integer pointer. This is not looking like a function pointer. So this star or asterisk should be with this name. So how to associate this? This is the way. And you are done. Now it is function pointer. And you can happily assign this add here. Okay. So let's see whether this code is really a working code. So this is your program. This is the add function, and we are creating a function pointer here. So let's compile this. So this is GCC. Program name is demo. We compile it. There is no issue in this program. Okay. So what we have learned is how to create a function pointer here. Okay. So what it is doing actually, it is holding the address of this add function. And there are two ways to do this. I just literally forgot to mention that, but I should mention that as well. There is this way of assigning the address of A, and this is another way. Okay, so this is most perfect way because this will work even with the old compilers. This is not going to work with old compilers. Okay, so better you should always use this one if you want to migrate from new compiler to old compiler. Now, as this add is here, now you can use this function to call this function. That's the only thing what this function pointer is meant for. Okay, you will be calling some function with some another name. Okay, so you're calling this add function with this function, and let's see how. So if you want to call some function here, you just simply pass these two values. You will get some value like C here, and we can just simply go ahead and print that. So let's compile this code. There's no problem. If you run this, the answer is 3. So 1, 2, and 3. So you notice that your function pointer thing is working. But wait a second. This is a new way to call function. And this is the traditional way. Okay. So I told you how to assign that by using address operator, and how to call function. There was that simple way, and this is the traditional way. So let's check this out, that this traditional is working, and yeah, see, it is working. Okay, now we know how to create function pointer, and we know how to call them. Okay, and as I told you that your function pointer should be of type exactly what you are going to assign in that. Okay, so this add is of type returning integer and taking two parameters. That's why your function pointer is also returning integer and taking two integer parameters. Okay, so if you will make some change here, let's suppose you are adding one extra integer. In that case, if you will compile, there will be an error. Too few arguments to function fun. Okay, and if you will add another argument like 1, 2, 3, and you will go and compile. So here you got the warning because wait a second, and the result is 3. So this is what I wanted to show you, that if your pointer is of not the same type what you are assigning into that is a problem here. Okay, see the warning here. So you should avoid using this because see, this third value is avoided here. Okay, only 1 and 2 are passed, and you are returning is the addition of 1 and 2 here. Okay, so far we have learned about function pointers and how to create them. Okay, now there is another question, and that question is this calling a function using a function pointer. We already saw this, so we will skip this question. Now there is this another question, how to pass a function pointer as an argument to another function. So let's create another function here. So let's try to understand what is happening here. You have one function, function1, and you're passing this add, which means you're passing the address of this add function to this function, and you're catching that address like this. Okay, so this is how you write in function parameter when you are getting some function's address. Okay, so let's run this. if you will compile this, okay, I forgot to have this C here. Okay, so let's compile again. There is no issue. If you will run this, answer is still 3. Okay, so this function we are calling add function here with some function name, and that some function is getting created like this. Now we will see another question here, and that question is how to return a function pointer. And this is really very interesting question. It was so easy, right? What function type you want to return? These both functions prototype is same. I mean, both are taking 2 integers and returning 1 integer. So you created a type of the same prototype here. Now let's look at the another one. That another one is little tricky. Let's suppose you don't want to use this type def and all, then how you will deal with this? So this is your function which will return a function pointer of this type. Okay, so let's do that. And this type is returning integer and taking 2 integers. So first of all, you will enclose this function with 1 round bracket here like this. So this has become the name parameter, integer and integer, and the return type was integer. And one more thing, this pointer, and you're set. Now there is this function fun which returns a function pointer of type taking 2 integer as a parameter and returning 1 integer. Okay, so this is how this whole thing will work. So let's compile whether it is working or not. So it is working, and the answer is still 3. I know this is little tricky and hard as compared to this type def thing, and that type def was more readable than this. Okay, so if I will remove all that, see, this function is a function which will return this math function type. Okay, this is a type, not a function. Okay, don't get confused. You always write type here like integer and character. Okay, so if I'm writing this math function, that means it is a type, and we are defining a type like this using type def. And the syntax to define a function pointer as a type is this. Okay, I know this is a little bit hard to understand, but once you will practice 2-3 times, like pass some function and return some function and try to do all those things what I taught you here, it will be a little easier for you to remember all these things. Okay, so we have seen how to return a function pointer. Now there is a question which says how to use arrays of function pointers. So now I will create arrays of functions. So see, this is really very easy, right? That you are creating an array of 2 size, and the type of that array is math function, which is nothing but a function pointer, return integer, and take 2 integer as a parameter. Okay, that's why we are assigning these 2 functions of this type into the array. Okay, and this is the syntax of calling that. And yeah, this is new syntax actually. You should call it like this, and this pointer and this pointer. Okay, so let's compile this as well. There's no problem, and the same answer. Okay, now this was a very neat and clean way to create an array of function pointers, because you have this type created already using type def. What if you are not using this type def and you want to create an array which stores these 2 functions of type this? In that case, you will again do the same thing. You will wrap this, put this pointer here. Now you do integer and integer comma integer. What we did before, I told you to wrap whatever that function was when we were learning returning a function from another function. I mean, returning a function pointer from some another function. That time I told, if you're not using that type def, then you will be wrapping up your function and write the type like this. So here you wrapped up your array with this pointer sign and return type like this. Okay, and now we're good to go. Let's compile this. This is compiled and running. It is working. Okay, so now you're not using this type def thing and all that, but I would recommend using that because that gives a code readability. This is so much confusing, right? So we have seen how to create an array of function pointers, okay, like this. Now let's look at the next question here, and that question is where to use function pointers. This is really very important question. So I have a program for that, and the best use I can say is you will pass your function's address, okay, to some another function, and there you will use this function, okay, or any function you want to use. So the best use is in C, we know there is something called qsort, which is quick sort. This is inbuilt function which will sort your array. So let's suppose you are having some array, you will pass that array inside this qsort, and this qsort will sort that array. And there are a few parameters you need to give. And lastly, you have to give the address of your function, which will compare the elements. Okay, so qsort need a function to compare two elements. Okay, so let's run this and find whether it is really working or not. So this is GCC demo, and now if you will run this, see 1 2 3 4 5. So you give this array in quicksort sorted out the elements inside that with the help of this compare function, and after that we are just simply printing the whole array. Okay, and as I told, this is making the ascending order. If you will make like this, like left hand side is less than right hand side, and then if you will return true, then this will become descending order. Let's compile this and check this again. See, first it is printing 5 4 3 2 1. Before it was 1 2 3 4 5. Okay, so we can clearly see that this is playing a major role here, but that is not the point. The point is qsort need one function as a parameter. Okay, this function is a user defined function, this compare function, because sometimes what happens, you are sorting some structure. This is integer value, so it's okay, but let's suppose you're sorting some structure or something, then in that case you will be passing two structure pointers. You will typecast that into the structure, and inside that structure there would be some field. On that basis you will be sorting that whole structure. Okay, I mean array of structures. So in that case this compare function becomes really handy. So that's the only reason this compare function is given to us. I mean, we are supposed to implement this function. The rest of the things are taken care by this qsort, but the compare thing is given to us. Okay, because our data could be anything. It could be class or anything. Okay, so to recap that, the best use is you will be passing your function according to your need. This is really very good example to understand this. Okay, so I think you got the video. If you like the video, don't forget to hit the like and subscribe button if you haven't subscribed yet. I'll see you in the next video.
Hello friends, welcome to another C++ interview question, and the question is, what is functor in C++? Notice this is functor, not a function, okay? And the answer is, it works as function and achieved by overloading this operator in some classes. Okay, we'll see that how it works. This is your class here, and you have overloaded this operator. Okay, you created this one object of this class, multiplication, and you created this object and you passed the parameter, the initial parameter you wanted to set in this. Okay, and I kept this name as multiplied by 12. Okay, so this object is set. Now this object, this particular object will work as function. Okay, so as you can see, I'm using the same object here and I'm passing 2, and second time I'm passing 3. So it is multiplying 2 with 12 and 3 with 12. So this is the logic. And what is the reason behind using this? It saves the state of the function. If you are using traditional functions, they don't have any state. You will be just passing the value and you will get the value. and some operation will happen inside that, but they don't save their state until unless you use some static variable inside that. Okay, so here it is not required to use any static variable. This is the benefit of using functor in your code. Okay, so I'll just run this code now. So as you can see, this multiplied 24 and 36. It's quite obvious. It is very self-explanatory what is happening here. Okay, it might be looking little simple that what I'm doing here, I mean whatever the functor is, but it is not that simple, guys. Okay, this is an object and working as function, and it save its state. So you have set the state initially when you was creating this function or object. Okay, so you set the state. Now you will be using that state and do whatever you want to do with that particular state. Okay, so I think I'm done here. Thanks for watching and check out my other playlists for videos like this. Bye-bye.
Hello friends, welcome to another C++ interview question, and the question is, what is this GDB and how to use to debug your C and C++ code? Okay, and I will explain few commands like next, step, continue, breakpoint, break, trace, frame and info. Okay, so there are lots of commands, but these are the basic commands. Actually, I was asked this question when I was giving interview in my time. Actually, they gave me the laptop and they wanted me to debug their code. Okay, so maybe that is not possible in these days, but still it's always good to have some extra tool in your toolbox. Okay, so let's start now. So first I will explain you this next command. So first of all, you need to compile your code. So to compile, you need to give this -g switch here. Okay, so this is your CPP. So this is how you compile if you want to debug your code. Okay, so I will just simply compile that. Now how to debug that? It is very simple. Actually, there are lots of ways. I will show you one of the ways. You just simply write this GDB and your compiled code, or you can call it exe also if you are from Windows. Okay, so we'll just simply hit that. Now you are in GDB mode. There are lots of commands. So first of all, you need to keep a single breakpoint in order to break your program first. Okay, so first we will keep this break. You can break on line number, like first your program will start running from this main. Okay, so you can keep break at 21, 22, 23, or you can just break your program with the function name also. Okay, so first I will break with this main, like main, break main. So it will tell you that okay, I'm breaking at this line 22. Okay, so it will stop here when we'll hit the run. Okay, so now you can hit the run here and your program will start running. Okay, so it has started running and it is stopping at 22. So this is what that line is. So there is another command called list, L-I-S-T, which short form is L only. So if you will press this L, you will see some of your program, like some part of your program. Okay, so as I told you that we are at this line right now. Okay, if you want to check, you can just simply check, like if you will press F, it will show you where are you right now. Okay, F stands for frame. So till now you have just started your program and reached to the first line. So there is another command called next. So this is the first command I want to show you here. So next is just enter next, then you will go to second line. Okay, so what you have done, you have initialized this main variable with 10. Now if you want to check how to check this main variable, you can just simply say that print main variable. Okay, and enter. It will tell you that okay, its value is 10. So what we have set here, 10. So this print will work. There are always short form for everything, like for print it is P only, main variable, so it will just print that only. Okay, so you no need to write this print. You can just simply type P and main variable, it will print that. And again we will press next. So yeah, there is another thing, N is short form for next. So if you will press next here, you will get the print here. Okay, like you wanted to print this main function, sorry, you wanted to print this main variable and that main variable value is 10. So that is also printed here. And right now you are at 24th line, like function 1, like this one. Okay, so if you will press next here, then you will reach to return 0, because next is for next line. Okay, so if you will press next here at this location, then you will directly go to return 0. Okay, so that we can see here, just simply, yes, see, you have reached here and this function 1 was called, function 1 is this one, and it was assigned 15 and 15 was printed, and then 20 was printed and 25 was printed. So this everything is done and at last you have reached here. But let's suppose you don't wanted that, you wanted to go inside this function 1 here. Okay, So how we will do that? So first I will quit this program again, or I can quit this, and I will just start this program again. I could have simply started from there only, but for simplicity I will start it again. So as I told, we'll keep the breakpoint here. So break main. Now we have one breakpoint. Now if you will run it, the short form for run is R. So you have run it here and you have already reached to this point. So now let's say you press this next and next. Now don't press next here. You want to go inside this function 1, then press step. Okay, so this step is like you will go inside this function 1. Okay, so the short form for step is S. If you will press S, then you will go inside this. Okay, so it is telling like now we are at function 1. Okay, and that is at 17 line, this one, and this is the statement. If you will press next, we will execute this one. Okay, so this is how it is showing. So we will press next here. So this is assigned 15. We can just simply print function 1 and variable. So it will print 15 is the value for that variable what we have just simply assigned here. Okay, so this is how you print the variable inside the functions. And let's suppose you was doing lots of this checking like print, and you forgot, okay, at what line my cursor is. You can just simply press F and enter. It will tell you I'm currently at this line. Okay, so you can just simply press next, and this line was supposed to print the value, so it has print 15. Now it is at function 2. So again you will do this step, you will go inside that function. Okay, we have reached to this function 2 here. Okay, and we have stopped here after entering into this function. So like this we go inside and inside and inside. So there is another command which is called backtracks. Okay, so if you will call backtracks, enter, it will show from where you are coming and at what point you are currently in your program. Okay, so you started from main, then from main you called another function called f1, so here, and from function 1 you called another function which is function 2. Okay, so you can see here function 2 you called here, and right now you are at function 2. Okay, so again to see where are you, you can just press F and enter. So you are at this location, you can just simply press next, and now don't press next here. If you want to go inside this function, then just type S. Okay, so now you have reached to this function 3 here. Okay, and this is the line it is stopped. So we will press next here. If you will press backtrace here, then you will see that right now we are at function 3. So you will see this one. See, you started from main, you came to function 1, function 1 called function 2, function 2 called function 3, and you are at function 3 here, and line number 9 it is showing that only. Okay, to be sure you can just print F, which is nothing but the frame, and it will show you, okay, you are at line number 1 and you are supposed to print this. Okay, if you will press next, it will print that. See, 25 is printed. It was supposed to print function 3 variable which is assigned 25 here. Okay, so till now we have seen this next step and continue. Okay, continue is something like okay, I will just simply start this program again. Let's suppose we have started this program, and if you want to see how many breakpoints you have kept, you can just simply do info B. It will show you how many breakpoints you have. So currently you are having only one breakpoint, which is this main. Okay, this info B is nothing but information about breakpoints. Okay, you can just simply delete also, like delete 1. Then this will delete the breakpoint number 1. So this is number 1. You can just simply delete that also. So if you will do again that info B, you won't see anything, no breakpoints or watch points. Okay, so anyway, we need to keep some breakpoints so that our program will stop there and we will start debugging. So keep first breakpoint at main only, like break main. We'll just simply run that and we'll reach to that breakpoint. Okay, now I wanted to show you the use of continuous command here. So what we'll do, we know function 1 is calling function 2, function 2 is calling function 3, and function 3 is the last one. Okay, so it's working like this. You directly want to go to function 3, and function 3 is like you can just simply keep the breakpoint at function 3, like B function 3, enter. So it has kept breakpoint at 8 location. So this is the starting point of your function 3. So if you will press continue now, then you will directly reach to this function 3. Okay, no need to do this next and step and all that. You can just directly reach to this point. So first we'll see where are we currently standing. So press F, which is nothing but frame. So you are standing at 22 line. So this is 22 lines, so you are currently at beginning. So if you will press C, this continuous short form is C. So if you will press C, you will directly reach to this function 3. So it is telling you we are currently at function 3, and this is the next statement you will be executing. Okay, so you can just simply press next here and next. So like this it is working. So this next is done, step is done, continue is done, run is done, breakpoint is also done, backtrace is also done. Backtrace is nothing but currently you are at F3. How you reach to this F3? Okay, from main and function 1 and function 2, and currently you are at function 3. So this is what backtrace is. You can just trace back, see where are you and from where did you came to this location. And then frame. Okay, there is something important in frame. Let's say you are at function 3. Okay, so this is number, this is your frame numbers. Okay, frame is nothing but your functions. So whenever one function is called, one stack is created, so that is simply called frame in GDBs. Okay, so this is one frame, another frame, and like this. So let's suppose currently you are at function 3, but you want to check some values of function 1 here at this point only. At this point you don't want to run this program again and reach to this function 1. At this point only you want to check what is the variable. Let's suppose this function 1 variable value at this point. Then you can just simply go to that frame by typing frame number. Like this frame number is 2. Function 1 is at frame number 2. You can just simply write F2. It will tell you you are at function 1. Okay, and now here you can just simply print function 1 variable. Okay, then you will get the output. If you would have printed that function 1 in frame number 0, which is nothing but your current position, let's go back to the frame 0, and if you will print this function 1, it will say no symbol, because this symbol is local to your function 1. Okay, so that's why you came back to function 1. Okay, this is your hierarchy. You came back in the hierarchy and you printed that. And there is one more command which is called info local. Okay, so that will print all the variables of local to that stack. So just simply local. So it will tell you that okay, function 3 variable is there and its value is 25, because currently we are at this location. Okay, so local to this function is only this variable. So I think I'm done here. Thanks for watching, and if you like the video, like and subscribe. Bye bye.
Hello friends, this is another C++ question, and this is really a very famous interview question, like what is compiler, linker and loader. Okay, so there are lots of ways to ask this same question. So I have got two diagrams. This is one diagram and this is another diagram, this one. So I'll try to explain with this diagram first, then we'll go to the next diagram. Okay, so compiler is not just one single entity. It has lots of modules inside that. Okay, so first you have written one source code. So let's suppose source code 1, 2 and 3. Let's suppose there are 3 CPP files or C files. You will feed that file into the compiler, and that compiler will create object code. Like if you are just simply compiling it, you will get .o file. Okay, so that .o file is nothing but the object of your particular file. I mean the object file, okay, of your particular source code. Like suppose if you are having this source code name like 1.cpp, then the output of this compiled version of code would be like 1.o. Okay, so this shows that this is the object file of this 1.cpp file. Okay, so once you will get that .object file, the linker comes into the picture. Linker will take all the object files along with the library files. You might be taking some libraries, like if you have included math library or some another external library, what you write here using like has include, or you link it when you are compiling. So you might have seen people linking math library like this. Like suppose if you are having some code, you can compile it like code.cpp, and here you will give lm. This L stands for library and this M is for math library. So this library you are giving it at compile time. Okay, so this library will also come into this phase. So that library will come, object files will come, linker will get all these things and will link together. Okay, and linker create executables
what you see in the AND. Let's suppose you compile this, you get some executable. That executable is the result of linker. If linker fails, you might have seen lots of errors like undefined reference. That undefined reference comes from this linker. Okay, and there is no undefined error, or everything goes well till now, till here, it will create executable. And when you run that program, when you double click that or run that program, that loader come into the picture, and this loader is not the part of your compiler or anything. This loader is the part of your operating system. In operating system, this loader will load that into your RAM and it will put into the ready queue. I will not go into the operating system much, so just try to understand. You are done with the executable. If you will run this executable, loader will load into the memory and your program will start running. So this was the first diagram. This was very basic diagram what people use. I have this another diagram also. Here you can see you have some editor or some IDE. You write source code in that. The source code is in form of .cpp and .h. That .cpp and .h goes into the pre-processing state. Okay, this pre-processing compiler and assembler and linker. From here to here we call compiler. It is really a confusing that saying these 4 stages a single compiler, and in second phase you say compiler. Okay, this is confusing enough, but this is the way it is. People get confused, but once you will get experience, you will understand what is the difference between this whole compiler and what is the difference in this one single entity of the compiler. Okay, so this comes under like lots of errors are there in program, like lexical error or semantic error. Those error comes into check with this compiler, I mean this phase. Okay, there are lexical analyzer, semantic analyzer, so those things comes under this one. If you don't know lexical analyzer and semantic analyzer and all that and tokenizer, forget about that. I will explain briefly about how the compilation goes. So you will get the preprocessor first in the phase. So it will take .cpp and .h file and it will do the pre-processing, like it will remove your comments from the code. Okay, because that comment is of no use for your operating system to understand the program. It needs only the actual program, no need of comments in that. It includes your included file, like we do this #include iostream. So this is nothing but a file. It is taking that file and pasting it here, just here. It is simply taking the content of this file and pasting here. Yes, it is total copy and paste. Okay, so once it will paste, it will move to the next thing. It will see that, okay, using namespace, okay, fine. It will go here, 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 like that. And let's suppose you are having some comment here, like I am writing main function here, then this comment will get erased. Okay, there won't be any comment after the pre-processing state. Okay, so the pre-processing state will do all these things, and it will replace the symbols also. Like if you have used any macros, it will replace all those macros at that phase. Okay, and if you don't know, I will give you a simple example in that situation. I know I'm going to make this video a little more lengthy, but it's okay. Max or add, and it can have x and y, x plus y, and let's suppose you are using that somewhere here, like and 1,2. Then we all know this thing will get replaced with x plus 1. So when this pre-processing state will over, this x plus 1 means 1 plus 2 will get returned here. Okay, so 1 plus 2, it will look like this after this phase. Okay, after this pre-processing state is finished. Okay, so once this pre-processor stage is finished, it will go to the compiler phase, and compiler phase is having tokenizer, lexical analyzer, semantic analyzer, and first of all it will convert into abstract syntax tree so that it can derive the meaning out of your code. So there are lots of phases, so I'm not going to explain the compiler. I may include in some another video, but the purpose of this video is whole phase of your compilation. So once your compiler is done and your code is okay, it will generate the assembly code. Yes, your compiler is responsible for creating assembly code out of your original code, I mean the CPP code. Once that assembly is done, it will feed that assembly into the assembler, okay, and that assembler will read that assembly and create object code, okay, and that object code will go into the linker, and some external libraries like static libraries like .lib or .a in Linux, it is .a, will go into linker, and once linker is done, it will see all the code what you have written, and if you have used some static library, it will see the library is there, definition is available, everything is fine. It will pass that and it will create the exe. So you are done with your compilation and you are ready with your executable. Now you can run it. So once you will run this exe here, it's up to you, you want to run this or not. So if you run this, the loader will come into the picture and loader load your program and any dynamic library like .so or .dll in case of Windows and .so in Linux at runtime. It will take these libraries at runtime and load it. Okay, so once everything is perfect, it will load into the operating system. So this is how this whole thing goes. And if you want to see the compiled version of this one, I can show you that. I mean the whole files like .i, .s, .o. So there is command in Linux. I don't know about the Windows what is there. It is there in Windows as well. You have to search for that. I don't know. But in Linux I know that. So we can simply go to this place. Where is this place? I don't remember that. G++, compiler, linker and loader. This double dash save temp. Okay, and you are good to go. You can just simply compile this. Oh, actually you need to give this save temp here dash. Oh, I didn't comment it out this whole thing. So we need to comment this first. Commented and do this. So if you will see here, my program name was this compiler linker loader .cpp. Okay, this is the code here, and once I did compilation with this option save temp, it will give you .i, .o, .s. Okay, so this is your object file, this is your pre-processed file, and this is your assemble file. Okay, we can open that and we can see what is this. So first we will open compiler linker loader .i. Once you will open that, you will see this whole bunch of code. It is really very big code, and you will have your whole program in the bottom. Like if you want to go into the bottom, press Shift G in this, it will go. See, this is your program and using namespace is this, and the whole content like from here to the whole top, it is coming from iostream.h. Sorry, iostream, there is no .h in that. So this whole thing is just copied and pasted here. Okay, in this file, as I said in the beginning when I was explaining. And did you notice that comment is gone? So let me check whether that comment is still there or not. Okay, yeah, even this comment is also not there. Okay, that comment is not there, no problem. I can simply write some comment and this comment will not be there. We can check that. I will just compile again with the same option and we will check that .ii file. Press Shift G, will come in the bottom, and see in between this using namespace std and the int main we have this comment also, but in this comment is not there, and even this whole comment is also gone from the bottom of your main. See, after main nothing is there. If I'll press down button, nothing is coming in this. Okay, so you can analyze the intermediate files. You can open other files also like .o file. It is not readable file actually, but this is how it looks like. Okay, and you can open that assembly file also. That is readable, but I mean you need a good knowledge about assembly. Okay, then only you can understand what is happening here. And this is your actual code, guys. This is the code. Okay, see here, I love string. This is a string part. There are lots of section in the code like text section and global section. Okay, so this is how it looks like. So I think I'm pretty much done here. So if you have any question, please ask. I'll be very happy to answer that. And maybe in future I will include much more deeper videos for this. For now, enjoy this video. Thanks for watching. I'll see you in the next video. Bye bye.
Hello friends, welcome to another interesting C++ interview question. And this is not only interesting question, this is very important question also. You can impress any interviewer by answering this question. So let's look at the question. How delete know how many objects to delete? And this is for deleting an array. So basically there are two techniques for that. First is over allocation. So if you think what you really need to remember, you need to remember this n only. Okay. What is this n? When you are going to destruct that, so you will be calling destructor on that pointer that many times and you will iterate in a loop. So this is the loop and you are calling the destructor that many times, this n time. So it's just only how to store this n and where to store that. So first is over allocation. So this code is about over allocation. I'll write another code for associative array, and this is going to be little big video. So if you want to grab your coffee or something, you can just go ahead and get that. So we'll start now. So now the question is how you will store this n. You will be over allocating how much, whatever the word size is. And the word size is generally 4 byte for 32-bit machine and 8 byte for 64-bit machine. So this is over allocation technique. You will be over allocating 4 byte to store that n here. So how it is doing that, we'll see. So whenever you will write this code, compiler will replace this one line with these many lines. So we'll understand these line by line. Okay. So what I told, we want n times base. So this is what it is, n times size of base. So this will return 4 and this is 10. So 10 into 4, 40 plus word size, and my machine is of size 32-bit. So it will be giving 4 bytes. And this is nothing but just a function call. Okay. And you are passing this argument. How much memory do you want? So if you are new, you don't understand this, then just consider this as a malloc and you are giving the size and you are typecasting it into character pointer. That's it. So how much you got by this line? I'll just write so that it will be very simple to understand this. From 0 to 43. Okay. You got this much. Okay. From 0 to 43 because you over allocated this much word size. And now you're going to place this n on this. So we'll see that is little bit tricky. You need to keep your eyes open. So what we are doing here is this temp is currently pointing to 0th location. Now we want this temp to point to 4th location by incrementing it by 4. And this temp is of character type. So it will get incremented by 4 characters. I mean the 4 bytes. Okay. So at this particular location, what address you will be holding? You will be holding something like this. Or we can say this P will be holding this address. P is going to hold 4th address. It's like 0, 1, 2, 3, 4, 5 up to 43 here. So this P is going to hold from here to here. Actually it is going to hold this one only. I mean 4 only. So this P is holding this address and this temp is holding this address. So actually this is the base address for temp and this is the base address for P. If you notice what we have done, we have typecasted from 4 to 43, which is nothing but our original array, into base pointer, and that's what we wanted. We don't want character pointer, we want base pointer. Okay, because we are converting into base, so we want base pointer. So we have converted from 4 to 43, which is nothing but 40 bytes that we want, into base pointer. So this P is nothing but our original array. Okay, and this 0 to 3 is nothing but this word size. So here we are going to place our n, this n here. Okay, so let's see how we will do that. That is also a little tricky. So this temp is nothing but this location, 0th location, okay, of that full array. So now you will typecast that temp into size t, and this size t is nothing but generally it is integer size. So, and if it is 32-bit system, it will be 4. If it is 64-bit, it is 8. So mine is 32, so it will be 4. So you are converting temp into integer and you are placing that n to that. Okay, so we have stored our n here. So this n will go to this place, 0 to 3. So we have done our job. We did copy n here, and now we are ready to use our p from 4 to 43, which is of 40 bytes. Now the only thing is left is we need to call constructor that many times, because the job of new is not just only creating memory, its job is to call the constructor also. Okay, so we'll see how it is calling the constructor in that case. So we know n times we need to call, so we are looping through and we are calling this new and we are passing the memory location, and this is what object we want to construct, and this technique is called placement new. If you don't know this, just go to my previous video, you will understand that what placement new is, and the heading of that video is what is placement new in C++, so that you will get it very easily. Okay, so I'll just roughly explain. It is nothing but you are telling I want to construct this object on this particular location. What is the general thing we do? We write like this, okay, new and base, and this is calling the kernel internally and telling I want 4 bytes of memory and I want to construct this object on that memory. So kernel is involved in that, so we don't want kernel to be involved because we have already got the memory here. Now we want to construct the object on that memory, so we'll pass like that, and if you see this p is of base type, and if you will increment by 1, then it will jump 4 bytes. So this is also done. You have called the constructor on all the location of this array. So from 0 to 9 it is holding 10 objects. So this was how you construct this array. Now we'll come to see how this delete works. So whenever you write this delete array syntax, compiler replaces that with this one. These many lines will be replaced. Okay, so let's see how this will work. You might have already noticed that we are getting n from that array, okay, by minus this word size. So why initially we did these much things? Just because we wanted to store this n somewhere in the beginning of that array. Okay, now we have to grab that n so that we can call the destructor that many times on this array. So this is where this grabbing thing is working here. So you are just getting that p, typecasting into character pointer. So whenever you will decrement it, it will decrement by byte. So this word size I told it is 4, so it will get decremented by 4 bytes. So this p was pointing here. If you see, now you are telling to point this to 0 location. So now you have n in your hand. Okay, this n is nothing but 10 here. Okay, now you will just loop through 10 times and you will call destructor in reverse order, and you are calling this destructor explicitly. If you remember, I told you that you are using placement new here. So whenever you are doing this placement new, you have to call destructor explicitly. Okay, it's your responsibility to free that memory. So this will call destructor on last element of this array, and then the second last and the third last, and it will go up to first location, and lastly we have to destruct the whole array, this array. Okay, so we are deleting that whole array by just doing this bp minus word size. So far we have seen the over allocation. Now we'll see how this associative array works. So thanks for your patience, guys. Now we'll see this associative array technique to store that n here. This whole thing is just to store this n only. Okay, just keep this in your mind, because the question is how this delete know how many objects to delete, and this is the size of array. So you just remember n only. Okay, so let's look at the associative array technique. Now you must be familiar what we are doing. So basically we are storing this n somewhere. So before we were doing over allocation, so that word size was entered in the picture, and we was incrementing that whole array by word size. Okay, and we were storing that n there. But now we'll create some array. This is that array, association array. I am not sure about the array name in the operating system, but it's something like this. So what you will do, you will simply do whatever you was supposed to do up to this place. I mean, base size is 4 and n is 10. So you will create n into size of base, 40 bytes. You won't include that word size now. Okay, and you will construct that much, and this base pointer is pointing to the first location of that array. Okay, now you created one for loop and you iterated on that for loop, and you just call this placement new, and you just give this address one by one. Okay, like 4 byte, then another 4 byte, and you constructed your object on those memories. So finally you are done with your array. Now the only thing remains is you need to store this n somewhere, so that whenever you are going to delete this, you will get that n. So what you are doing, you are inserting that pointer with n. So whenever you are going to delete this, it will search in this array where is that particular pointer stored and what is the associative number. So this becomes very much simple, but there are other problems with this technique that I won't cover here. You just need to remember there are two techniques. One is over allocation, second is associative array. So finally we have placed our pointer with that n. Now whenever we want to delete that, we'll just simply grab that value. Like this is the array, you will call the lookup function on that array, and you will pass the pointer what you want to get, and that pointer will be matched here, and that n will be returned. Okay, so that n is getting returned here, okay, by this lookup function. Now it becomes the same. You will iterate over the pointer one by one from reverse, and you will just call the destructor. Again it's Fred. So call the destructor of base. Okay, and finally once you have destructed all the objects which you constructed with this placement new on that array, you will delete that array. So you are calling that delete on that base pointer, which is nothing but the array. So that's it guys. I hope I explained well, and if you have any doubt or something, or you want to discuss this, you can just comment out. I'll be replying to that comment. Don't worry, okay? And you can just explain this to your friend. He will be very much happy to know this. Okay, so we are pretty much done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye-bye.
Hello friends, welcome to another C++ interview question, and this question is how this static variable behave in case of template classes or template functions. We all know what is the use of static variables. It is local to the scope, like you cannot access this variable outside this printf, and this will be alive throughout the program for this function. Okay, and the same is applicable for the classes also. All the objects will share the same static variable. But what if it is a template function and template class? We all know what is the meaning of templatization. Like if you will be writing it like print 1, then this whole function will get replaced with the I mean 1, which is an integer type. So this t will be replaced with integer here. Okay, and this is character, so this will get replaced with the character, this t, and this is a float value, so it will be replaced with the double. Okay, so there will be 3 printf functions after compiling this. Okay, but this static variable will be common for all those 3 functions, or will be separately available for all the different print functions. We'll see that only. The question is that only. Okay, so let's look at the function case here. We'll see the class case also. So I will just compile and check that. So this is compiled. Now we will execute this. 11, 11, 11. So what did you expected? Maybe you expected the same or different. So what is this 11, 11 and 11? So as I told, the printf is executed 3 times, but different printf were executed. Here we all know there was 3 printf instantiation. So on the basis of this call, compiler will generate 3 printf, and this printf will call integer version of the printf, where this will have like the whole thing will be like this only, but instead of t it will have integer return that. Okay, and for this x there will be some character here, and this float value there will be some double like this. Okay, and this static will be different for all the functions. Okay, it is not going to be common.
That's why it is printing 11 and 11 and 11. If it would have been common for all the functions, it would have print like 11, 12 and 13. It means this is not common, and the same case is applicable for classes also. Okay, so I'll show you the class example here. And yeah, I wanted to show you that it is really local to every function. We can do it like this. If we are going to call that integer version of function 2 times, then first time it will be 11, then 12, then 11 and 11. So let's go ahead and compile that, run that. See, 11, 12, 11, 11. Okay, so this static variable var is different for all the instantiated functions. Clear? Let's move to the class example here. I will change this t to t, this integer to t, and maybe we are good to go anywhere. This t is not there, right? So display plus, and then we are good. So let's go and check the correctness here. Yeah, it is compiling. We will run this. And it is running 1 and 1. So now it is for sure that it will be instantiated 2 times. Once this t will be integer and another time this t will be float. Okay, so this whole class will be returned 2 times with integer here and with float here, and the same case will be here for definition of this variable also. Okay, so as we can see here, this is 1 and 1. If this would have been common for all the classes, then once we incremented this variable and again we are instantiating this class, and if we are printing the same function, which we might think that okay, now it will increment by 1, so it should be 2, but it is not 2. Okay, I think you got the point here. And yeah, as I showed you, for that purpose I will create another like p1 and p1 dot print value. So we'll see that it is really the way I am telling you. See, 1 2 1. Okay, why this is 2? Because you have instantiated the same class 2 times. So now you are going to share the same static variable in case of integer. Okay, so I think we are good to go for the next video. Thanks for watching. I'll see you in the next video.
Hello friends, welcome to another C++ interview question, and this question is, what is this pointer in C++? This is very common question in C++ freshers interviews. So let's look at what is the answer for that. Okay, so the first point you can tell is like this is passed as hidden argument to non-static member functions. Okay, so what is non-static member function? This is a non-static member function. Okay, we are not writing static here. If it is written static like this, then it is a static member function. Then in that case, this pointer will not be passed to this one. Okay, but if it is non-static member function like this, then this pointer will be passed, and this is also non-static member function. This is another type of member function. This is a constant member function where you cannot change the value. Okay, if you will attempt to change this a in this function, which is this function, you will get a compiler error. Okay, so let's see how this whole thing will work. So let's suppose there is a class, this class, and this is your data, and these are the interfaces you want to use this for changing this data. Okay, and let's suppose there is a base variable b and you are setting the value, let's suppose 10. Okay, so how compiler will treat it? Like this one. So the compiler will see this line, compiler will change this line into this line. Okay, that is how your this pointer gets transferred from here to the respective function. Okay, so this is the call to your function, which is this function. Okay, so in that case, compiler has to do some modification. So when you write like this and compile your code, compiler change lots of things. Okay, so this is one of the thing. Compiler will change this into this. So like if you are calling this set value will be this set value, and your this pointer will be sent like this. Like b is having some address, your address will go here. So in order to get your this pointer, your compiler has to change this set value function also. So the compiler will change it like this one. Okay, so your set value will look something like this one. So this is how compiler will change this function. Okay, so first it will take this as a parameter. So your address of b is going as this here. Okay, and you was assigning this a, which is temporary, to this private a, which is nothing but your class data. Okay, so you was assigning like this, but compiler will change it like this one, this and your a. Okay, and then it will assign that a to this one. Okay, so the same thing will happen in this case also. Like suppose
you are passing something like, I have not taken the example of this one here, so I will just simply write in here. Let's suppose you're taking get value. In that case, compiler will change this also, like suppose you're calling this one, then compiler will change this one like this one. Okay, in this it will send address of B. Okay, and we generally keep this getters. This is like you are getting the value, so you are not supposed to change any value. So we keep this constant for two reasons, like compiler can optimize this code or whatever is written in that, because compiler know that you are not going to change anything inside that. So compiler can attempt to optimize things in this whole function. Or second thing is, you don't want accidental changes, like you are just supposed to get the value, right? You're not supposed to change anything. Suppose this is one kind of restriction. Okay, so this A is getting returned. So in this case, compiler will replace this with this one. Okay, so it is very similar, but just because of this constant in here, compiler will add one more constant, which is this one. In that case, you cannot change the value also. Okay, before this constant was just because you cannot change this pointer. Okay, this pointer is nothing but the address. You cannot change address, which means you cannot make this B point some another address. B is having its own address and you cannot change that. Okay, so that is the reason this constant is here. So this is how this whole thing works. That's why you always get this pointer in your member functions. Okay, so I think I'm done here. Thanks for watching. And guys, please follow your passion. Do at least one time in a day what you're passionate about. Okay, that would make your life so much good. Thanks for watching. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is how to assign any object, like it could be an base class object or derived class object or any object which is not primitive data type, okay, like character, integer and all that. So how would you do that? Here is an example. So let's say there is a base class and we have variable, integer variable, so this is the data member, and we have these two constructors, and this is the key to do that. Okay, so the answer to this is you need to define operator integer, okay, in your class in order to allow the conversion from class to integer. Okay, so this is the example here. You are creating this base object which is B and you are assigning 100 to that. So this assignment is happening here. Okay, this is little bit new. If you don't know, don't get confused here. I'm not doing anything special here. It is just var is equal to val. Okay, so instead of writing in this bracket, there is this new syntax. This is called initializer list. I will make video on this later. So you have initialized it. Now you want to assign object which is of base class into integer. Okay, so this is integer and you are assigning some object which is of base class. So simply if it is not there, let's say this is not there, then it won't compile. No, first I will show you the compile case. So this will compile just because of this only. Okay, so what we'll do here, we'll call this function and we'll return the value what was set by 100. Okay, so 100 will come here and we will print that. So let's go and let's go and run the code. Number 2 and this, let's see, this is 100. So we are printing temp here and it is coming 100. Let's say you are giving some value, let's say some value. Okay, then it should print that. We'll compile and it is printing that value. So as you can see, we are getting this value in temp, and this is the way to do that. And if it is not there, let's say this is not there, and you will compile, it will show you error that you cannot convert base to integer in initialization. Okay, so in order to achieve this, you need this operator int to be overloaded here. Okay, and notice this, guys, you are not returning anything like integer or something. Here you have not given any return type. And why you have not given? Because it is pretty sure that if you are assigning to integer, you will be returning integer only. Okay, so that's why you are not writing any integer here. Okay, so that's it. I'm done here. Thanks for watching, and check out my other videos so that you will get good set of questions to prepare your C++ interview. Okay, bye bye. Hello friends, welcome to another C++ interview question, and the question is how to call some function before main. There are lots of ways to do that. I'll be explaining one of the way, okay, which is very famous in C++. So this is the way you are having one main function and you want to call some function, let's say this function, before this main event start. Okay, so how to do that? So the trick is you create some class, and in that class constructor you write that function and create a global variable, because global variable is always created before main starts. Okay, so creation will cause this constructor to be called, and this constructor will end up calling this function, and you will call this function. Okay, so we'll see that. We'll compile the code, we'll run. So if you notice here, this is inside base and then inside main. Okay, I should have written like inside function. Okay, before I plan to keep this in here, later I kept it inside this. Okay, so this is the basic idea actually. See, now it is first going to inside function and then it is going to main. Okay, you are not calling function here, but still it is calling that function. Okay, so this is the trick. This is first trick. There is another trick also. So for that you need to have one static variable of class. So we will just remove this, and some static means you can just keep simply static something like integer static variable. Okay, and we all know that if we are creating some static variable here, so this is kind of declaration, we have to define it. So I'll define that. It is in base, so static variable is equal to function. So now this time, as this is static variable, it will get created first. Okay, so this will end up calling this function. Okay, because it has to be initialized first. So initialization part, I mean the value for this particular static variable is coming from this function. Okay, so I need to change this also. We have to make this integer, and we should return something like, we can return just 10. So 10 will be assigned here. Okay, so we'll just go ahead and check whether it is working or not. Yeah, it is working, and see the same. So that's it. I'm done here. Thanks for watching, and make sure you go and check out my other videos. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is how to check two different objects belonging to the same class in C++. And the answer is by using type ID. For that you need this new header type info, and I have included these two classes here. Not need to keep anything inside, so I didn't keep anything. So there are A1 and A2, B1 and B2. So if you will check this type ID of A1 and the type ID of B1, which is totally different objects here, so it will print not equal. Okay, actually this is the way to check both objects belong to the same class or not. So this will print equal because type ID of A1 will be equal to type ID of A2, because they both are from same class. And this is how we traditionally check that two objects are equal or not, so that in this case it will print not equal. So now we'll run this code and we'll check it. Now you can see this first if and else statement is printing not equal, just because type ID of A1 is not equal to type ID of B1. Okay, they both are from different class. And here type ID of A1 is equal to type ID of A2. They both are from same class A, so it is printing equal. And here A1 is not equal to A2. In this case it is printing equal, and in this case it will be printing not equal. Why? Because these two objects are totally different from each other, and this check is what class they belongs to. Okay, so they both belong to the same class, that's why it is equal. That's how we check two different objects belong to the same class or not. So I think we are done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is how to overload pre and post operator in C++. And I have taken this example. This is an integer class. This you can call a wrapper class of this primitive integer data type, and this is how I am going to explain you the question here. Okay, so in this case is pre increment case, and this is how we do post increment. Okay, so let's take an example here. You have created an object of this integer class. So this is one integer class here, and you have taken one object and you are assigning 100 into that. So this is your constructor, you are assigning 100 into that, and you have assigned
value to the element. So this is the element, this is the data member of this class, and now last you are printing that. So we'll just compile and run so we can analyze the output of this. So this is printing 100 for this. So this is quite obvious. Now we'll incorporate this post and pre-increment logic here. So I++ will do, and simultaneously we can check the value here. Like if it is post, we all know that if I will print the value at this line only, then it will not print the updated value, because this is post increment. Okay, so it will print here. Okay, so we can just compile and run for that case. So see, when you created the object, you assigned 100 in that, and you did post increment on that operator, and you print that operator at that line only, then it is giving you 100 only. Okay, and if you are printing the same I here, then it is giving you the updated value. So this is what generally happens when you use primitive data type. And we can simply check the case of pre here. So instead of this post, I can just use this pre here. So what happens when we pre-increment? When we pre-increment, data gets updated at that time only. I mean at that line only. Okay. So if we will print this one, we'll get 101. So let's compile and check that also. So see, 101 and 101. So we are printing 2 times, and this time it is giving you the updated value. So how we are achieving that? Let's try to understand. So first of all, I will tell you how the compiler differentiate whether I should call pre-increment or post-increment. So this is how it is done. If you pass an integer parameter to this operator, then it is considered as post-increment. Compiler always needs some way to discriminate whether you have done pre or post. So if it is post, then which operator should be called, because both are this plus operator. Okay, if you have written plus operator here or here, so how to differentiate, okay, which function to call? Okay, so this is one dummy variable we pass, and if you have written post, then this function will be called, and if you have written here pre-increment, then this function will be called. Okay, this function. So first we'll check the pre-increment case. So in case of pre-increment, it will take the element value and increment that and return the object, and on that same object you are calling some function which is print value. So you are printing the element of that particular object what you get here by this return. Okay, so you will be printing the updated value. As you can see, you have updated the element here. Okay, but in case of post increment, when you do this post increment, you call this one, and this is how it is achieved. Okay, so this is the way we deal with this post increment. So first we take the copy of your this operator. So here you notice there are 2 objects. Okay, first object you called, which is I. Now this is converted, I mean this you can treat as this here, and you created another object which is temporary object. So first you assign your I, which was coming from here, to this temporary. Now you are incrementing the value with the help of this plus, and you are returning temp. You are not returning this. In pre case you was returning this only, but you are returning temp here because you don't want to return the updated value. It is post increment, not the pre increment. Okay, so you will return the old value and you have updated the value also. Okay, so in this case we can see it won't get the updated value here. We can just compile and we can check. It didn't get the updated value here. Even if you incremented it, it didn't get updated here. It will always get updated here only. So this is the trick we do to achieve this post and pre increment of objects. Okay, so I'm done here. Thanks for watching, and make sure you go and check out my other videos so that you can prepare well. Thanks. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is how to print something n number of times without using loop or recursion or any iterative way. Okay, and the answer is using constructor and the array trick. Okay, so we'll see how it works. So this is your base class. There is some class you have to create, and inside constructor you just print that value. I mean whatever the value you are asked to print. Okay, so you print that value here and you create an array of that size. So
size is like if someone is asking you to print 10 times, then you just give 10. So what is happening here? It will call constructor 10 times, okay? So because it is required to create an array of base of 10 size. So this constructor should be called 10 times, okay? So that's how you end up calling this constructor 10 times and you print this bingo 10 times, okay? So in an interview, you might be asked like, you can print something without using loop or recursion n number of time, okay? So the n is defined here. So this, I could just simply write it like this. Integer n is equal to 10 here. Okay, so we'll see, it will run. Yeah, see, this bingo is coming 10 times here. Okay, so that's it. Thanks for watching, and make sure you check out my other videos so that you can prepare well. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is how to set, clear, toggle, check and change a single bit. Okay, and the answer for that is I'll be explaining one by one. So first I'll be explaining how to set one bit. Okay, so this is your number. Okay, you will be setting some bit in this number. Okay, and the bit position is this one, which means you are setting second bit. So this is 0th bit, this is first bit, and this is second bit, and this is third bit. Okay, so you will be setting second bit, which means this bit. So if you will set this bit, it will become like this after setting. Okay, so this is nothing but 7. So if we will compile and check what it will print, we'll verify that first. We'll compile and we'll check. As you can see, it is giving 7. So number is 3. You're changing the number using bitwise operator. Okay, how it is working, we'll see that. You have taken the position 2 and you are doing left shift on this 1. So 1 is having this binary representation, okay, in 4 bit. So if you will do 2 times left shift, it will go here. Okay, so this will be the result of this one. Okay, so assume you have written this one here, and now what you are doing OR operation on this number. So it is nothing but you are doing like this. Number is 3, which is 0011, and you are doing OR with 0100. So we can see it will result in 3 times 1. So instead of writing it like this, I can just simply write it little bit like this so that you will be able to understand little better. 01111. So these two ORing will result 1, these two ORing will result 1, and these two ORing will result 1. So you see, this is the result, and you have achieved 7 with this. So you already saw that the result is 7. So this is how we set some bit of this number. Okay, so now we'll unset one bit, okay, using this AND operator, and this is how we do that. Our number is as usual 3 here, and this is the bit representation for that. We are unsetting this first bit, this bit. If we will make this bit 0, it will be 1. So this is how we do that. You know, you are doing left shift to this 1. So as I already explained, you will be getting some output like this. This is the output of this particular thing, and this negation shows that you are inverting all the bits what is there. Okay, so you will invert the whole bit set here. So the result will be 1101. This is the result. And now you are doing AND operation with number. And what is our number here? Our number is 3. So take 0011. So if you do AND operation here, so the result will be something like this. AND with 100, and with 10 again 0, and with 01 again 0, and with 11 it will be 1. So you see, you have unset this bit here. Okay, so if you will unset this bit, the answer will be 1 only. We'll just go and compile and check that. See, we are getting 1 here. Okay, so this is how we do this unset bit operation. Now I'll move further. So this is the example of toggle one bit. So toggling means if it is 0, you will make 1. If it is 1, you will make 0. So this is your number as usual, and your bit position, what you are going to toggle is 0. So if you will left shift 1 by 0 time, it will end up as 1 only. Okay, so that is pretty obvious that if you will do this left shift 0 time means no time, then it will result as
this one only. We are using here XOR, and if you remember, XOR operation is if two bits are equal, it will return 0. If two bits are not equal, it will return 1. Okay, so we are doing XOR operation with number, with this number. So 0011. So as I told, XOR returns 0 in equal case. Okay, so this is equal, so it will return 0. These two are equal, it will return 0. And these two are not equal. This is 0, this is 1. So this will return 1. And again this is equal, 1 and 1. So it will return 0. So you can see you have achieved toggle bit operation, and you have toggled the 0th bit here. So you have toggled this 0th bit, which is 1, and now it has become this one. So we can just compile and check this code also. We'll compile and we'll run. So this is 2, okay, and we are getting 2 here. So this is also done. Let's move to another. Now this question is, how will you check some bit? Like what is the bit value at second position, or what is the bit value at third position or 0th position? So this is how we do that. So this is very simple thing. You will have check position like 2. You want to check the second position of this one, which is 0. So we will get 0 here. Okay, we will verify and check that. As you can see, we are getting 0 here. So how this is working? You are getting this bit position and you are doing right shift on that number by bit position. So obviously that bit will reach here. Okay, and you are doing AND with 1, which means you are extracting out that bit. So I will just explain, and I will just write like this. Like this is your number 0011. You did 2 time right shift. Okay, so the result will be 0000. This 1 will also go off. Okay, so this will be the result. Okay, and if you notice, this 0 is here now. Okay, and what you are doing AND operation with 1. So how 1 looks like? 1 look like this. Okay, and if you will do AND operation, as this all are 0, you will end up getting 0 only. Okay, so this will be the output for you. This, okay, and as you saw, we are getting 0 only. If you want to check this 0th position or 1 position, so first I will go and check the 1 position. So in that case, you should be getting 1, because at 1 position, this is 0th position, this is 1 position. So at 1th position, you are having 1. So we should get 1 here. So we'll compile and check. As you can see, we are getting 1. Okay, so this is how this checking a bit work. Let's move to another change. Now this question is, how you will change nth bit to bit value. Like you are having some bit value like 0 or 1. It cannot be anything else, because a binary is only 0 and 1. So you will be having either 0 or 1 in this bit value, and you want to change the nth position of your binary representation. Let's say you want to change the second place. Okay, so this n is 2. So you want to change this one with bit value which is 1. So this is how this will work. I'll compile and check whether it is working or not. So as you can see, if we will set 1 here, then it will become like this, and this is nothing but 7 only. Okay, so this is working correctly. Now let's see how this is working. So first of all, if you know the precedence rule, then this will get executed first. Okay, so AND operation with this one. So first I will write what this is. Okay, so this is your number. So number is nothing but 0011, and you are having this AND operation with this one, which is nothing but 1 left shift by n time. So 2 time. So it will be 001. Sorry, it will be 0100. Okay, and you are having this negation. That means you want to flip all these bits. So this will become like this. 1011. Okay, so you have flipped this bit. Now you want to do the AND operation with this one. So the result of this will be 0011. So you have got 0011 till now up to this. Okay, and now you want to do the OR operation with this one. So we'll calculate this one now here. So this is bit value. Bit value is 1. This is what bit we want to set. Okay, so we will do the left shift that many times, n time. So this is bit, and you are doing the left shift that many time. So n is 2. So you will do 2 time left shift on this bit value. So this will be like 0100. So this will be the output of this one. Okay, and as you have output for this one and this one for this one, so you will just simply do the OR operation between these two. So the OR operation between this one and this one will result into something like this. If we will do OR operation with this one, then the result will be 0 1 1 1. Okay, and 0 1 1 1 is nothing but 7. So we'll see that how it is giving you the output. So as you can see, this is giving 7. So we have achieved setting second number of bit, which is this one, with 1. Okay, you can do this experiment, like you might be willing to set this 0th position with 0. Okay, so in that case you have to keep this one as 0, and the bit value also you want to keep 0 only. Okay, so if you will make this one 0, then the whole binary representation will become 2. So we shall get 2 here. So yeah, we are getting 2 here. So this is perfect code. I'm done here. Thanks for watching, and make sure you check out my other videos so that you will get so many good videos to prepare for C++ interview. Even if you are fresher or experienced, you can check out my list. Bye bye. Hello friends, welcome to another C++ interview question. And this question is how you will stop your object being copied from here and there. Okay, so how could you do that? I mean, there are lots of ways, and those ways are like, you can use first way, second way, and third way. So I'll be explaining these 3 cases with the code here. And that situation arises like one object cannot be copied and made 2 times. Like one system would have that kind of object one only. Okay, so and best you can recall is singleton design pattern. In that you always have only one instance of that class type. Okay, so there you can use that. So let's go and check the first one. And the first one is keep the copy constructor and assignment operators private in your class. So I'll show you what is that. So this is the first way of doing that, what I was telling. You just keep the base, I mean the copy constructor and the assignment operator private in your class. Then if you will do this like b1 is equal to b2, then there is an error. We can compile this and we can check that. So g++ app.cpp will compile this. It is telling operator, I mean this assignment operator is private within this context, so you cannot copy. So this is how you can stop someone copying your object from one object to another object. Okay, you can create them, you can use them, but you cannot copy them. Okay, so that's why you have kept this into the private section. Okay, second way is inherit one dummy class which is having its private constructor and private assignment operator. So instead of messing your own class, you can inherit one class which will tell you that okay, if you are inheriting me, that means you are blocking your objects to be copied from here and there. Okay, so we'll see that what is that. So this is your second way, and what this second way tells that please create one separate class for this purpose if you don't want to mess up your own class. Okay, and this is a straightforward message also to the other developers that if you are inheriting this stop copy class, it means you don't want this base class to be copied here and there. Okay, so if someone is assigning one object from here to here, it will be an error. We can check that. So I'll just compile this code, and it is telling that use of deleted function base, and second it is telling it is private here. Okay, it is happening just because your these two functions are private here. If I will make them public like this, and if you will compile this code, now this code will compile. See, okay, so there is no problem in this code. Actually, you are just injecting the dependency here by keeping this private. Now it become dependent, like you have to call this stop copy and stop copy operator in order to achieve your base class getting copied from one object to another object. Okay, because you have inherited it, and that is the nature of inheritance, that if you are copying one object from here to there, you have to call your parent object constructor as well. So you are keeping the parent class constructor as private, so it won't allow you to copy from one object to another object. Okay, so this is the basic implementation of that. And another way of doing that is very clean method. Delete copy constructor and assignment operator from your class. It's not that delete. I'll show you what delete I am talking about. So let's go and check that also. So this is the third way. I was talking about this delete. you can just simply create your your constructor. So you can just simply assign this delete to this declaration and this will get deleted. Okay, and the same for this one. This is new in C++. We can use this also in order to avoid copying. Okay, so let's go and compile this code as well. See, it is telling use of deleted function base. Okay, so you are going to use your copy constructor which is deleted. Okay, and if you want to see this one also, I can show you that also. Let's suppose you are creating this b2 with, let's suppose, 19, and here after some code you are assigning b2 is equal to b1. Okay, now that error will change. It will ask you that now operator is also deleted. Okay, so this time you are using this operator here, okay, which is also deleted. So I'm done here. If you like the video, please hit the like button, and haven't subscribed yet, go for it for upcoming videos like this. I'll see you in the next video. Bye bye.
Hello there, this is Rupesh and watching CPP Net video series on C++ interview question, and in this question we will be learning how to stop someone from taking the address of your object. Yes, you heard that correctly. You are stopping someone from taking the address of your object. Okay, so if you have some class like this and you created the object of that like base b, and you just simply wanted to print the address of b, then you can print that. Okay, let's compile this. See, you got the address of your object. Okay, you can initialize this object address inside some pointer also, like base pointer bp is equal to address of b. Okay, and you can print that also. Both will be equal. Okay, but that's not the point. The point is how to stop someone from taking the address of your object. Okay, so first of all, you should know that the address operator is internally overloaded in your class. Okay, so even though you don't overload this address operator inside your class, C++ compilation include that inside. Okay, so whenever you create any class, the address operator gets overloaded automatically. Okay, so now we will use the same technique to achieve our goal. Okay, and first technique would be overload the address operator and keep it private. Okay, oh, not this one, we should write it like this, delete this operator. Okay, that was a typo. Now, as I said, we have two options, overload the address operator and keep it private. So let's do that. So yes, this is a base pointer operator address. We need just return this. Okay, and this is what it does. So let's compile this and check the correctness. Yes, it is working. So whenever now we are using this address operator here and here, we are ultimately calling this function. Okay, so before this function was hidden inside our class, we were not giving, then also it was including, but now in this case we are giving it. Okay, so obviously this will use this only. So let's print some message so that we can see it is really calling this function. Okay, so let's compile this. See, bingo and this address, and bingo and this address. Okay, so first you got here, then you will come and print the bingo and you will get this address. Okay, so as we can see, it is coming here. Now as I told that we will be keeping it as a private, so let's do that. So it is really very obvious that if you make it private like this, then you won't be able to call it from your main function, because main is the outside from your base class. Okay, and we cannot call private member functions from outside your class. Okay, so if you will compile this, it won't compile. See, there are lots of errors. So it is telling that base pointer operator this is private in this context. Okay, so this was the one way to stop someone taking the address of your object. Another way is you just simply delete this operator. What do I mean by that? So let's remove this private thing here, and no need to give the this part also. Delete means this. Okay, this statement tells that this is a new, it is from C++ 11. So if you will delete some function, it tells to the compiler that don't create this function, okay? And if it is going to create internally, it won't do that, okay? As I told you in the beginning that your class already has an operator overloaded inside that, even though you don't give it. But now if you are writing it like this, your compiler is not gonna create that function internally, okay? So let's compile this as well. Now it will tell that use of deleted function, okay? The same thing is happening. Now you cannot compile your code so that user won't be able to get the address of your object, okay? So if you are not getting the address of your object, this code will compile, okay? So just remove this one, and this one, and let's compile this code. See, it has compiled. So wherever this address is coming, that line will not compile, okay? So that's how we stop someone from taking the address of your object. If you are asking for the applicability of this, then I would say it depends upon your application, like what you require. Maybe you require this because you don't want someone taking the address of your object so that they can change it using the address, okay? No, you don't want that. So that's where you will use this, okay? So thanks for watching.
Hello friends, welcome to another C++ interview question. And the question is, how to stop someone inheriting from your class? Can you do that? Yes, we can do that. And the answer is, use final keyword, okay? Use only this keyword. Don't use any other tweak to achieve that, okay? Because I have seen lots of people are doing lots of other stuff. They might be correct in their way, but they were using that technique because this final keyword was not there in C++. But in C++ 11 and followed, this final keyword has come, so you should use final keyword for that purpose. And I'll show you how to use that. Let's see, this is our base class and this is our derived class. You are inheriting base class into this derived class, and this is the constructor. It is pretty much simple code here. And let's assume this final is not there in the beginning. So what you did, this is base class derived into derived class, and we'll just compile that so we can see it is working correctly. Yeah, it got compiled. Now you don't want this to happen, like you don't want anyone inheriting your base class, then just write final here. Now this base become final, you cannot inherit further, okay? So we'll see that by compiling it, and see the error here. It is saying that cannot derive from final base, okay? So that's it. You can just simply stop someone to inherit from your class. So we are done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello there. Today's topic is atoi function. So this is a function, okay? This a means ASCII, 2 means we will be converting to an integer, okay? So we will be converting ASCII to the integer, and this is a function already given in the C and C++ language. So let's see first the use of this function, then we'll go and create our own function of this type, because lots of interviewers ask you to implement atoi function, okay? So the use of this function is, it will convert your string into an integer, but that string should contain the numbers like 1, 5, 9, 0, 8, okay, like this. So this is a string. If you will convert this into integer, it will still look like 15908, but this is integer part, so you can now apply any addition, minus, multiplication and all those arithmetic operation on this, okay, because this is integer, okay? You cannot do all those things here because this is a character pointer, okay? So we want this to this. Generally we get this because when we are dealing with websites and web development cases, if you are passing something from website to your C code, everything generally comes in a string format, okay? So you have to convert it into the integer format, and you have to use that. That's where we use this atoi. That's what I can recall where I use this, okay? So this was the use of ASCII to integer function. Let's look at the code for this. So this is your code now. As you can see, we have this particular string, and yeah, I forgot to mention that string could be a minus also, okay? So this is minus 1 2 3 4, and this is a character array. We will pass that character array to my atoi function, okay? So this is the code for converting your
character pointer into the integer. Okay, so these are some variables we'll be using. So ultimately this is our result, this is our sign bit, and this is the index what we are currently pointing to that character array. Okay, so these are just simply initialization. Now let's come to this point. If your input is minus, then str's 0 position will be holding this character. Okay, so 0th location will be having this particular character. Okay, so yes, it is true. So we'll do sign is equal to -1 and we'll increment our pointer of I. So now we'll be pointing to the next location. Now I is 1 and we will start from 1 until unless we get the null. Okay, and this is a very basic technique we use to create your integer from your character pointer. Okay, the only thing you have to take care of is this one. Okay, you are taking the character and minus character 0. This is the key to convert your string into integer. Okay, so let me explain this little further. If your string is like 1, 2, 3 and at a time you will be picking 1, so this is like this, 1 minus 0. Okay, and this will produce 1 and this is an integer 1. Okay, how this is happening? Actually you are not doing this character minus, actually this 0 is 48 in the ASCII and this 1 is 49. Okay, so 49 minus 48 will result into 1. Okay, so if your 0 is a character, this 1, 2, 3, 4, 5. Okay, so this is an ASCII value, this is the character. So if you will minus 0 with any of the character, you will get that difference only. That's why we do this. Okay, so this is where the character will be and you will do the minus of 0. But don't forget, this 0 is not simple 0, this is a character 0. Okay, so if your I is 1 and your string which is passed is this one, like -1, 2, 3 and 4, then your I is pointing to this location and initially your result is 0. 0 into 10 plus stri, which is 1 minus 0 will be 0. So your result will be 1. Okay, in first case. Then we will increment our I, we'll go back inside this. Now we are pointing at 2, so it is going to be 1 into 10 plus 2. Okay, 1 is because this res is updated, right? So new value will be this one, res is equal to this one, so it is going to be 12. Okay, we do this trick so that your number will get incremented, okay, by digits. You are just including one more digit into that. Initially it was 1, okay, then it has to be 12, right? 12 is nothing but 1 into 10 plus 2. Now if it should be 1, 2, 3, then currently if it is 12, you have to multiply it by 10 to make 1, 2, 0, which is 3 digit. Now you add 3, so it will make 1, 2, 3. Okay, so this is kind of a trick we use to increase our integer by digits. Okay, and just simply this will add the number inside that and we will get our integer. Okay, and lastly we are multiplying the sign bit. I mean the sign, if it is -1, it will become minus, the result will become minus. If we didn't went inside this function, let's suppose this minus is not there, then we will not go inside this function and just simply hold 1 here, and 1 into something will result into the same number and we'll return that number. Okay, so let's quickly see the working of this one. So if this is the code, first let's compile the code. See, you have got -1, 2, 3, 4 and see, I'm printing value here. Okay, and let's suppose you are having some another string like this. We are getting into value 1 and 2 and we're just printing the addition. So it will be 5555 but -555. Okay, and if we are keeping this one as positive and this one as negative, the result would be 3087. Okay, that's it. So I think you got the point here. The main thing was just to remember, if you want to convert any character like this is a character, right? If this is a character 1, you want to convert it into integer 1, just do this minus with 0, okay? And now if you will store it in some integer I, that I will hold the integer part of 1, okay? Because we have this ASCII value like this, and we do the minus of this one with this one, we will get the difference as 1, okay? So that's the trick, and nothing more to understand this. This function and all can be implemented in any ways. We have not included any check here, like if your string what you are passing is holding some non-integer value. Maybe if your string is holding like this is like 1 to k3c, okay? So if you will try to convert this one into string, that string will not be perfect because we are having k and c here, okay? This is 3, so we have to check that also, but the main point was how to convert that, and this is the way of doing that, okay? So thanks for watching.
Hello friends, welcome to another C++ interview question, and the question is how vector works internally. So this is the code and this is our vector of integer. So first I'll be checking the size of the vector and capacity of the vector. In this case it will be 0. Now you have inserted one element to that vector, so now the size will become 1 and the capacity will become 1. Okay, so I'll just tell you what is the difference between size and the capacity here. So let's go ahead and just run that code. Now you can see in first case it printed 0 and 0, and in second case it printed 1 and 1. So what is this size and capacity? To check that, we'll do one experiment here. We'll insert one more, okay, and we'll again compile and we'll check that. So it is getting size as 2 and capacity as 2. So we are still not clear. So we'll insert one more and we'll compile and we'll check that. This time size became 3 and the capacity became 4. So how it became 4 from 2 to 4? Still not clear. So we'll insert one more element and we'll check that again. So this time it is 4 and this remain 4. So one more time we'll just insert and we'll check. So this became 5 and this became 8. Can you see any pattern in here? It is 0, 1, 2, 4, 4, 8. So if you see here, it is just getting double. Okay. So what is the magic behind that? The magic is when you insert any element in that and that element makes the size greater than the capacity, then capacity becomes double than the previous capacity. Okay. So as we can see here, initially the size was 0 and the capacity was 0. You inserted one element and you are checking that size, which is 1 and the capacity is 1. Why is this 1? Because before it was 0, capacity was 0. So you inserted 1, which make this size 1, which was greater than 0, so that capacity become double. It incremented by 1 here, but it is getting double. Okay. So when you inserted another element, which make this size 2, which is greater than capacity, so this again become double. So from 1 to 2. Now you inserted another third element which make the size 3 and then this 2 become 4. Okay. And you inserted another element which makes its size 4 and the capacity was 4. So it didn't, this capacity was 4. So it didn't increment it. Okay. The size is 4 and the capacity was 4. So no need to change the capacity. Now you inserted last time which makes this 5. The size became 5 and the capacity was 4. So you inserted more than capacity, so it will get double again. So this 4 became 8 here. Okay. This is how it works. So let's see if you will insert it one more time. So what will happen here? Now we'll run the code and we'll see. We incremented one more, so it became 6, but the capacity remains same. So what I told, when you will reach more than capacity, then only that capacity will get double. So we'll insert 3 times so that it will go beyond that. Okay. So we'll compile this again and we'll check that. Okay. So when this becomes 9, which was greater than the previous capacity of your vector, it again became double. Okay. So this is how vector works internally. It keep on incrementing the size of it. And when size reaches more than capacity, it doubles the capacity and copy all those elements which was there in the previous vector into the new vector. I don't think you might be able to understand that copying thing.
I will explain that in next video. Okay. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye. Hello friends, welcome to another interesting C++ interview question. And today's question is it possible to call constructor and destructor by yourself? What do I mean by that? Let's check this out. This is direct call to your constructor here. Okay, this is a class, base class, and this is constructor, and this is the destructor. I'm just printing that. Okay, so here you are explicitly calling that as you just normally call some other functions. So this is called to your constructor. So let's go ahead and run this. As you see here, this is base constructor called and the base destructor is called. Okay. Now you might be thinking we cannot call destructor, but I'll give you the example where you can call the destructor as well. So here we are calling destructor. See, base class is created. We are calling destructor, and yes, obviously we need some object to destruct. Okay, that's why I'm using this weird syntax. This is a temporary object here, and I am destroying that object by calling destructor on that. Okay, so I'll make this little more simpler so that you can understand it better. Let's say there is object obj, and you are calling this on this obj. Okay, so it will be a little more easier to understand. So as you can see here, constructor is called, destructor is called, and again one more destructor is called here, this one. So why 2-time destructor is being called here? And the reason is, it's the guarantee from C++ that when one object goes out of scope, its destructor will get called. Okay, so it's not compiler's issue that you are calling already a destructor so that it should not call. So this is the disaster. You should not call destructor explicitly, okay, by yourself. You should not write like this. This is danger code. Okay, you should not do it like this. There is only one reason where you will call destructor by yourself, and that is called placement new, and that is totally different topic. So I'll be covering that topic next to this video. So if you're watching today, so you have to wait for tomorrow, and if you're watching after tomorrow, so then you can just get this video. Okay, so just go ahead and check that video to get this. Okay, and there is another point. What is that explicitly calling to the constructor? What did I mean by this? This is a temporary object being created here. At the same time, it is getting destructed also. To show you that, I'll just print out something. Let's say call something here, and okay. So what do you know? If some object is get created and its scope is going out of scope, then that destructor will be called here. But if you see here, the destructor will be called just after constructor here. Okay. What is the normal case? The normal case is like this. You have created some base class object. So the constructor will be called here. Then something will be printed. And when you are going out of scope, then the destructor will call. We'll see that. See, base constructor is called, something is called, then the destructor is called. That is the guarantee of C++. But when you explicitly call that base constructor, it called destructor at the same time. Just to verify that again, we can just simply run that. Constructor is called and the destructor is called here only. That's why this something is coming after this destructor. So that's it. Bottom line is, you should not call destructor by yourself unless you are using placement new. And what is that? I'll explain you in next video. Thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye bye.
Hello friends, this is not any C or C++ interview question. This is just to inform you that whenever you want to check any optimization case, that which code will work fast and which code will work slow, you can use this website godbolt.org. So this will tell you how many assembly instructions are there for your particular code. Okay, so the idea is you can write anything like this, like integer a is equal to 10. So it will create the code for that. So it is giving you color based understanding, so that here, as you can see, this is a green color coming in background. So this particular line is generating these two assembly code, okay, and this middle one is generating only one line of the assembly code, and this last bracket is generating these three assembly code, okay, so that you can interpret which line is creating how many assembly instructions, and you can decide whether you should use something over something, okay. So this website I generally use, so thought of informing you guys also, it might be helpful for you. I'll create another video so that I can show you the best use of this website, okay. So thanks for watching, and if you really like the content, like and subscribe. Bye bye. Hello friends, welcome to another C++ interview question, and the question is how C++ achieve function overloading, okay, and the answer is name mangling. We know what is name mangling, but how internally it does we will see in the example, okay. So there are two functions, these are overloaded functions, one I'm passing integer and another I'm passing double here, and I'll just simply run the code so that we can just be sure that it is working. We'll run that. So it is the output of this, okay. So now we'll see the internal of this object. Now if you see here, you will see two definitions of print. One is appended with D here and one is appended with I here. So that's how this internally work. This is your symbol table, okay. If you don't know what compiler is and how this compiler works, then you think like you have written this here, okay. If this is integer, in case of integer you are writing here like this and this one like this, and that's how this compiler is differentiating in between these two. And in case of this double, you are simply just writing this double in that case, okay. So you're writing it like this, and in this case you're writing it like this, okay. So that's how this compiler is understanding. So in this case it is calling this one, and in this case it is calling this one, and when it is replacing when it is compiling this, okay. And one more point, it is not mangling only the overloaded function. I can show you some another example. I can just make some function like some function, and the definition, no need to keep inside anything, and we'll just compile that again and we'll check this now. So see here, what you give some function, now it has changed, it has mangled the name, like it appended the underscore z7 and appended this v in the trailing, okay. So what do you derive from this? C++ compiler changes all the function name, okay, and that is called name mangling, and that is just because to achieve the function overloading, okay. It happens in classes also. So just to show you that, I'll just create a simple base class here, ej or some. We will just compile this and we will see we must be getting somewhere obj here. No, we are not getting that. Why? Oh yes, until unless we will use this, compiler will optimize out. So we won't get that symbol table until unless we really use that. Okay, so how to use that? I'll just simply create some base b and b.obj. If we will do this, now we'll compile this, run this, we'll get this print obj here. Okay, so this is print obj, but it is changed here. Okay, you can see this is also mangled here. So the rule of thumb is C++ compiler changes all the function names inside that. Okay, and this is how it does. Okay, so this is the symbol table after compilation of this program, and this name mangling is not there in C. And to show you that example, I will create some another C file and I will show you that example. Just wait for a moment. I'll pause the video and I will write that. Okay, now I have created this C file, and now we can just simply compile this C file. If you see here this print is exactly print, and your printf is exactly printf here. Okay, so no name mangling is there in your C program. Notice here C file.c. Did you notice something, that main is not mangled in this case and your previous case when it was compiled with G++, I mean the C++, okay, main was like this only. Could you guess the reason behind that? If not, just try to remember when you were studying C and C++, there was some time when someone told that the entry point of your program is a main function. So the main function is the entry point. So if you will change the main name, then how that operating system will get to know that where is the entry point in that. Okay, so that's why we don't change this main name, and that is why the reason we don't overload this main. Okay, we cannot overload this main here. Lots of guys are there, they are saying that we can overload. They will just foolishly copy this main and put into some class, and they will overload that class, but that is a foolish thing. Okay, the point is you cannot overload this, particularly this main function. So I think I'm done here. Thanks for watching, and make sure you go and check out my playlist so that you will get videos like this. Bye bye.
Hello friends, welcome to another interesting C++ interview question, and this question is, what is object slicing in C++? Okay, so we'll see that what is object slicing. Here we are creating derived object DOBJ and base object, and we are assigning that derived object into base object. That's the simple code. Okay, and what is this derived object? It is having base object, it is inheriting base object. So here is the code. So if you see, you are copying this derived object into base object. Okay, so what exactly this base object would have the memory for? This base object will have memory for only this base variable. Here it is only having memory for base variable, but derived is having memory for both. Okay, for base variable as well as derived variable here. Okay, so if you are copying derived object, which is this one, which is having both variable inside, so it is having both variable memory, into base object, which is just simply one variable, so in that case only base variable information is being copied from this one to this one, and the derived information, which is this D variable, will not be copied here. Okay, so that's the only thing which comes under slicing, the object slicing in C++. So that is what is called object slicing in C++. Okay, you just sliced off this derived information when you are assigning that into base class. Okay, I think we are done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is good way to count number of set bits, number of ones present in binary bit in some variable using C and C++. Okay, so this is the example. There are two ways, I have included two ways only. There are lots of ways. This is the simple way. First we will see the simple way here, and the way is you will be iterating over number. So this is your number, this is I'm assigning with 7. So if you don't know, you might be knowing that this is the binary representation of this 7. Okay, there are 3 1, so we want 3 as output because we are looking for how many 1 is there in that number in this variable. Okay, so we'll loop through that number. So first of all, this number is 7, so it is not 0, so it will go inside this loop. And what we are doing later on, we are just doing the AND operation with 1, which means we are doing something like this. We have this bit representation which is 7, so this is 7 here. We will be doing AND with 1, so this is 1. So 7 AND with 1, we will end up getting 1 only. So this will be the output. So you are getting 1 as output here, and then you are adding that 1 to the count. So initially the count is 0, so it will become 1 now. Now you are doing this right shift by 1. So this number will get right shifted, so it will look something like this. After getting right shift, it will look like this. So this whole thing will get shifted right side, okay, this side, and this last bit will go off. Okay, and at 4th position 0 will come. So this is the result of this statement here. Okay, after that you will do again this checking. Is this number is 0? No, it is not 0. That means we will again come inside and you will do that operation again. What you will do? You will do the AND operation with this one. So again 1 will be the output. You can see 1 into 1, 1 will come, and 1 and 0, 0 will come, 0 0 0 0. So result will be this only. Okay, so again that 1 will get added to count. So this time it became 2. Again you will do this number with right shift, then you will get this number. Okay, you will get this number. Now again you will do the AND operation with this. So AND with 1 will produce the same output. Like if you will do the AND with this one again, then you will get the same thing. So you will again end up adding 1 to the count. So you counted up to 3 now. And now if you will do again one right shift, it will become 0. So this 1 will go off, then it will become 0, and you will come out from loop because of this condition. Okay. So if you will print, it will print 3. So we'll check that. Oh, I forget to remove this. We can just now check. Yeah, see, this count is getting as 3. This is the simple way. Okay, it will take so many iterations to complete that, but there is one good way to achieve, and that is called brain Cunningham way. Okay, and we'll see how this will work. So I have commented out everything. I'll just make sure it is working correctly. Yeah, 3. If you notice here, we are again iterating only, but this time you are going to iterate number of times 1 is present in this. Okay, so you will always be iterating that many times how many 1s are there in that number. Okay, so this number is having 7, so 7 has 4 set bits, so sorry, 3 set bits. Then this loop will iterate 3 times only. Let's say if you would have assigned 15, which makes this as 4 times 1, then this loop will go 4 times only. Okay, so this is the beauty of this. This runs very faster. There is another algorithm. There is something called table lookup, which gives you order of 1. I'm not explaining that because that is little tedious, and no one asks that table lookup technique in interviews. Okay, so I'll explain how this will work. Initially your count is 0. Now you will come inside by checking this number is non-zero. Yes, it is 7, it is non-zero. Then you will come inside and you will do AND operation of that number with the minus of itself. So how this will look like, it is looking like this: 0 1 1 1, and then AND of minus 1 will be 0 1 1 0. So this is looking like this. So if you will see here, by doing this AND operation, you will again get 6 only, like this one. Okay, so you are assigning 6 to that number. So now that number has become 6. Okay, and it will increment again, and then it will check number is non-zero. Yes, it is non-zero because it is 6. It will again come, and this time it will do something like this, like 0 1 1 0, and this time you have done minus 1, so it will cause 0 1 0 1. So this has become 5. So the answer of this one will be 1 into 0 0 0 into 1 0 1 into 1 1. So the answer will be 0 1 0 0. Okay, so this is nothing but 4 here. So now 4 will go here. You will check with the 4, and before that you will increment this count, and next time the 4 will come. So you will do this with 4 and the minus 1, which is causing it to become 3. So this is how 3 look like, and the answer to this one would be 0 0 0 0. Okay, now this time you will increment the count, which will make this count 3, and then you will come to check whether number is 0 or not. It is 0, then your for loop will terminate and you will print that. So we will see how it is printing. We have actually already saw that. So it is printing 3. So this is how we count the number of set bits in variable. I'm done here. Thanks for watching, and check out my other videos so that you will get so many interesting videos on C++. Thanks for watching. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is override keyword in C++? This keyword was not there in C++ before, and it has arrived in C++ 11 and forward. Okay, so let's see what is this override. This function fun you have overridden. Okay, so this is how we achieve polymorphism in C++. You override some function which is virtual in base. Okay, so this is one simple example of polymorphism. This is base class pointer, and it is pointing to derived class. So whenever you will call this function, then the derived class function would be called, so that we can just simply see that. And yes, don't forget to compile this code with this, okay, standard C++ 11 flag here. Okay, it is compiled, and if you run, it will run, and derived function is called. So it is printing this derived function, which means we have achieved polymorphic behavior here.
Okay, so now let's talk about override keyword here. So what is that override keyword? If you will write override here, so this is overriding and it won't change anything. It will still print the same thing. But why do we use override keyword at all then? And the reason is testing become easy with this. How testing become easy? Let's say someone is testing your code and he sees this override keyword, then he will directly get the idea that you are overriding this function. Okay, so the testing becomes easy. And the second point is compile time check can be performed. What is that compile time check? Let's suppose you was thinking that you are going to override this function and you just did like this, something like this, okay, and something like this, and you write override. So this code won't compile, and the reason is this syntax is not matching here anywhere. So let's suppose this override is not there and you will compile this code. This code will compile. See, it compiled. Okay, so you intended to override this function, but you just simply wrote some signature mismatch which resulted in not overriding. Okay, so future error could be reduced. So this error you can track in the future. Okay, so that's the simple reason behind using this override keyword. Okay, these two simple reasons. So I think we're done here. Thanks for watching and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello friends, welcome to another interesting C++ interview question. And today's question is, what is placement new in C++? Okay, and this is what I promised, that I will explain in what situation we will explicitly call the destructor. Okay, if you don't know, you just watch this video and you will get it. So I have showed two cases here. First is the normal case and second is the placement new case here. Okay, so first we'll look at the normal case. So we'll see what this simple case does. This new is internally calling kernel, which means you are shifting from user mode to kernel mode, and then kernel is searching for the available space, whatever the space you are asking for, and that kernel will return that space, and then you will construct your object on that space. Okay, this is what happening here internally. But let's suppose you know that you will be needing at least 10 dynamic objects like this. Let's say one object 1 and then object 2 and object 3. Like this you will be needing at least 10 or 100. You know that already. Okay, so is it advisable to call the kernel all the time and get the memory from the kernel? The answer is no, because switching is a costly process. Okay, from user mode to kernel mode, and kernel will again search for the optimal place where to place this 4-byte object, because there are lots of calculation involved. There is some fragmentation problem, okay, that also kernel need to handle. So lots of things are there in backend which kernel needs to handle just because of this dynamic memory allocation. And if you are doing it all the time, then it's really overkill. So what is the solution for that? The solution is placement new. What do you think you should be doing in that case? You will ask 10 times of that memory what you need. Okay, so you have asked the kernel that I want 10 times of my base. So that kernel will return around, what is the size of base? Base is having integer only, so it is only 4, and the 4 into 10, 40. So it would be something like memory is having 40-byte array. Okay, so this is a 40-byte array. You won't go and tell to the kernel that I want memory again and again and again. No, what you did, you created a pool. It's called memory pool. Okay, so you created a memory pool. Whenever you want, you will construct your object on that memory pool, and whenever you don't want that object anymore, you can just explicitly call this destructor. This is the only reason you will be implementing, or you will be calling this base destructor in your code. Okay, and it is very easy for kernel to search for 40 byte at one time instead of going 4 bytes 10 times. Okay, I think you got the point. And now I will explain you the syntax. New is taking memory. This is the memory location where you would be constructing that object. Okay, new is always two process. One is asking the memory from the kernel and constructing the object on that memory. Okay, so here also it's same only.
it will ask the kernel and will construct the object on that. Here also it is same, but instead of asking memory from the kernel, you are providing that memory here, and the object will get constructed on that. And one more thing guys, you cannot get away with construction here. You will always have to construct the object. Just only you are getting away is getting memory from the kernel. I think you got my point here. Now the only thing remains is how to destruct that. So you have taken care of constructing, so it's your sole responsibility to destruct that. So for that case only you will be using destructor here. And usually how we delete some array, this is the syntax for that. So you will you will simply destruct that main memory, what you constructed in the beginning. This is the whole idea guys. So now we'll run this code and we'll see what is happening here. Okay, compile, and now we are running. So the normal case is constructor and destructor. As you can see here, this is normal case, and here it is getting constructed and here it is getting destructed. So that's pretty simple here. And placement new case, this is your placement new case, so I'm printing it here. So basically you are constructing for 3 times. Okay, so this is that 3-time construction here, and after that you are deleting it for 3 times. So this is 3-time destructor here. So I think we are done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye bye.
Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++, and in this video we'll be learning about reinterpret cast. And this cast is used for casting one pointer data type to another pointer data type. Okay, and it is a little dangerous cast, and we'll see why. So let's read out this one. It can perform dangerous conversions because it can typecast any pointer to any another pointer. Okay, so as you can see here, there is this banana and mango, and now I'm not forcefully actually, it is just a message to the compiler that now onwards you will be treating this address as banana address and this address is mango. Okay, so it's very simple message to the compiler that please trust me what I'm doing, I know what I'm doing, so please do what I want. Okay, so it will simply convert that. So if you will compile it, let's compile this, and if you are running, see it has compiled. Okay, and if you will run this, let's run this code and don't be surprised. See, eating banana. So actually you are having mango object typecasted into banana, and now you are calling eating banana, which is this one, and it is calling. Why it is calling? The reason is whenever compiler sees, okay, you are calling some function like this one on this object, so what compiler does, compiler just simply change this line into something else, and that something else will look like this: banana, eat banana, and here the address of new banana will go. Okay, so if it is pointer, this will directly go. Okay, and let's suppose if you are passing some parameters like 1, 2, maybe it is taking some parameters here, then things would look like this, 1, 2. Okay, and now you'll be thinking that the type mismatch will come because here 3 parameters are there and here only 2 parameters will be there, like integer a, integer b. But no, whenever you are writing something like this and giving declaration and definition like this, compiler changes your classes also. So compiler will make it look like this: const banana this pointer. So do you remember you always get this pointer in your class? So this is how you get it. Okay, I mean in your functions. Okay, and this is how you get it. So I think I'm going off topic, so let's come back and remove everything. And this was the first point I wanted to discuss, and first point is it is dangerous. You can see it is dangerous. Okay, right now we are not having any data member in banana and mango, so it's okay, otherwise it will be a really dangerous task. Okay, trust me. So this is where you should not use a reinterpret cast. Okay, and I mean, obviously you should never be doing dangerous stuff in programming until unless you really know what you're doing, okay? So let's look at the second point now. Second point is really very good point. I like that point. Why we use reinterpret cast? And this is the reason for that. Let's suppose you have some class or struct in C++, doesn't matter because the only difference is public, okay? By default, struct members and inheritance are public. That's the only difference. So this is your struct. We have the values here. Now let's suppose there is an API like this, or just forget about the APIs. You can do something like this. Integer pointer p is equal to reinterpret cast into integer pointer and give the address of s. Okay, if we will compile this code is going to compile. See, so what we are actually doing is we have this s which is holding 1 2 3 4 bytes. So I'll draw a diagram for you, it will be a little easier for us. So as we know that this is a struct, this will be taking 4 bytes, this will be taking 4 bytes, and in conjunction these two will fit in 4 byte. Okay, and why 444? If you don't know what is structural padding and packing, please search in my channel, you will get that video for that, or maybe I'll include that in my description field, or you can search in YouTube. My video is only coming on the top. So let's draw this here. So we have one struct and 3 part. So this is from 0 to 3, 4 to 7 and 8 to 11. Okay, 4 bytes, 4 and 4. In first 4 byte we have x, in second 4 byte we have y, in third 4 byte, as third 4 byte is having these two and character can fit in 1 byte, so first byte of this will be a character, let's call that C here, and second byte will be boolean, so boolean, and rest of the 2 bytes will be empty. Okay, so this is how it would look like. So now come back to the code and try to print few things. Like if you will print this one p, let's see what answer you will get. You're getting 5. So what you did, you said, okay compiler, I want to treat this address as it is integer pointer. Okay, and now you're going to print that. So what ultimately it is trying to do is, this will start from here. So this is the base address, whatever the address is, let's call this a 0th address. Then this 0th address will be typecasted into integer pointer here. Okay, so if you will print that, compiler knows very well how to print a 4 byte memory. So it will come here, it will take initial 4 bytes, and whatever the value is on that 4 byte, it will just simply print here. Okay, now do one thing, you just increment it ++. Now you print, and you will not be surprised, I know, because it will print 10. So see, we had kept 5 and 10, so it is printing 10. Why it is printing 10? We know if it is integer pointer has 4 bytes, so it will be incremented by 4 byte. So before it was pointing in the beginning of p, which is nothing but s, so before it was pointing here, now it is pointing here. Okay, so that's why if you are printing after p++, it will be printing 10. So up to now it was okay, but if you will give one more increment, you will come to this position. Okay, C and B position. So if you will try to print that, you will be surprised. Let's do this p++ and this print again. See, some value. Okay, 5, 10 were okay, but 2, 6, 2, 1 is not what we wanted. So what is happening here? The thing is, your compiler is taking full 4 byte because you are taking the help of integer pointer here. See, p is integer pointer. So if you are printing p and dereferencing that, it knows it is pointing to a 4 byte memory area. So compiler is taking 4 byte, full 4 byte from here to here, and whatever the value, bit patterns like 0 1 1 0 1 0 0 1 it is getting, it will just convert that into integer and it is printing. So you end up getting this one. Now how to get that? So here comes the real beauty. You know that after this p++ you are pointing at this location, okay, the beginning of this C, okay. Now you know this initial first byte is of type character, okay. So do one thing, typecast it back to the character. So reinterpret cast char pointer and remove this one, and let's not do this, better character pointer C, and we can just print this by dereferencing this C here, okay. Now if you will run, see, you have got your A here. So this C was holding A here, we can see. Now if you want another pointer here, you have this character pointer, and if you will increase character pointer, this one, that will get incremented by 1. It means it will go to 9th position. Right now you are pointing at 8th position, 0 to 3, 4 to 7, then 8 to 12. So right now you are at 8th position. Now let's go to 9th position by just incrementing C. So C++, oh C++, and okay, wait a minute, instead of doing all these things, we can just simply use this one, reinterpret cast character pointer and ++C, okay. It will give you 1. Let's check that. It is giving you something else. Oh yeah, because that type is not character type, that is a boolean type. So let's convert that into bool type and then try to print. See, it is printing 1. So until unless we typecast it back to the actual pointer or to actual data type, you cannot use that properly, and that's what we saw here, okay. So I think I have made my points. Now let's look at the bottom lines. We always got the bottom line. Maybe I have not included everything, I don't know. If I miss something, you please comment. It will be really helpful for others, okay. So read out. Bottom lines are: the result of a reinterpret cast cannot safely be used for anything other than being cast back its original type. And we saw that here, okay. And we should be very careful when using this cast. Yeah, this is a very true statement because you might end up messing up with your stuff, okay. And if we use this type of cast, then it becomes non-portable. What is this non-portable product? Non-portable means you cannot take this project and run for any another CPU architecture, computer architecture and all that, because now here we are dealing with bit patterns. There is no abstraction between hardware and software. You are directly going to access the hardware. You are going byte by byte. See here. So if your hardware is treating differently, whatever the code you have written, your hardware can treat this differently, okay. And the difference could be, I don't know, let me tell you that. Here we are having 444. Your hardware, whatever another architecture or what you are using, that can take 4 bytes, okay. And if you wanted to access this boolean, you would have done like this, but in this case you will end up accessing some garbage value which will be coming from somewhere around here, okay. because this is X, this is Y, and here in first byte C, second byte Boolean, Boolean is not here, Boolean is here. And in our previous code like this, you were thinking Boolean is here. Okay, so mismatch happens like this in hardware side. So that's why this reinterpret cast is not good when you plan for porting your project. Okay, so we have almost completed our 4 cast, like static cast, dynamic cast, reinterpret cast, and const cast. Now I was planning to give the difference between all cast, like what is the difference between static and dynamic. So if you will know the difference, you will directly decide where to use what. Okay, but that would take a little time because that was not in my schedule. Okay, so we'll see the differences in upcoming videos. Bye bye.
Hello there, this is Rupesh and you're watching CP Peanuts video series on C++, and in this video we'll be learning about static cast. So in previous video we saw that how to use const cast and where to use and where we should not use that. And in this video we'll be learning about static cast, and I have almost 5 to 6 points here to discuss. So let's start it. So this is the first demonstration program. Here I need to uncomment that, and it tells that it performs implicit conversion between types. So implicit conversion is like what generally C++ or C compiler does when you are typecasting integer to integer to float, and float to integer, and integer to character, and character to integer. Okay, so those things comes under implicit conversions, and we should always use static cast in order to do that. Okay, so I have given this normal implicit cast and this is our static cast. Both are doing the same thing, but let's suppose your program is failing somewhere and you want to check where am I doing all those implicit cast. So searching this line in whole bunch of code is really very hard. So that's why we should use static cast in that case. So you can just search it. Okay, otherwise both will be doing the same thing. But this is explicit message that I'm using static cast, and static means this typecasting will happen at compile time. It won't go at runtime. Okay, so it will check whether I can typecast f, which is of float point, into a, which is of integer point. Okay, and I have given this comment, you read it out. Okay, so this was the first point, we should use static cast. Okay, let's go for the second point. And second point tells that use static when conversion between type is provided through either conversion operator or conversion constructor. So we'll see that here. If you don't know what is conversion operator and conversion constructor, we'll learn here. Okay, so we are having this integer class. This class is taking integer as a value. This class has an integer x as a data member, and we have this object here. These two lines are very important. Okay, here we are using a conversion operator. See, you are initializing object of type integer inside string. How is it possible? Both are not equal, right? But still, if you will compile this code, it will compile without any problem. Okay, let's check that. See, it has compiled without any problem. And why this is happening? Because we have this conversion operator here. Okay, we are initializing into a string. That's why we are having conversion operator for string. If you want to initialize your class object to something else than string, you have to provide the conversion operator for that as well. Okay, so object is being initialized to string data type. Okay, so this function is being called. We are typecasting x into string and passing, and that x is getting initialized into this one. And this is also a weird thing. This is talking about the concept called conversion constructor. The rule of conversion constructor tells that if your class has any constructor with one parameter and you are initializing the same data type parameter into the object, we will call that constructor. Okay, so let's print the message here, like what is getting called at what time. So this is conversion constructor, and next one is here this is conversion operator. Okay, so we will compile this and we'll check what is being called at what time. See, conversion operator, conversion constructor. So the first thing is conversion operator. Okay, so this was called, I told you, sorry, this one. Okay, but why we are discussing everything here? The reason is we know what will be called at what time here, but here if somebody is looking at your code, they won't be able to understand it much because they don't know what type of casting is happening. And this is a compile time casting, so you should always use static cast for that. Okay, so this first expression should look like this one, and this second expression should look like this one. Okay, ultimately this assignment is also doing the same thing what we are writing here, but we should explicitly write that. Okay, so the reviewer or somebody else is looking at your code after 10 years, they will be able to know, or even in debugging phase, it is really very important if you want to find where all those static casts are happening. Okay, so here also we should use static cast. Both the cases, conversion operator and conversion constructor. Okay, so this was our second point. Let's move to the third point. Third point tells static cast is more restrictive than C style cast. And let's see why I am telling like that. Because character pointer to integer pointer is allowed in C, but not with static cast. And this is really a very dangerous cast. If you are casting character pointer into integer pointer, it means that you have a character pointer which is pointing to 1 byte memory location, and you are typecasting that 1 byte memory location to 4 byte memory location. Now, if you will use this to write into memory, it will write 4 bytes. So that's the example here. See, we have a character C, typecasted that address into integer pointer, and you are updating that integer pointer, which is of 4 byte, with 5. So what it will do, we'll see with this diagram here. You have memory like this, and you have somewhere this address of C, which is 1 byte. Okay, now what you are doing, you're typecasting that address into integer pointer. So what this will do, it is like now you are pointing to the same memory location, but now you are having 4 bytes into your consideration. So if you will use this pointer, which is this P pointer, and initialize 5, what compiler will do, compiler will initialize 5 on all these 4 bytes. So it's like it will initialize 0000101 like this. And what you're doing here is you was allowed for this particular block, but with the help of typecasting, which is this one, you got access to the nearest bytes also, which was not allowed for you. So in this case, you might corrupt your memory, you can go to segmentation fault, lots of things are possible. But that's not the point here. The point is here C style casting. This one allows this. You should be getting error for this, right? But no, your C style casting is allowing this. But if you will use C++ style casting, this is not going to allow that. Okay, these two things are exactly equal. I mean, you're typecasting character pointer here to integer pointer, and the same thing is happening here. You're typecasting character pointer into integer pointer. Okay, but this is C style casting, this is C++ style casting, and this won't allow. I mean, this won't compile, whereas this will successfully compile. See, I have given the comment here, pass at compile time but fail at runtime. I mean, this might fail or might not fail. It depends what address it is accessing, is it allowed to access and all that. But this is a danger thing, and this is telling like it will fail compile time only. Okay, because both pointers are not compatible pointer types. Okay, so C++ cast avoid so many dangerous casting what C allows. Okay, so this was the third point. You will notice that this part was compiled See, there is no error. The error is here. Invalid static cast from character pointer to integer pointer. This one, but this one has compiled successfully. So if we will comment this part like this, and we will go again and compile that, see, it has compiled successfully. Okay? Whereas this is a big problem. So you got the proof. Now let's look at the fourth point. Fourth point tells it won't allow to typecast your derived into private base pointer. Okay? I mean, if you are using static cast, it won't allow, but if you are using again the C style casting, it will allow, and that is dangerous. I mean, that is not allowed cast, but still using C style casting you can achieve that. This is your derived class. You have inherited base as private. Okay? So let's compile this and you will get the error for that. See, base is inaccessible base of derived. Okay? Because you are having private here. If you will write public, let's write public and recompile this. See, compiled. No problem at all. So if you will write private here, this won't allow your code to compile. So this was the fourth point. Let's look at the fifth point. I hope you are not tired of looking points here. So fifth point tells that use for all upcast but never use for confused downcast. So we'll see what do I mean by that. So here in this code, we have this base class. We are initializing base into derived 1 and derived 2. So this is something like this. Base, this is D1 and this is D2. So we have these two objects, derived 1 and derived 2. Now you are typecasting derived 1 object into base base pointer 1, and same thing, derived 2 address into base pointer 2. So this is allowed because you are going from here to here, and in second case you are going from here to here. So we know that we can typecast it like this. Okay, so this is also perfect code, this is also perfect code, but the problem lies here. What you are trying to do is, after typecasting into upcast like this, you are again coming back, but while you are coming back from here to here, you are just switching. So base pointer 2, which was holding derived 2, is initialized to derived 1 pointer. Okay, see, derived 1. So now from here to you are again coming back like this and this. Now here you are initializing D2 and here you are initializing D1. Okay, so D2 is initialized inside D1 type and D1 is initialized into D2 type here. Okay, and this is compiling. So this point is not about where you should use static cast. This point is about where you should not use static cast. You should not use static cast if you don't know what your pointer is holding. So you might typecast it wrongly. Okay, so that's why I told never use for confused downcast. If you would compile this, this will compile successfully. Okay, see, and this is the problem. You can see that. So this should not happen, and you should use dynamic cast for that, and I will give a separate lecture on that. Okay, so this was fifth point. Let's look at the sixth point, and maybe that is the last point. Yeah, don't worry, you can go home, no problem. And sixth point tells that you should use static cast whenever you are casting to void pointer or from void pointer. So let's see what is that. So you got this I is equal to 10. You're typecasting address of I into void pointer. Then you should use static cast. If you are typecasting any void pointer to some another pointer like this, then also you should use static cast. Okay? Why? Because there is a predefined rule for converting anything into a void pointer, and that knows how to convert any pointer to a void pointer. Okay, because this is generic pointer, so there is a standard way of doing this, and this is obviously a compile time check, so you should use static cast. Okay, so this is also a point here, and maybe I don't have any point, so let's look at the bottom lines. Bottom line says that for compatible type conversion such as float to integer, so you should use static for this purpose. We saw this in first point. Second point is for conversion operator and conversion constructor. We saw that in second point to avoid unrelated pointer conversion. We saw this in third point where we were typecasting character pointer into integer pointer. Okay? And fourth is avoid derived to private base pointer conversion. We saw this as well. And use for all upcast but never use for confused downcast, because there is no runtime check performed for static cast conversion, because static means it will be happening at compile time. There is no runtime check here. Okay? Runtime check happens with dynamic cast. We will see that in upcoming videos. And by the time you are watching this video, maybe it is already there. So check out the description field. And sixth point is intensor are more clear in C++ style cast. And sixth is finding is easy. Like if you want to find where you are doing all static cast, you can just easily find that. But in case of C style casting, it is nearly impossible unless you are using some kind of regular expression or something to find that. And maybe you won't be able to find that. And eighth is error finding at compile time. Yeah, if you are using static cast, it means you want to check everything at compile time itself. Okay, so generally experienced people tell that this is the first cast you should always go for. If it is not compiling, then think twice and go for other cast. Okay, so I think we're done here. So let's look at the next video, which is maybe about reinterpret cast or dynamic cast. I don't know. You'll get the link in the description field. I'll see you in the next video. Bye-bye.
Hello friends, welcome to another C++ interview question, and this question is, what is structural padding and packing in C and C++? Actually, this is going to be a really very interesting topic, okay, because I have created lots of documents here just to make you a little more comfortable. Okay, so first of all, what is padding and packing? Okay, so padding is like you will be adding some extra bit to some size, and packing is like you don't want to do the padding, so you will be doing packing. Okay, instead of adding extra bit, you won't add any extra bit to the size of your class or structure and all that. Okay, so first of all, just answer me, what would be the size of this base? Let's suppose you have created this base. Just forget about all the functions and all. Just this is your base class, and let's suppose you have these 4 data members like character, integer, character. So 1 byte, 1 byte, 4 byte and 1 byte. So total 7 bytes are there. So if you will print this size of base, it should print 7, right? So let's go and check that. So if you will compile this code and run this code, oh my god, what it is printing? It is printing 12. Okay, whether it should print 7, but it is printing 12. And let's suppose I'm just copying and pasting this from here to here, and you will just recompile this again and you will run this. So this time it is giving you 8. So why it is changing like this? Like why your base size is changing? This time also it didn't give you the correct output, but it is taking a little less size. So what is this all about? Why your base is not 7 as you expected? So just to assure you that it is actually 7, we have to write something like this. And we will compile it and we'll run it. We'll see 7. Okay, so for this moment I will just comment this so that we can just understand why this is happening. Okay, so what you did, you just did the packing here. Okay, you tell to the compiler, don't do any padding here. So you just did packing. Okay, so why it is working like this? Just take an example here. Let's suppose this is your base. Okay, it is having one character, another character and integer. So it will be setting bytes like this. The memory layout will look like this. This is 1 byte. Okay, A is 1 byte, so it occupied 1 byte. So the 0th position is occupied. B is also 1 byte, so it occupied another place. After that, 2 empty space is left, and after that, it is assigning this P. Oh my god, I should have written this I here. So okay, so this I is nothing but integer, so it will take obviously 4 bytes, so that's why it is occupying 4 bytes here. But why it is having these 2 extra bytes empty here? Why it is working like that? And if you will see second case here, let's suppose you are having one character here, integer I here, and then character B here. Then what you will do? What this compiler will do? Compiler will assign first byte here. After that, it will keep 4 empty bytes, and then after that, it will assign this I. Oh my god. So instead of changing this, I will just simply change this. Okay, this P. So as you can see, this P is occupying 4 bytes as it is integer, and after that B is coming. okay, and again this 3 byte is empty. So if you will print the size of this base, it will tell you 0 to 11, 12 bytes. Okay, so this is how it works. But why it is working like this? Actually, the point is when you run your program, it gets divided into pages and it is stored in your hard disks. And when you are double clicking something like you're running your VLC player, you're running your any browser or something, it will load into the RAM. So when it is getting loaded into the RAM, it is called segments. Okay, so I will show you one process diagram here. I have kept it ready for you. So let's suppose you double click. So you created a process. So that process will first come into the waiting queue. After that it will go into the running queue. So it is running here. Okay. And when it is requiring any IO operation, it will get blocked here. After that, when that IO operation is triggered or that device is ready, you will get one interrupt and you will again start waiting and you will again go to the running state. So this is how this operating system actually works. Okay. There are lots of things, but this is the actual thing. Okay. And let's suppose your processor is of 32-bit. So have you ever imagined that why it is called 32-bit and 64-bit? It's just because 32-bit processor means it can process 32 bits altogether at once, at one clock cycle. Like if you are giving one clock to the system, it can process 32 bits. And that another 64-bit means it can process 64-bit altogether if you will give one clock to that. Okay. So that is the reason. So in that case, when it is going to process 4 bytes, the computer researchers found that if you will keep your data like this, like 7, if you will keep your data like this, it might be looking something like, I will just copy and paste this situation here, and I will just simply remove this too. Okay, so in our thinking, it should look like this. But what your processor read? It read 4 bytes altogether. So processor will take first 4 bytes, okay, and it will read. So when this 4 byte has gone to the processor, it can read A and B without any problem. But let's suppose you want to read I, okay, which is this I, these 4. So in that situation, processor has to read this portion to get these 2 bytes of I, and after that processor has to read this 2. Okay, so that's why there are 2 read, okay, to the memory. So that's why it is a big penalty. So just to remove that penalty, we pad the extra bytes. Okay, so now let's see if this is the situation here and you want to access A or B or something. These first 4 bytes will go to the processor. Processor will read A and B without any problem. Just need a shifting here. Okay, and if suppose processor want to read I, processor will read another segment or page. Okay, so we divide whole memory into segments. Okay, so if it is stored at hard disk, it is called pages. If it is brought to the memory, it is called segments. Okay, so that is the only difference. And we do paging concept, and that paging help you to map pages to the segment. Okay, because your processor always generate logical address, not the physical address. Okay, it doesn't know about your RAM. It asks the logical address. Okay, so this is how it works. I mean, if you are not good in operating system, you might find it little difficult to understand. But in just simple way, you need to understand one thing. Processor will read 4 byte. Okay, if it is 32-bit, just remember that. If it is 32-bit, it will read 4 byte. Okay, and you cannot tell like why it is not reading from here. Okay, no, this when the pages were created, it was created like this. First, these 4 byte went to one page. Okay, or one word size, that is also a proper terminology. And another 4 bytes, let's suppose here it will do the padding actually. Okay, then another will go to another page. Okay, or another word. I think I should use the word here. So this is one word and this one is another word. So you cannot say why it is not reading from here. No, processor doesn't have that advantage. But nowadays processor does have that advantage. Nowadays scientists and processor creators are telling that there is no penalty even if you don't pad any extra byte, but I'm not that sure about that, but I have read that article somewhere, so I'm just telling you that. Okay, just keep that in your mind. And there is a rule. Let's understand the rule. Okay, so how data gets memory slot? This is the rule for that. 1 byte can go and can be stored at multiple of 1 memory slot. So what do I mean by that? So let's suppose there is a memory slot. It starts from 0 and 1 and 2 and 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so this 1 can go anywhere because 1 is the multiple of all. So 1 can go anywhere, but 2 can go at multiple of 2 only. So it can go at 0th location, at 4th location, at 6th location. 2 cannot go at first location. Okay, so that is the memory mapping work. Okay, if the size of your data type is 2 byte, it will never go to first byte position. That is how the memory optimization and all these algorithm and all those stuff work internally. So if it is 4 byte, it will go multiple of 4, like it can go to 0th location. So if it is going at 0th location, that means it is occupying from 0 to 3. So that's why it is requiring multiple of 4. Okay, from 0 to 3. And then if it is already occupied, like from 0 to 3, suppose this 1 was already occupied, then it will never take 1, 2, 3. No, it will search for 4. So 4, but still it should get consecutive 4 empty space to get into this slot. Okay, so this is how things work. And in case of 8 byte, it will always check consecutive 8 empty bytes, but that should be multiple of 8. Like it should be starting from 0th position or from the 8th position. It will never go to either of 1 to 7. Okay, so this is how things work. So am I left with something? One word is 4 byte in 32-bit processor and one word is 8 byte in 64-bit processor. So that I already explained you. Word is nothing but pages, and I can explain you or just leave it. No need to go into that deep because otherwise I will become operating system teacher here. For now, you just understand this much only, that padding gives boost to your program. Like it will get read by 4 byte, 4 byte, 4 byte if it is 32-bit processor. Okay, so first 4 byte will go like this. And yeah, one more thing I wanted to tell you. If it is like this, then 0th byte will get A here, first byte will get B here, second byte will get C here, and another time that third byte will get padding. Okay, so here you will get one padding, and after that this integer is going to get 4 byte. So it will be like total 8 byte. So that we can just simply check here by compiling. Okay, we will compile this. Oh, what am I missing in here? Define constant. What is this? Am I doing something? Okay. I will just remove this. We will go up. I will compile. Check. Yeah, 8. Why it is 8? I already told. This is first byte, second byte, third byte. 4th byte is padded, and now this is starting from the 5th. I mean the 4th byte because the indexing starts from the 0. Okay, so it will look something like this. A is at 0 position, B is at first position, is at second position, and there is one padding, and then third is coming. Third is padded. Okay, and then I is at 4, 5, 6, and 7. Okay, so I. So this is like this. But let's suppose if you will remove these two, like B and C, then how it will be? It is not going to look like this. Okay, it is not going to look like this. It is going to look like this. Why? Because it pads multiple of the maximum available data type here. Okay, so I will just give you the example here. I will just simply remove this. And what do you think? What it should be? Like before it was having B and C here, like B and C. So if you will remove this B and C from this place, then it won't be looking like this. Why? Because I will just simply compile. Oh my god, I always mess up things. And then we'll just simply compile. Check. 8 again. Even if you remove B and C, it is not changing. It is again, it was 8 and it is again 8. Okay. So what is this? Why it is not changing? The reason is that only.
what I told you there. Like this is a 4-byte data type, this is a 1-byte data type. So this 1-byte data type already occupied the 0th place. Now this 4-byte data type will look for 4 consecutive byte, so it will start looking from here, but it will not get. So as it is 4-byte data type, it will get stored multiple at 4. Okay, so that's why it is starting from 4 here. That's why it is having this size 8. So let's suppose if you are using some sort or something like sort. In that case, what should happen? Like sort is of 2 byte. Okay, so in that situation, it would be like this, only 4. Because sort is 2, so what did I said? If it is 2 here, then it will look for the multiple of 2. So what do you mean by multiple of 2 here? Multiple of 2 is 0 position. 0 is already occupied by A. 1 is not the multiple of 2. So this 2 is the multiple of 2, and 2 and 3 was empty, so it will occupy that size. So the size would be these 4 bytes. So that we can see here. I'll just simply compile. No, before that, I always forget this one. I'll just simply compile fast 4. Okay. Now I think I made my point, guys. Oh, is there anything left? I don't remember. Yeah. And even if you are interested to remove this one, okay, remove this extra padding, you are just going to use this pragma pack here. Okay, compile and check. See, now you are having 3. So 1 and 3. You are saving so much of memory, but it might give you a big penalty. Okay, but researchers claim that now there is no need of doing that extra padding, but still you should know this concept to answer to your interviewer. That's why I'm explaining this. Okay, so I think I'm done here. Thanks for watching. Bye bye.
Hello friend, this is Rupesh and I'm watching CPP Nuts video series on C++, and today's topic is structural padding part 2. So yeah, there is a part 1 of this particular topic, and if you don't know what is that, what is structural padding, please go ahead and watch that video first, because we are going to discuss little advanced point with respect to structural padding. So if you don't know what is structural padding, or you have only heard about it and have few knowledge, I would recommend please watch that video. You will be getting that link somewhere here, I guess. So please watch that video first, then you come and watch this one. So if you have watched that video, let's start this video. So for this, I need some struct and A here. Here we will give integer x and double D, and we need another struct. Let's make it B, and we will make it integer y and a here. So this is very important part. We are taking this A as a data member inside this B, and yeah, you might have guessed it. What I'm going to ask you now is the size of B here. Can you guess it? What is going to be size of B? Think about it. Pause the video and think about it. So I assume you have paused the video and come up with some answer. So let's compile this and check the output for this. 24. Why is it so? Let's check that. But before that, let's see what you might have thought. So it is very easy to guess the size of this A here. This is going to be 4 and this is going to be 8 byte, but structural padding doesn't work like this. So structural padding will see that, okay, what is the biggest size among these two? Double means 8. So it will create, let's suppose this is the memory slot, and it will create, let's suppose 8 byte, and try to place this integer x inside that. So this integer x will occupy only 4 bytes, and remaining 4 bytes will be wasted, and after that this double D will come, so another 8 byte. So these two data types will result into 8 plus 8, 16 bytes. So the result of this one should be 16. Okay, it will search for the bigger one, which is double here, and then it will create block multiple of that. So it created block of 8 and it entered this x inside that, and then it will try to fix this 8 inside this remaining 4, but it cannot fix that. That's why it will allocate another block, and then this D will come here. Okay, actually
this 8 can start at memory location which is multiple of 8. So if you will divide this full memory from 0 to 7 here, so which is total 8, and then from 8 to 15. So as you can see that this D will start from the memory address which is multiple of 8. So this 8 is of multiple 8 of 8. Okay, so it will start from here. This is another way to remember this. And these things I have explained in my previous video. I mean first part. And I have given so much of extra points related to this. Okay, so now let's come to this structure B. So as you can see that we have this integer which will take 4 and this A which is of size 16. So it is 16. And as I said, here it saw the biggest data type which was 8. So it started creating multiple of 8. Okay. But if you will see here, according to that statement, it should start creating multiple of 16 bytes. I mean, the first block should be of 0 to 15, but it is not like that. Don't miss this part. Okay. I'm discussing the false case here. It won't create 0 to 15. I mean, the first block of size 16 and place this 4 here. And I mean this Y here and some space will go wasted and then this A will come here. No. This is not going to be like this. So let's discuss the actual thing here. The actual thing is this structure B will try to open this structure A here itself. What do I mean by opening it? It will check which is the biggest data member inside A, which is happen to be double here, which is of 8 bytes. So again it will create 8 byte block, not 16 byte block. I guess you are following me. So let's suppose this is 0 to 7, 8 bytes, and it will try to place this Y. So Y will come here and this much of memory will go waste. You got this point, right? When there is a situation like this, one structure is inside another structure, then how to get the size? It will try to go to structure A and it will find that which is the biggest data member. Here it is 8 byte, I mean which is double. So it will allocate 8 byte block first and place this one inside that, and remaining place will go waste, and then it will place this 16. So from 8 it should be 23. Okay, so this A will come inside this. So 0 to 23 it is 24. That's why we got 24 there. And this is how it works. And you might think, what if here I'm having another integer, let's suppose K. Then as I said, if suppose there is some integer K after this integer Y, then what should be the size of this B here? It should be 24 only, because as I said, it will try to open A and it will find that 8, I mean the biggest element, and that is 8. So here it will first allocate 8 byte and try to fix Y inside that. So Y will take only 4 byte, remaining 4 byte will go for K. So K will come here and then A will come here. So now there is no wastage. If you want to see that, let's see that. I will place one integer K here and let's compile and check. See, it is still 24. But wait a minute. What if you place this one here instead of like that? What if you place it like this? Then what would be the size of this one? I'll tell you, the size is going to be 32. Let me compile that. See, it is 32. Now I will explain why it is 32. Be ready for that. So let's assume that we have integer X and then this A and then integer Y. Then why it is 32? As I said, there is this a here, so it will try to open this and we will get 8. So it will create multiple of 8 blocks. So first it will go and allocate the memory. It will create 8 block. So 0 to 8, and it will try to accommodate this x inside that, which will come in half because this integer is of 4 bytes. So x will come here. Now, as I said, this a is of 16 byte. It cannot come inside this remaining 4 byte. So we have to create another block of 16 bytes. Sorry, it should not be 0 to 8. It should be 0 to 7. You might be shouting there, but I was not listening. Sorry. So it is 23. So from 8 to 23, we'll have a here. Okay. Now we will have this integer y. So we have another 8 byte for this y here. And half will go waste. Why we are creating multiple of 8? Because we have this a here and this is the biggest data member inside a. So you might have got the answer for your question, why having the similar data members suddenly increased your structure size. So if you will have the same data structure, integer x and integer y and a, then this will result into 24 and the same data members, but if you have changed the places, it will result into 32. So place is really very important when you are creating any class or structure, and how you're managing your data members inside that. I mean, how you're placing them. It should be in sorted order. Okay. So you might be thinking why I'm uploading this video after 2 months. So actually I have a reason for that, and I wanted to show you that reason. So let's see that. Actually, my brother has also come into this YouTube stuff, and where is that? I wanted to show you his channel, and I am doing a free advertising, Bot King. Actually, he is a gamer. He likes to play games, and currently he is playing game only. And he used to play PUBG too much. So there he is. Maybe he died in this game and he's watching his friend playing that. So his channel name is Bot King. If you like to watch PUBG game in your free time, please try to support this channel. He plays really well. Actually, he plays very quick. So I like that part. And I was also a gamer when I was in BTech. So again, guys, if you watch PUBG videos in your free time, please consider watching this channel's video. The channel name is again Bot King. Okay, this is the channel name. So thanks for watching this video. And if you have any doubt, please comment. I'll be very happy to answer your questions. Thanks for watching. Bye-bye. See you in the next videos.
Hello friends. Let's look at another question in C++, that what is the difference between enum classes and the traditional enum what we used to use long back. Okay, nowadays also people are using this enum, but there is a significant difference between these two. So I have brought that difference here, and I'll be talking about few differences. Actually, there are lots of differences here, and lots of minor differences which you are not really need to know. And so this is the basic difference between enum classes and the simple enum. Like in simple enum, you write straight away that you will be using this red. Okay, so if you are initializing this red to this C1, then this C1 is nothing but 0 and this red will be printed. Okay, but here in class enum, you have to use this scope resolution in order to access that red. Okay, this is the way we declare the enum classes, and to access any of this red, green or blue, you have to have this scope resolution operator. Okay, then only you can use it. And wherever you want to use, like C2 will be red again of enum class, and if you want to use it like this, you have to use again with the scope only. Okay, before it was not needed, but this is a good thing, guys, that keeping this in the scope. I'll tell you why. So first problem is this one is without scope.
So what problem comes? Let's suppose you want to create some variable and you want to give that variable name like green, like integer green is equal to 100. You won't be able to do this. I'll compile this code and we'll see that. So g++ app.cpp. See here, it is telling integer green redeclared as different kind of symbol. It means this is a symbol which you cannot redeclare. Okay, so that was the problem. This green between these red and blue is having full scope, this whole scope. Okay, but this green is not having full scope. Let's suppose if I will comment this whole code, let's suppose this whole code is not there, and we will use this green, and I will compile this, it will work. See, it is working. And if I will execute it, this will execute with red. Don't think like I was writing it after this whole statement, that's why it was giving you the error. I know people might think like that also. So I'll just paste it here, compile it again. It is compiling and it is running successfully. So it means there is no problem, because this green you cannot access naked like how this red you was using. Okay, I think you would have got this difference. Now there is another difference. Two same red or green or blue was not allowed. Like suppose today you created this enum. Let's suppose tomorrow you came and you thought, okay, let's create another enum. There what I will do, I will create another set of class where I will include this black also. Okay, and that I can just this is color 1, this is color 2, I can tell this color 3. Okay, and we are good to go. No, we are not good to go, just because I'll show you that it will tell you red, green and blue redeclaration. Okay, you are going to redeclare red, green and blue here because its scope is all over the place here, in this main. And you cannot have another red, another green, another blue, like exactly the same way as you cannot have another Rupesh variable once you have already created Rupesh variable. Okay, it's like this. Once you created Rupesh variable in this full scope, you won't be able to create another variable with the same name. Okay, so this is what's happening here. So this was also not allowed, but this is allowed in enum classes. Yes, you can do that. I'll show you that. Enum class, and now if we will compile it, it will compile. See, it compiled. I'll clear the mess. We'll compile it. It compiled. Now we can just simply run that. Red and red. One red is coming from here and another red is coming from here. So that was the second difference. Actually, they have created this class enum to overcome all those stuff what they realize in the face of this whole journey of C++ development. So developers have resolved lots of the issues which was there in the older C++. Okay, and there is another difference, last difference. What I think should be discussed here is this was converted into integral types, like this is 0, this is 1, this is 2. But in case of enum, this is not integral type. Okay, you cannot implicitly convert into integrals. I'll tell you what difference it makes. Okay, so for that I need to create one function here. So that function we can create is something like function which will be taking integer. Okay, and I can use this whole thing. Now you see this function is taking integer, right? But you can pass something else like red here. Okay, another and something called 1 here. So see, the same function is taking integer, green, red. I mean, this is of color type, right? And this is of integer type. Why it is taking these two different types? Just because we can convert this type into integral type. This is by default 0 here. This is 0, and the rule is you will be keep on incrementing by 1. So this green become 1 and this blue become 2. Okay, so that's why this whole thing is working. So if I will pass this 0 here and 1 here and 2 here, it is going to print red, green and blue. We'll see that. Compile, successfully run green and blue. Okay, so this is going to work. It should not work because it creates confusion. So that's why enum classes were created. If I will write just class here, so we are done. Now we'll see that. what the error is? Could not convert red from color 1 to integer. Okay, it means this cannot be compared with C. And what is this C? C is an integer type. So now you don't have any comparison between red of enum type to some integer. Okay, so this is a clear code. Now if you want this to work, you have to have your color 1 here and you have to pass red, green and blue here. So we'll see that if you will just simply change color 1 here, is it going to work? No, it is not going to work. See, again the same error. But if you will keep it like this, now this whole code will work. We'll compile this. See, it compiled. If you will run this, red, green and blue. So now there is no confusion. You are passing color 1 type, you are getting color 1, you are comparing color 1 type with color 1. Okay, so everything is neat and clear. There is no confusion. And I will tell you one more problem here. Let's suppose this is color. Okay, this is color 1. Let's just remove the color name like color 1 null. And I will remove this function also. There is no need of this. Let's suppose there are two classes. Okay, I don't want to use this class. I'm going to explain you the another problem with this enum is this is color and this is people, and here we will write anything like good, bad. So where enum is color, another enum is people. So I can write something like this. Okay, and if we will compile this code is going to work. See, red and good are equal. Can a red and good be equal? No, it is not possible. But see, it is working and it is true. Why? Just because this is 0th position, so that's why it converted into 0, and this is also 0th position of another enum, that's why this is also converted into 0. So 0 equal to 0, yes, it is true, and it came into this if, okay, which is logically incorrect. Okay, so this kind of things also create lots of confusion when you work on bigger projects. You should not create things which might create confusion in the future. And yeah, see, if you put equal in between color and people, like if you are using this class here and class here, then can you compare these two? Because if it is class, now you have to write this color here and people here. Okay, you cannot compare it these two like this. Why? Because it is obvious that one part of this is color, another part of this is people. How these different parts could be equal? There is no possibility at all. That's why this operator is not available in between these two. Okay, so if I will compile this, you will see that there is an error. See this error. Okay, it is not available. So I think I have explained all the differences what I wanted to discuss here. So let's move to the next video now, and I hope you enjoyed. Hello friends, welcome to another C++ interview question, or maybe it's not an interview question, but actually I generally create videos for clearing the doubts of the viewer. Okay, so maybe it's not a good interview question, that how would you return more than one value from a function? So as you can see here, there is one values variable v, and it is taking whatever is coming from here, and I'm passing true and false, and this is how we get it, and the output would exactly look what you are expecting here. So let's look at the output now. So this is compiled version of the code, and yeah, the answer is 1x, y, rupesh and all that. Okay, this is okay. This is how we do this. But I wanted to show you this tuple thing. This is totally new. So let's look at the second one. So this is the second example. Here you don't need any structure or class or anything in order to return multiple values from a function. This is the function. Actually everything is just same. Actually three things are new here. This tuple type, this make tuple function, and this tie. Okay, and I could have used that get function also. So okay, no problem, we'll use that also. After showing this example, I will show you another way of doing the same thing.
Okay, so for now you understand, you are calling this function with this true is coming here, you are making this flag true, this will get executed, it will create tuple of 1, X and Rupesh. This tuple is of this type, so we are happily returning this whole tuple into this tie num code and name. How beautiful it is. Like first value is some integer, so this is num, which is integer, code is character and name is string. So yes, you can do this. It can directly bind the variable with the return values. Okay, and you can just simply print those values and it will print that. So we can go ahead and compile this code. It compiled successfully and run. Yeah, so it is exactly the similar what we were doing with the help of structure. Okay, this was the output of structure and this is the output of this tuple. But if you recall structure, you had to do few things. So this is the example that okay, I will comment. Okay, I'll just remove this comment here. See, you had to take this values variable, you have to access them with the help of this dot operator. Okay, but here you are not supposed to do anything like that. We are just simply binding these values and you are good to go. Okay, this is, you can say, a fancy way of doing the same thing what we were doing traditionally in older C++. Okay, and this is possible because of this tie only. And there is another way of doing the same thing here. So to show you that, I'll have to write some another bunch of code here. So no problem, I'll write that. Let's suppose you are getting this function like auto and some v and this function, and you are returning it like this. So this auto will get replaced with this type, whatever the type of this return type this function is. Okay, so no need to panic. If you don't know, you can search in my video series, you will get what is this auto and how to use this. Okay, or I will give you the link in the description field. So we are done here. Now we want to initialize this num with v dot get 0th location of, no, it is not like this, it is std get 0th location of v. It works like this. Okay, code is equal to std get, I'll just remove this and we can check whether it is working or not. Okay, you can see, we'll run this, it will run 1x Rupesh. Okay, so this is also one of the way to get the values from this v. Okay, and this v is of type auto, I mean this one. So we can just simply replace this whole thing here. Don't get confused with this auto man. Okay, we can compile this again, we'll run this, the same thing. Okay, so I'll better keep this auto only because it is nicely looking code, otherwise you can see that it is looking like, wow, what is this whole thing. This is very simple. Okay, and we must use this one. So I think I'm done here. Let's look at the next video, and if you like the video, don't forget to hit the like button. I'll see you in the next video.
Hello friends, welcome to another C++ interesting interview question. And this question is, why we need virtual destructor? So we'll see so this is your base class, this is your derived class, you have derived this base class into this one, and this function is virtual function. So this is where this polymorphism come. Okay, what do I mean by polymorphism here is, if you are having base class pointer and it is pointing to base class, then the function, what this function is, will be called of base class. Okay, this function will be called. And if the same base class pointer is pointing to derived class, then the function would be called on derived class. Okay, so we'll see that, we'll compile this code and we'll see that it will work. It compiled, now we'll run. So as you can see, the base class function is called and the derived class function is called. So how it is calling? This B1 is holding base and this B2 is holding derived class. So it's pretty obvious that it should be calling function which is in derived class. So that's what we have achieved here. Okay, so the base function and derived function it's called. Okay, till now no problem. But the problem is this: if you will delete B1 as it is a pointer, so you need to delete that. We'll compile this code again and we will run that. See, so as you can see here, base function is called, derived function is called. So till now it is okay.
But here you can see base destructor is called 2 times. So why it is calling 2 times? Because this base is calling the destructor on the basis of what is the type of this variable, and its type is base. In both the cases it is base. It is not calling on the basis of what type of object it is holding. Okay, so we want that behavior. To enable that behavior only, we make virtual destructors. Okay, so if we'll make this destructor virtual, so in that case it will call derived class. Now you can see base function is called, derived function is called, now base destructor is called, derived destructor is called, and then again base destructor is called. So now you will be thinking why 2 times it is being called. So if you don't know, I'll tell you. If you remember how the constructors are being called, constructors are being called in reverse order. So if you are constructing this base, then the base constructor will be called. But if you are constructing derived, then it will go to derived constructor and it won't construct that object that time. First it will call base constructor. So in that case it is like that. So I'll just simply implement that so that you will get the better idea here. So let's look at the output here. This base is created here. Okay, this is for that message. Now you are going to construct derived here. Okay, so instead of calling derived constructor first, it will call base constructor first. Okay, so the base constructor is called, and then after that it will come back and it will call derived constructor. So it's like that. So the rule is first you create your parent's object and then you create your own object. Up to this it is clear. Now we have this function calling here. Base function is called and derived function is called. So it's pretty obvious that B1 is holding base, so it will call base function here, and B2 is holding derived, so it will call derived function. Okay, till now it is clear. Till this place it is clear. Now base destructor is there. When this base destructor is calling here B1, so you can see B1 is holding base, so obviously we want base destructor to be called. Okay, so you can see here base destructor is called. Now you want to call derived destructor. Okay, if you are deleting this B2 which is holding derived 2, so in that case you wanted derived destructor to be called, and that you have achieved here. Derived destructor is called. And why this base destructor is called? Because if you remember, to construct this in the first place you had called base first and then derived, but when you destruct that object it reversed. It reversed means it called derived destructor, then it called base destructor. We wanted to achieve this only, so we have achieved this by the help of virtual destructor here. Okay, so the bottom line is why we need virtual destructor, this base destructor to be virtual, just because whenever base is holding its children, it should always call the children's destructor, because it is holding this object, not the base object. Okay, so it is pretty obvious that you should be calling destructor of derived class, not the base class. So if this is not there, then we already saw what is happening here. It is calling 2 times base destructor, but this destructor should be of derived class. Okay, when this B2 is holding derived class. So this is the problem here. There is a memory leak in this program. So to solve that problem, we do like this. So I think I'm done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, and this question is, what are all those possible places where you will use initializer list? So I will be bringing around 5 to 6 possible cases where you have to use initializer list, otherwise your code won't work. Okay, so these are the places where you have to use that, and there could be other places also, and if you know that, please comment out. So first case is whenever you want to initialize a non-static constant data member of your class from outside like this, okay, then in that case you have to use this initializer list, otherwise you cannot initialize this constant data member here. Okay, so we will go ahead and compile this. Compile. If we will run this, it will run successfully. I am not printing anything. It's okay, you can do that. But let's suppose you are not using this initializer list, you are going to initialize it inside, like _x is equal to x. What generally we tend to do,
okay, and remove this one also, and underscore x is equal to 0. Okay, so this is how we generally do. So if you will compile this code now, there is this error. You cannot assign the read-only member like this. Okay, so there is the only way to initialize that read-only member. Okay, and that's this initializer list. And I will just simply give a print method so that you can be sure about that. Yeah, this is the exact thing what you're looking here. So we can here give some b.print and expect it to print that b, and for b1 print, and that's it. We'll go compile this, run this, set 10 and 12. So this is for 10 and this is 10. Okay, so first point is you cannot initialize non-static constant data member without initializer list. Okay, so this was the first point. Now we'll go for the second point. Now the second point is this: if you want to initialize some reference variable, there is some variable, say integer variable, and that variable is of reference type, then you cannot initialize it without using initializer list. I mean, you cannot do it like this. I will show you all the things, don't worry. So first we should have compiled it like that and see whether it is working or not. Okay, so I will just revert these changes. So let's go and check whether it is compiling or not. So we'll compile this, it is compiling, run 10 and 20. Okay, so the same thing is there. I mean, I have not changed the code much, that's why it is giving as the previous output. So 10 and 20. If I will remove this for your clarification, x is equal to x, this is not going to work. Let's compile this and check. This is an error. Okay, and yeah, if you will do it like that, then there is no error. Compile, run 10 and 12. So the second point is you cannot initialize reference data member from outside of your class. I mean, obviously you will be initializing outside if you are not doing it from inside. Okay, so that you cannot do without using this initializer list. Okay, so let's look at the third point now. So guys, third point is you cannot initialize one class member, I mean the data member, inside another class if this class is not having default constructor here. As you can see, this is only a parameterized constructor. We don't have any default constructor here. Okay, and one is a class, and we have taken this one as a data member here in this second class. Okay, and this one is constructed here with this parameterized constructor. I'm passing that one object into this 2. So this 2 is taking it here and assigning that a, which is of this one type, from this x, what I'm getting from here, which is nothing but this one. Okay, so this is the whole flow, and I'm telling you, if you will not assign this in this way, it is not going to work. So let's go ahead and compile this and check that. I'm going to compile this, it is going to compile, will run, it is running. So that means there is no problem in this code. So if I will remove this initialization like this one, and I'll go for the traditional one like a is equal to x, which I think you might be thinking would work, but it's not going to work. We'll compile this, and there are some error. No matching function for call to 1 and 1. Why? Because there is no default constructor here. And why we need default constructor to be present? Why? Because you need to create this a here, then only you are going to assign this a with this x. Okay, don't ask me question like why you wanted that. So listen carefully. Whenever you are calling it like this, so 2 will call its parameterized constructor this one, because you are passing this 1. Okay, and 1 is of this one type, so you are getting this constructor called. Now this 1 will get copied here, so the copy constructor will be called, and if you are not given that, there is no problem, compiler will give you that. Okay, but see here, if you have created this one, now you want to assign this one into this one. So in order to assign this into this a should be created. And you know, if you are writing this 1 and a, this means you are going to call a default constructor here. You are not passing any value here, like we are passing this 10 here. When you are creating this one variable,
you are not passing anything here. It means you are going to call default constructor, not the parameterized constructor. That's why it is telling you that this one, which is nothing but a default constructor, does not exist. Okay. So if I'll make one, it will work. See, we'll compile this. It is going to compile. Okay. We'll run. No problem. But if in case you don't have this, it is not going to work, and you must have to initialize it using your initializer list. Okay, so we'll just simply fast do this, run it. Got it? Let's look at the fourth point. So this is your fourth point, and the fourth point is you cannot initialize your base class data member from child class without using this initializer list. Okay, this is base class, you have inherited this into the child class, and there is this underscore x underscore y is of child, underscore x is of base, inside base. You want to initialize this 1 into this x, which is nothing but this x, and you want to initialize this 2, which is going to into this one. Okay, so in that situation you have to have this initializer list. This is nothing but your parameterized call to your base parameterized constructor. Okay, it has nothing to do with this one. Okay, this I'm using to initialize this because we generally we should use initializer list to initialize our data members, but it has this base call, which is our main intention here. Okay, so shall I show you that? Yeah, I should show that. Well, I can do that. Underscore x is equal to x, and underscore y is equal to y. Okay, this is not going to work. We'll compile this. There is this error. Integer x is a private within this context, so it is a private variable here. Okay, you cannot do that. So the only option left is using initializer list. So this is the initializer list, and if we will compile this, this is going to compile. If we will run this, we will run. There is no output, so nothing will come. So this is fourth point. So let's go for the fifth point. So this is your fifth point. Fifth point is when you have your temporary variable exact similar to the data member, like underscore x and underscore x. If you remember, previously I was doing it like this, without underscore here and without underscore here. That means you are going to assign this x into underscore x, which is your data member. Okay, but what in case of this one? If both variable name are same, then you have to use this initializer list only to make this happen. Okay, the initialization happen. If you will not do that, let's go ahead and compile this. This is going to work, no problem. If let's suppose you are not using this one and you are going to initialize it like underscore x, then there is an error. It doesn't know which x is what. Like this x is also underscore x, this is also underscore x, both are underscore x. So are you initializing this one to this one or this one to this one? You got it right. So there is a confusion, but if you write in initializer list, there is no confusion. So we'll compile this one. Oh, sorry, we have to use it something like void print, so that you can see it is really disturbing. Underscore x endl done. So now if I will print this b.print, it will show you that it is not having this one as a value here. Okay, you might have thought that okay, this one will go, this whatever this one you are passing, it will go into this one, but no, it is not working that way. Okay, you can see that. If I will just simply change this one to the initializer list, just for your surety, underscore x, then this is going to work. We'll compile this, we'll run this, 1. Okay, got it? So this was point number 5. You cannot initialize your data member which is of same name what your temporary variable is holding. Okay, so let's go for the last point, and that is really very big point. So this is your last point. Actually, the last point is whenever you use initializer list to initialize the data, you optimize your code a little bit. Okay, and we'll see what is that optimization. So I will just go ahead and run this code. First I will clean this. So compile this, it is working, and we'll run this. So now remember, parameterized constructor was called, base parameter, base copy constructor, base default, base assignment operator, and my class parameter. So this I can just explain you like this, like base B10 is getting created, this one. So this is a fair call to the base parameter constructor. So this first one is base parameter constructor. Second one is you are copying this B here. From here you are passing. So this B is getting copied into this B. Okay. So that's why this base copy constructor is called here, because of this B to this B copy. Okay. So that base copy constructor is called. After that you are creating this underscore B here. So there is no parameter. So that's why this base default constructor is called. So this base default is called. Okay. Now after that base assignment operator is called, because now you have reached here, you are going to assign this B, which is this B, into this underscore B, which is your data member. Okay. So this assignment is happening just because of this initialization. Okay. So after that, once you are done, I'm just printing my class parameter. So this my class parameter is called. Okay. So we can see 1, 2, 3, 4, 5. 5 functions were called. Okay. Let's suppose you are doing it with initializer list like this one, not with this assignment. Then what will happen? The same code, nothing is changed. You saw that if you will just assign that using this initializer list, then what will happen? I will compile this code and I will run this. So you can count this 1, 2, 3, 4. Only 4 constructors were called, but in previous code there was 5 construction call. So we'll go through line by line. So because of this one, this base parameter constructor is called. So there is no optimization in here. This is getting called with no optimization. Now this B is assigned into this B. So that's why this base copy constructor is called. Okay. This B is going into this B. And this base constructor, copy constructor is just because this B is now going into this underscore B. You are not creating this underscore B using this default base call. The only thing which is saved is this base default. Don't think like base assignment is also gone. No, base assignment is there actually. This is nothing but your base copy constructor call. But what you saved yourself is this base default. This is not going to call, okay, because this is in place construction. So this base copy constructor is called, and at last my parameter was printed. Okay, so that's why, as you can see, 1, 2, 3, 4 functions were only called in this case when you are using this this initializer list, and 5 were called when you was not using that. Okay, so that's how it is good for optimization purposes also. Okay, so I think I'm done here. If you have any doubt or some concern about anything whatever I explained here, you can comment out. I'll be very happy to answer that. Okay, I'll see you in the next video. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what are the drawbacks of using vector in C++? So the first answer is, it over-allocate memory, which sometimes could be very bad in terms of performance. And the second answer is, whenever capacity of vector increases, it copy all the elements from previous vector to the new vector, and we'll see what is that. Okay, so to demonstrate, I'm using this code here. If you have already watched my previous video, you might be having the idea what is the size and the capacity, but I will give you the same example here. Okay, so what we are doing here is we are creating a vector of integer and we are printing the size and the capacity. So here it will be 0 and 0, but now again we are pushing one element into that vector, so the size and the capacity will increase. Okay, we'll see that how it will increase. So let's run the code here. So as I said, size is 0, capacity is 0. After inserting one element, it became 1 and 1. So I'll copy this code and paste it several times so that you will get the idea here. Okay, and we'll again compile and run. So you see here, when it is becoming 1, capacity is 1, size become 2, capacity become 2, size become 3, capacity become 4, and size become 4, capacity remains 4, and size is 5, then capacity becomes 8. What is this happening here? It's just a simple thing. When your size increases from your current capacity, capacity gets double. Okay, you notice here, initially it was 0, then it became 1, then the capacity became 1. When your size get increased by inserting one element, then the capacity got double from 1 to 2. Then again you inserted one element which make the size 3, so this 2 became 4 here. And then again you inserted one more element, but this make it 4 and the capacity was 4, so that capacity didn't increases. Okay, now the capacity was 4 and you increased by 1, which makes it 5, so that capacity becomes 8 here. And you increase again, so it becomes 6, 7, so the capacity remains same because it is not crossing the capacity. Got it? So how internally it is working, how it is making this capacity increased. And let me tell you guys, internally vector uses array. Okay, not a linked list or anything or tree or something. No, it uses array, and you know you cannot increase the size of array dynamically. So how it is doing like this? So remember this, whenever it is doubling the size like this 1 to 2 and 2 to 4, it is creating another vector and copying the previous vector into the new vector and keeping the rooms for new insertion. Okay, so here you can see when your size was 2 and the capacity was 2, you increased by 1, so it became 4, from 2 to 4. So here the free room is 1 because your current size is 3 and your capacity is 4. So there is one free room in that. Okay, and here you see when it was 4 and you inserted one more which makes it 5, so it became double by 8. So here also it did the same thing. It copied the previous vector into the new vector and it deleted the previous vector, or I should say it created new array internally and it copies the previous array into the new array and delete that previous array. This is how vector works internally. Okay, now look at the answer portion here. What I said, it over allocate memory, which sometimes could be very bad in terms of performance. So as you can see here, it is over allocating. When you inserted one more element which makes it 5, but it allocated 8 size array, so that remaining 3 was over allocated. Okay, and maybe you don't want this, or you can just consider some case where you are inserting 1000 or more than that time, so it will become so much big which is not required also sometimes. Okay, so that is one problem. And the second problem is whenever capacity of vector increases, it copy all the element from previous vector to the new vector. So that's what I said, it will copy the previous vector into the new vector and it will delete the previous vector. You can call internally as an array also. Okay, it will delete that array and it will create that new array and copy the previous array into the new array. These are the main drawbacks of using vector in C++. But still we use vector because there are lots of advantage of using this, and I will cover that in next video. Thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye bye.
Hello friends, this video is about constructor delegation. And if you have followed my MCQ question series, then you will be knowing what is this. Okay, so if you know this, skip this video. I have created this video for those people who don't follow my MCQ questions. So let's look at this. What is this constructor delegation is? So you created this B1 end up calling this one, and again from base you are calling another base with the default values. Okay, so that default values are coming here. Okay, I'll just separate out so that it will be very easy for you to see. See, this is a default call. I mean, this one is default call, this B1, and after that B1 is calling this base with the parameters. So this is another constructor call, and that constructor is this one. So that 0 and 0 is coming, and you are initializing that x and y with 0 0. Okay, and the same is happening with this one also. Like B2, you're passing one value, and that is end up calling this one, and that a is passed to that constructor here, and that b is having this default value. So we delegate the constructor like this. Like you're calling this base, and that base, I mean the default constructor is calling the parameterized constructor with the default values. Okay, and why we did like this? Just because we don't wanted to write this initialization part again and again. Okay, this is very trivial. I mean, it is looking like you could have just simply written this part here and assigned like a to x and 0 to y, and here 0 to x and 0 to y. But no guys, it is looking very simple. But let's suppose you are calling a base constructor, I mean the default constructor here, and in this case you are having, let's suppose, 10 to 15 lines of code for initializing this x and y. Okay, there is some mathematical function which is getting the value depending on the input. Okay, and at last here somewhere you are doing this x is equal to, let's say, some value 1 and underscore y is equal to, let's suppose, some value 2. Okay, so think if you are passing 0 0, I mean if it is default constructor, then you would have taken some default value and did your calculation and assigned this underscore x and underscore y. So in this situation you have to keep this whole calculation part in each and every constructor here. Okay, this should have come in here also, and let's suppose here also. So you are doing code blotting here. You are writing unnecessary code 2-3 times. Okay, instead of doing this, you could have simply written that heavy lifting part. And what do I mean by heavy lifting? Means heavy lifting is nothing but assignment. Okay, so you do the heavy lifting here at one place and call that constructor from rest of the constructor, like default constructor and parameterize other parameterized constructor which is not getting all the values like this. Okay, so no need to write this heavy lifting part here and all the constructors. Okay, so I think I made my point here and it makes sense. Okay, so if you like the video, please like, it will help me a lot. Okay, and yeah, if you have any questions, please ask. I'll be very happy to explain that. Okay, oh my god, I didn't run this program, right? Oh my god, I will just simply run this in order to show you that it is a valid code. Okay, Constructor delegation, compile successfully, running, then 0 0 10 0 10 20 b2 b3. Okay, so it is a valid code. Okay, let's look at the next video now.
Hello friends, welcome to another C++ interview question, and the question is, what does printf and scanf returns when they get executed? Okay, and you might be thinking, how does this become C++ interview question? They can ask any question which is related to C also. Okay, so they can just check out your knowledge and the basic knowledge. Okay, so and the answer for this question is, printf return the number of characters printed successfully on the console, and scanf return the number of elements read successfully from the console. So we'll check out what is that. This array is nothing but one array of characters of 100 size, and this is printf and scanf, and this is, I'm getting the output from printf, and this is the output of scanf. So as you can see here, whatever the output would come will go here, and whatever the output will come from scanf will go here. Okay, and at last I'm just printing that. So we'll just go ahead and just run this code. We compile it, we'll run it. So this is printf, it will be printing this hi there, and after that it is waiting for the console to for me to input something, like I will just say something like Ethan or something. In first case it is giving you 11, and second case it is giving you 1. Why 11? Because this is whole 11 character string. Okay, and why scanf is giving you 1 only? Just because we are using only one element here. Okay, if suppose I'm using something like this, well here and %30, then in this case it will give you different output. So we'll see here again Ethan, and now another value for this, so let's say 10. So now this time it will give you 100 and 2. So that 100 for hi there, and 2 for how many elements you are using, getting from the scanf. So that is for 2. So that's it, I'm done here. Thanks for watching, and make sure you go and check out my playlist so that you will get the videos like this. Bye bye.
Hello friends, welcome to another C++ interview question. Maybe this is not interview question, but it will really enhance your knowledge in function calling. Okay, so this question is, what is RVO and NRVO in C++? It stands for return value optimization and the named return value optimization. So we'll see there what it is. So if this is the simple code here actually, and this is my main function, I'm calling that some function here, and I'm returning some base from there, and I'm assigning into this, and these are the constructors. So we'll see how many times some constructor is being called to achieve this. Okay, so this is the whole topic here. So as you can see, constructor of base is called, copy constructor of base is called, and another copy constructor of base is called. So here, first you call this function, you reached here, you
created this object, so this default constructor is called. Okay, now you are returning from here, so in that case you have to create another temporary object in that case. So then this copy constructor will be called here, and now you are copying that object here. Okay, so in that case also we need copy constructor. So this is what we wanted to see. No, my friends, I have used this flag here. If we will not use this flag, which I will tell you what is that flag here, and then we will run, then only constructor of base is called. This is where the return value optimization comes. Okay, what do you think? Why it should call 3-time constructor? This is just simple one object, right? You are just simply returning this object into this object. Then can't we just optimize it so that we don't have to copy here and there to just finally copy that object into this? Can't we just create that object on this memory itself? So this is something little bit complicated. You just understand something. This function is being called, but it is being called with this memory hidden inside of this function, and this base is constructed on that memory which is passed from here. Okay, and now no need to return and all these things because you have constructed base on this memory only. So that's why only 1-time constructor of base is called, if you see here. And why this was called 3-time, I have just used this fNoAllied constructors flag here, which was disabling this feature in C++. And what is that feature? It avoids unnecessary call to the constructor. Okay, but sometimes we want unnecessary call so that we can trace that is there any bug or something in our code, or if you created some library, is there any problem in that library? So to check that, we enable this with this flag here. Okay, you remember this flag. So you are just saying that no allied means you just don't skip the constructor, you call all the constructor whatever comes along. Okay, and what is that named return value optimization? Here if you notice, you are returning a temporary base. Let's call this something like this, and you are returning this b here, not the base. Okay, so in that case also, if you will see here, I'll just simply compile and check. It is calling default constructor only. Okay, so the only difference is this return value has name b. That's why it's called named return value optimization. Return value optimization and non-return value optimization. Now you know how function returns the value, right? But it's really very good thing to know. So thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, or maybe it is not an interview question, it's just for your understanding. So the question is, where is the best suited place that enum will fit in? Okay, or in other words you can say, what is the best place to use enum? So the answer for that is here. Use enum when you are dealing with some limited set of values. Okay, otherwise don't use that. And for example, you can take like a function which takes limited set of values. I mean one value out of set of different values. Okay, so what do I mean by that? I mean this. There is a function. First we will create enum. So it is sure that I'll be creating enum class only, like color or something. We can go for red, green and blue, and you can give one extra comma here, there is no problem. Okay, so this is ready. Now let's suppose there is one function, we'll call it function. It takes color as a type. Okay, and it does something with that type. I don't know what. We can have switch, it will go inside that, and case nothing but color red. If it is color red, we will print red, and the same for others. So if there is a situation like this, that your some function will take only some set of values, then only you go for enum. If your function can take integer value, then don't go for integer. I mean, don't go for this enum, sorry, because integer can be anything, whatever the range is defined, like 4 byte and 8 byte. In between that, it can be anything.
But here you want either red, green or blue, not anything else. Okay, so we can just simply check this case. Color C is equal to color red, and I will pass this into this function C. Okay, and we can compile this. This is G++A running red. Okay, so I think we're done here. Thanks for watching. I'll see you in the next video.
Hello friends, welcome to another interesting C and C++ interview question. And the question is, what is the difference between structure and class in C++? Read this question carefully. I said, what is the difference between structure and class in C++, not in C? Because there are so many differences between C structure and C++ structure, which I might cover in my different videos. So let's look at the difference between struct and class in C++. There are basically two differences, and the first difference is member of structure are public by default, whereas member of classes are private by default. So let's look at the code to understand that better. Let's say I'm creating some variable here, and I'm not giving any access specifier here like public or something. Okay, so I won't be giving this. So this is what we are talking right now. So, and same here also. So let's see, can we change this class base? So this class means this is related to the class, and this struct means related to the structure. So we'll create some object here, like say CB, okay, and struct, oh my god, struct base SB, okay, and now we'll try to access those member variables here, okay, CB dot underscore bar is equal to 10. So this CB means class base. So as I said, this is by default private. Okay, so if you are not writing anything here, it's private by default. So we'll see that this won't compile. Let's go ahead and compile that. It is saying that declared as private here. Okay, whereas you have not declared anything, but it is saying that it is private. So let's go and check the same thing with this SB also. Let's do this and comment out this one and compile the code again. As you can see, it compiled. That means it's allowed, which that says that, okay, if you have not given anything here like access specifier, so it's considered as public. Okay, so this is the first difference. And the second difference is when we derive some class from base class to, let's say, derived class, and we have not given any access specifier, in that case, if it is a structure, it would be a public, and if it is class, that would be a private. Okay, so let's go and check that also. So I will just erase this whole code now. Let's look at the second difference now. So for that, I will create some class here. I won't write anything here. If I am not writing anything, then if this is class, then here it would be private automatically. Okay, you don't need to write private if you meant to write private here. Okay, if it is class, and let's say if it is structure, then it is public here by default. You don't need to write this. Okay, so this was the second difference. So how to remember this? And the easy way is, whenever it's about structure, it's public, and whenever it's about class, it's private. So it becomes very easy to understand or remember that. Okay, that's the way I remember this.
So I think we're done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye. Hello friends, there is another C++ interview question, and this question is, how do you determine that when you call some function like this, which one will execute first and which one will execute second? Okay, because so what happens, there is one dependency, like you are calling this function 2, so you are thinking I'm writing this build here, so this will execute first, and use here, so this will get execute second. Okay, or vice versa. If you are using, you are building here, then this will execute first and this will execute second. But let me tell you one thing, this is undefined behavior. It is totally independent to the compiler builders, that how they are building this thing. Like either they are using stack, like they'll push this one first, then this one first, then execute this one and then this one, or they can use this reverse stack, like they will push this one first, then this one first, then they will execute this one and then this one. Okay, so you don't need to be sure that first this one will be called, then this one will be called, or vice versa. Okay, because there is no order defined function parameter call evaluation. Okay, let's go and compile this so you will be able to understand it a little better. See, the answer is build here. Now you can use. So first you have to build. I have kept this much big message so that you can understand it a little better. Before building you cannot use it. There is a dependency. First this function should be called, and after that this function should be called. Okay, so you should not keep it like this. The only guarantee which you get in this scenario, in both of this scenario, is that this function will always be called once both of the functions are done. Okay, but order is not fixed, which will get executed first. But the only thing which is fixed is this function will not be called until unless these both functions are called and returned from their places. Okay, once the value is ready at both the places, then only this function will be called, and the same for this one also. Okay, so as we can see here, first we are calling this one, so this build is getting called first. After that it is calling this use. Okay, this one, and we are just passing 1 and 1 to this and just printing that. This is not the important point what I'm writing here. The only important point is there is no order of evaluation of your function parameters. Okay, so if someone asks what is the order of the evaluation of your function parameter, you say there is undefined. Okay, so I think I'm done here. Let's look at the next question.
Hello friends, this is a continued video of the previous video. So if you have not watched my previous video, which is about what is the difference between references and pointers, I strongly recommend please go and watch that, and you will get the link in the description field. So I have noted down few comments here. So this is a bold comment for references, like use reference in function parameter and return type. So this is the best use of references I have seen so far. Okay, and I have noted down few points here. So the first point is pass big object. So whenever you are passing a really very big object, so whenever you pass it in some function like this, so as we can see here, let's suppose this big class is some class and there is this object. Now you're passing this object to this function and you are getting that here. So if you are passing by a value and its size is, let's suppose, really very big, then it is unnecessary copy, and maybe you didn't want that. So in that case, using references are really a very good idea. Okay, you can use pointers in that case, but pointer will make your life so hard because you will have to use arrow operator. Okay, and what is that? Something like this, and data. So you'll have to use this operator all the time in order to call the member of this object. So this was about first point. Whenever you are passing a big object, take it as reference. Okay. Second point is to avoid object slicing. And to show you what is object slicing, let me write a program here. So here is your example ready. And if you will print this, print, then let's see what is happening. If you're not using reference here, and what happens if you're using reference? So for this case, we are not using reference. So let's see what is happening. It will print base. Okay, base is printed. Why? Because it has sliced out the derived part from this object. Okay, so derived is holding base and derived data both, and we know the use of virtual. If virtual function is present in class and you are passing that class object to the pointer of the base class, then it would end up calling your derived class function. But here we are not using pointers, and if you will not use pointers, your object will get sliced. Okay, and to avoid that, we will use reference. See, okay, now we'll compile this and it is printing derived. Okay, so that virtual behavior can be achieved without pointer. Okay, so this was the second point. Let's look at the third point. To modify the local variable of caller function, that is really very obvious, and code for that is, so if you print this, the answer is 10. So what you did, you changed the local variable for you. So for you from where you are calling in this main. So you are main right now and you're calling this function and passing this local to main variable into this, but taking it as a parameter, reference, so you're able to change that. Okay, so the same behavior can be achieved with pointers, but we are not using pointers, and then also it is possible. Okay, and fourth point is to achieve a runtime polymorphism in function, and this is actually the same point as second, because in second we were talking about the slicing, and if you will remove that slicing part, if you will do this, the reference here, then this function will become a polymorphic function. Okay, so in this function, if you're passing derived object like this, then it will print derived, it will call the derived object function, and if you will pass base class, then it will print base class object. Okay, so let's check that. So this is a polymorphic behavior because runtime you can pass anything and it will behave accordingly. So let's compile this and check. Yeah, derived and base. So this is what the polymorphic behavior is. Okay, so this was the fourth point, and I can remember a fifth point. That point tells that there are so many places where you can only use references. Here, whatever we discussed, these points were having option like either you use reference or use pointer. Okay, so these all 4 places where we use reference instead of pointer just to make our life little easier, because pointer include little more overhead, and if you're passing reference, you can treat that object or variable as it is. Okay, but there are few places where you have to use reference, and one of them I can remember is a copy constructor. So let's see the example for that as well. And here you're using a reference. So this place tells that you have to use reference, otherwise this code will not compile. Okay, you can omit this constant. It's up to you whether you want to make sure that you're not accidentally changing this object, but you cannot remove this reference from this. Otherwise it will be a recursive object creation and it won't compile. Okay, so let's see whether it is compiling or not. I'm going to press compile button and it is giving me, you probably meant base const base reference. So here it is telling me the error. Okay, but if I will remove all these things and I will just simply compile this, then it should compile. Okay, I'm making some silly mistakes here. Yeah, so now you have only one problem, and that problem tells that you must have reference here. So let's write this and compile again. Successfully compiled in 0.8 seconds. Okay, so this is one of the places where you have to use reference, and there are other places also. You can comment if you know those places. Okay, now let's come to the pointer point. Pointer point. Yeah, so the pointer is use pointers in algorithms and data structure like linked list, tree, graph, and all that. And why? Because sometimes we put null or null pointer in nodes. So if you have ever done coding for linked list, tree, and all these things, you might remember that you was putting null in left hand side child and right hand side child if you are creating a new node. Okay, so that you can fill that in later point of time when you will get that correct node or something. Okay, but you cannot use reference instead of pointer there, because a reference cannot be null or null pointer. I told you in previous video. Okay, so that is one reason. And another reason is sometimes we change the pointers to point some another node. Okay, so we cannot do this with references, because reference is a very tight bound. If you define a reference saying that I have a variable integer I is equal to 10 and I want a reference of I. Okay, so this R is the reference of I. Now you cannot change this R and cannot make it refer something else. Okay, if you are making R is equal to J or something, then the value of J will get copied into R, which is nothing but I. So I will change by the value of J, but you cannot make R point J. Okay, so this is kind of fixed once you have written this line. Okay, but in case of these type of algorithms, we keep on changing the pointer values.
so you cannot use reference there. Okay, so I think I'm done here. If you have idea of few more places where pointer and reference can be, please comment out. It will be a good fun to know those things. Okay, thanks for watching.
Hello friends, welcome to another C++ interview question, and this question is which one is faster among pre-increment and post-increment. So I have brought this website so that we can visualize it, that which one is faster. So we all know that post-increment is little slower because you don't update value at that moment only, you update it later. Like you are incrementing this I++ here and simultaneously you are assigning it here. So initially the I is 10, so 10 will go into J++, and later after this, I mean at this line, this I will get 11. Okay, so there was some magic happening inside. We never talk about that. Okay, so I have brought that here. So this is the I++ case. I mean this is post increment and this is pre increment, and this red one, this red line, this line is generating these 4 assembly instructions. I mean 4 lines of assembly instruction, and this pre one, which is this, I don't know, blue, is generating these 3. So pre is generating 3 line and post is generating 4 line. So that is pretty obvious that we can see post is taking more time. Okay, but what is happening inside? So let's look at that. First I++, so that is post increment. Now pay your attention guys, this is nothing but your I. Okay, so as you can see, this RBP -4, this RBP is some value, we are referring that and doing -4 so that we are reaching to our I location, and the same reference and -8, then we are reaching to our jth location. Okay, so consider it, this is I and this is j, and you have assigned 10 to I and 5 to j. Okay, so this 4 is nothing but I. So what you are doing, you are moving your I into some EAX. This EAX is nothing but some register. So what you did, you just copied your value, what was 10, to some register. Okay, now what you did, you are doing this LEA. It is nothing but incrementing this value. I mean this RAX. RAX is nothing but your accumulator register. If you don't know what is the job of accumulator register, you just think of it stores the value of your current address. Okay, that means what you are doing, you was holding this I, right? So I is having 10, so you assume this is 10. So 10 plus 1, 11. That is what we want to do. We want to do plus plus. So here it is 11 and you are moving that 11 into EDX. So this one is having 10 and this one is having 11. Okay, now what you did move EDX, which is 11, to RBP 4, which is I. So you changed the I here. Okay, now you have moved the EDX, which was 11. If you notice, you have moved the 11 into I. So I have got changed and it is now 11. Okay, and after that you moved EAX, which was originally 10, to the J. That's how we achieve. Okay, so this is what we all know happens internally, that you will be moving 10 into that and I will get incremented magically. So this is what magic is. Okay, you are assigning 10 into J and you have incremented your accumulator register by 1, which was holding this ith value. So nothing but 10 and plus 1, 11, and you move that 11 to EDX register, and lastly you move that EDX to your 4. 4 is nothing but I. So I is holding 11. Okay, so we are clear till now. This was I++ case. In ++I case, which is pre-increment, which is faster than I++, we add 1 to 4. So 4 is nothing but I only, you can see here. So we did addition, and how this assembly addition work, you add 1 to this I and store into this. So this is how we should interpret, like you will add this one and this one all together and you will store at this location. So this is how we interpret this add and all that. So you have made this I 11 now. Now what you did, you are moving RBP4, which is now 11, into EAX, some register, and then you are moving that EAX to 8, which is nothing but your j. So the updated value is coming to j here. Okay, so this is how it is being done here. Okay, I think you enjoyed, and please use this website or getting money out of it. Okay, I am just promoting this because I always use this to visualize the assembly code and which one will work fast and which one will work slow. Okay, so maybe it will be helpful for you, so I'm suggesting that. And please check out my other videos for interesting C++ questions like this. Thanks for watching. Bye bye.
Hello friends, this topic is why copy constructor takes argument as reference. You might have seen that all the time, but you might not be knowing that, so we'll try to understand. Let's look at the code now.
So this is the code, and this is one foo class here, and this is a default constructor, and this is a copy constructor here. So I have created one function object here. I am setting the value 10, so it's getting set here. Now we are creating another object called foo f2. This is statement. The copy constructor will be called, and this is the syntax we write for copy constructor. This constant is for you won't accidentally change this object whatever you are passing, because you are intended to pass this into this. You're not intended to change anything inside this object. Okay, so you are taking this as a constant. And the second question is, you are taking this as a reference just because you don't want to make a recursive loop inside, because let's say you have not used this. So what does it look like? It is looking like a pass by value. So for this statement, which is a copy statement, which is you are copying this one to this one, this copy constructor is called internally. Okay, so again now you are passing this f1 to this object, so again the copy constructor will be called, and that copy constructor will again get called. So it is an infinite recursive loop. Okay, so let's see what compiler says about that. If you are not given a reference here, so let's see what compiler will give you the error. So it is telling that you probably mean, yeah, see, compiler is very smart. It is telling you that straightforward, because it is very obvious thing that you need to create the copy constructor with pass by reference. Okay, so that's the reason which you should always use pass by reference while you are creating the copy constructor. This is the way you would create copy constructor. Okay, and you should have this constant. If you will omit this constant, then also this will work. If you will see here, yeah, it got compiled, and if you want to run, it will run without any problem. I have not given any print statement, so nothing came, but you can see it is running. Okay, so that's it. Thanks for watching. Hello friends, welcome to another C++ interesting question. And the question is, why we must define static member variable of class inside CPP file, not in header file? And the answer is, it will create multiple definition error. Okay, and it is a compile time error, and the linker generates that. Okay, now let's look at the code for better understanding. This is my app.cpp. This is the main driver of this whole application. This is the foo class source file, and this is your class declaration. Okay, I'm talking about this static variable here. I have given static variable name. Okay, and the normal variable as normal variable name, and I have given some APIs to set and get those variables. Okay, this is for normal and this is for static, and here you will get the definition of these things. Now our question is where to define this static variable, either in header file or in this CPP file. So let's keep this in header file and try to compile this program. As you can see, it is showing multiple definition of this static variable exist. Why it's like that? Because you have defined this one inside your header file, and you have to include that header file here and in main. So you have included this foo 2 times, here and here. And now if you see here, I'm compiling with this two compilation unit, or you can say source file. Okay, so here it is coming 2 times because it is included in app.cpp as well and the foo.cpp. So in that case it is showing the multiple definition problem. So how to recover from that problem? So instead of just declaring it in a header file, you can just simply put this into your CPP file. So let's compile this code after putting this into CPP file. As you can see, it compiled successfully, and that a.out is generated. We can just simply run that, and these are the values I'm getting and setting in this application here. I'm repeating this again, and the reason why we always declare in header file and define in source file is that we all know we include header files here and there. So wherever that header file will be included, that variable will be created. So application will have multiple definition for that single variable, and this is compile time error, and the linker will generate that. Okay, so you have got your answer for this question. So I think we're done. Thanks for watching, and make sure to like and subscribe so that you will get the notification for upcoming videos like this. Bye bye. Hi friends. So this topic is why to prefer pass by pointer or reference over pass by value. So we'll directly see the code now. This is your main function. This I have taken a vector. You can, if you don't know, you can go ahead and check out my other videos. You might get that. So there is a vector. Just consider it. If you don't know, then just consider that we are making some array in that. Okay, and this is the size. And for now, I have taken the size just 10 here. Okay, so like that, and I'm passing into some function called foo here. So this is I'm taking. This is called pass by value because you are taking the value. So what do you think? What is happening here? It is copying one by one element from this vector to this vector. It is copying that. It is not referring this same vector even though the name is same, and we don't want that copying because see this is 10 here, so sometimes this could be a 10,000 or this much big element. So you won't be liking to copy this whenever you want to pass this because it is a big headache, and it will take so much time to copy this whole vector and make a copy and pass to this function. Instead, you can just simply pass the reference of that. Okay, and the beauty is that your code will still work. Okay, see, and if let's say if you have not given anything, and we'll compile it and we'll run. So as you can see, it is running from 0 to 9 because I have given this cout statement here. I'm looping through. Again, if you don't know this auto, this is a type deduction mechanism in C++. So this is nothing but just you are looping over this vector. So if its size is 10, it will loop for 10 times. If its size is say 100, it will loop for 100 times. So it's like writing like this. Okay, so generally I'm in practice with C++ 11 and further, so I don't write like this. So yeah, this is what it is, guys. You should not prefer using pass by value bigger objects. As you can see, its size could be very big, so that you will end up copying a very big object. Okay, so generally we should prefer using reference, and there might be some fellows who might be thinking that if you are passing by reference, and what if you mistakenly change this, then what is the problem? You can just make this as a constant now, so that you won't up changing anything by mistake. Okay, yeah, and you can just simply use pointers here. So what could be the pointer here? So instead of passing this, you could just simply pass the address of this, and you will get it here, but syntax will be almost same here. So that's it. Thanks for watching.
Welcome to another C++ interview question, and this question is why returning reference is bad sometimes. Yes, it is bad sometimes, and this is the situation that if you are returning reference to a local variable, then it is a problem. See, this function is being called here, it is coming here, you are creating one integer variable which is local to this whole scope, this function scope, and this I is going to get erased once this function will
finish its call. Okay, so this is called here, you are just initializing one I, you are returning that I, but the reference, not the value. Okay, so that reference will come here and we are just printing that A here. So we'll see what is the output of this. Actually it is undefined, but we can still check the output, right? So let's check this. This is G++. There is a warning that you're returning a reference to a local, but that's okay. We can compile that. Segmentation fault. Okay, so it is obvious and we can expect this error. There is no surprise in this error, okay? Because we are going to access something, this I, and this doesn't exist. So it's obviously a segmentation fault. And someone will say that if it is giving you a warning, then also why you are going to go ahead and run your code? No, sometimes people just don't look at the warning, okay? And as it is undefined behavior, you might not get segmentation fault, you might get some garbage value. I can fairly expect that, okay? Where you can use this return reference is in classes. You might have seen those copy assignment operator, and lots of places we use this because it makes sense. But in this case, it doesn't make any sense. You can return this I, but if you are taking it in some another way, like I from here, and let's suppose this I is already initialized with something, you are passing this I here, you are getting it with reference, integer reference I, you are changing that I with some very meaningful way, like I plus 15, this 15 you get after so much of calculation here, let's suppose like that, okay? And after that you add that 15 to that I, and now you can return the reference of that I and you can initialize this one. We'll run this code, it will work. But lots of people might think that what is the need of making one reference of this one? That's up to you, okay? I just gave the example here, but this is a fair case. You can just simply use this one, okay? So this is a very small topic, but it's really important topic for freshers. So I'll see you in the next video. Thanks for watching.
Hello friends, welcome to another interesting C and C++ interview question. And the question is, why the size of empty class or structure is not 0 in C++? Notice here, I'm saying C++ because it's 0 in C, but class is not there in C, but structure gives 0 in C compiler. But why C++ class and struct doesn't give 0? Why the size of empty class and structure is 1? Let's see that. So first I will create some class here. Let's call it base, and let's print the size of this. So and now we'll compile and we'll see that. As you can see here, it is giving base size as 1. Okay, so this class is totally empty here and it is giving size as 1. And if you use structure here, then the same case will happen. Base let's say 1, and if you are doing the same thing here and you will compile it and you'll run, that is also giving you 1 here, which means either class or structure both gives 1 byte size even if they are empty. So why it's like that? The reason is C++ compiler makes sure that two objects are different from each other. So to make that difference, you need to have this base class at least 1 byte so that you can differentiate it. Okay, and in C and C++, the smallest size you can get is 1 byte. So let's do some experiment here. So I'll just remove this structure because in this case both are same only. What if you use class or this one? So I'll just use some b1 comma b2, and if address of b1 equal to address of b2. So if this is equal, that means these two objects are equal. They are empty and they are equal, but they won't be equal. Okay, so let's check that. And now if they are not equal, we'll print some another message like, so we'll compile that, compiled, and it is saying no,
That means these two objects are different, and C++ makes sure that any two objects are different from each other. So how this C++ would do that until unless you give anything inside this. So it would be very easy if you give something here like if say bar. Now if you will print the size here, it will give you that size only, whatever the size of integer is. Okay, size of bar. So let's check this. Yeah, see, it is giving 4. It is not giving 4 plus 1. Why? Because whenever you will create object of this base class, its size would be 4, at least 4, because it is having integer in that. So that 4 is sufficient to make any two object of that class different from each other. Okay, so why it was 1? Because this was not there. So at least compiler has to do some magic inside so that these two would be treated as differently. Okay, even if it is empty, it will be treated, these two objects will be treated differently. So for that reason only, compiler gives 1 byte to empty class. I'm repeating this again. If you are having some data member inside, then there is no need to give that extra. What you would be expecting, if it is 4, then 1 plus 4, it should give 5. But as you can see, it is giving 4 only. Because 4 is enough to differentiate this B1 and B2 from each other. Okay, so that's the only point why we have 1 byte in empty class or structure in C++. So the bottom line is compiler needs at least 1 byte so that compiler or operating system differentiate these two objects from each other. Okay, that's the answer for this question, guys. So thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye bye.
Hi friends. So today's question is, why template functions only defined inside header files? So we'll look at the answer now. This is a little bit of code snippet. This is your header file. This is what we want to achieve. Like this is what traditionally we want to do, because if suppose it is not template thing, then you will be writing your declaration in H file, and you will be writing those definition into this CPP file. But if it is template, you cannot do this what I have written here, because yeah, that reason we'll see in a moment. Okay, so this is our application, this is our main function. We want to declare a foo, we want to instantiate this foo with integer. So this t will be replaced with this integer, and all these t's will get replaced with this integer. Okay, that's how this template work. Okay, but this, if you will compile this code, it won't work, because you have taken this foo.h here. So this file will come here, and when you will try to instantiate this foo with integer, what compiler will do, compiler will try to place this integer at place of this t, but at this t, but when the compiler will go and search for the function, actual definition of this get value and set value function, compiler is not going to get that. Okay, that's the reason we write these functions inside this header file. If you would have noticed, you are doing this only all the time. So I'll answer you why we do that. Okay, so this is the exact code what I showed you in that PPT, and this is the header file, this is CPP file, and this is our application where we will be using that. Okay, so as you can see, we have included only foo.h. Okay, what we generally do, we don't include .cpp, otherwise the problem will get solved. But we don't want to do that, because it will create so much problem, like you have multiple definition if this header file is included so many places. Okay, so that problem comes. That's why we include only header files. Okay, so now I'll compile this code and we'll see it won't work. So yeah, as you can see, it is telling that undefined reference to set value. If suppose you would have written this two things here inside this, then it should have worked. Okay, we'll see that. See, it got compiled, and if you want to run, you can just simply run that. Okay, the answer is 5 because we are setting the 5 in our application. Okay, so but the question is, we don't want to do that. Let's say how to keep this separate as we do traditionally without template. There are a few ways to do that. One is, after doing this, you define all these functions in separate CPP file and you just include that CPP file here. It's the same thing. Okay, you just include that and we'll start working. So we'll see that we'll just compile that code here. See, it's again working and it is giving you the same answer. But if you would have not written this here, let's see what it will do. It will tell you the same error. Okay, so this is one solution. If you want to separate out your definition from that H file, header files, you can do this solution. Okay, instead of writing that here, you are including that. Okay, so this is one way, and the other way is, wherever your template CPP file is there, I mean these definitions are there, you instantiate the type what you are looking for in the future. Like here I am looking for integer. Okay, so I will explicitly instantiate that so that compiler will generate those functions. Okay, so we'll see how to do that. Template class and then foo, and what we want, integer. Okay, so we have instantiated it. We could have instantiated float also. Let's say you would instantiate it for float as well. Okay, so it will, I think you all know what this instantiation means. Compiler will not do anything, it will just replace this t with this integer. Okay, so it's like that. So we'll see that how it will work. So we'll compile this time with app and our this foo also. Okay, as you can see, it is compiled, and if you want to run this, we can simply just run that. Okay, so we have explicitly instantiated this. Okay, saying that I would be using integer and the float. Okay, there are some benefits and drawbacks, but I'm not going to cover all those things. Okay, so this is the second way to deal with this problem. Okay, so that's it. If you want to separate out your implementation part from the header file, you can just simply either use the first way, which is doing this one. You will just simply include the CPP file here, or the second way is you will just instantiate in the CPP file itself and it will start working. Okay, let's say if you have not instantiated it, some of you might have this doubt. Let's say you didn't instantiate it and you want to compile like this, it will show you the same error, guys. So that's it, guys. We'll see you in the next video. Thank you. Bye bye. Hello friends, today's topic is why using namespace std is considered bad to use. Okay, so we'll directly go to the code now. So now we will see what are the drawbacks of using namespace std. So everyone know that using namespace std is used for standard libraries. Okay, so and the general thing is you will be using like I'll be just taking simple example like cin and cout. So let's say you want to use this cout. So okay, so you used it like this, and for this to work you need to have this using namespace std. Okay, so now we'll go ahead and compile that. Yeah, it worked, and you can see this hi Ethan coming. But why it is considered bad practice? So we'll see that this is not there. If it is not there, then you have to write explicitly here std standard. Okay, so let's suppose today you used this using namespace as standard. Okay, so you don't need to give any std here, I mean the namespace, so we don't need to give this.
So let's say you are in need of some library, let's say call it some library, okay, and this library, see, before you was using this cout, because cout was coming from this namespace, okay, this is an object which resides in this std namespace. Now what happened, you were using some library and that library got updated and they have included similar cout in that library. So what will be the conflict here? Here now you are including that library, so the object will come from that library also. So it will be like some cout is coming from this standard and some cout is coming from this some library. So there will be two cout, so there will be multiple definition of the same thing, okay. So this is not allowed, so there will be a conflict and you cannot resolve that until unless you go and change your code, or you remove this using namespace std and you put here std, so that you can concisely tell that from which library or which namespace I am using this particular object, or there could be lots of functions also, okay. So that's it.
Hello friends, welcome to another C++ interview question, and the question is why vector was introduced in the first place in C++. And this is really very interesting question, and this is the answer for that. It gives advantage of using array and linked list both, okay. So you are using array and linked list in conjunction if you are using vector in your code. So if you try to remember what was the advantage of using array, the array was giving you index based access to your element, which was the fastest access to the element. And the advantage of linked list was you was creating it dynamically, which was the drawback of array. You need to give the size of array initially when you are compiling it. That was the drawback of array. And the drawback of linked list was there was no index based access. If you want to access, let's say 100th element, then you have to go from 0 to 100. Okay. So that was the drawback of linked list. So how vector is using advantage of both array and the linked list? We'll see that with this code. And as I said, it grows dynamically. So if you will insert this 1 here, its size will become 1 and the capacity will become 1. So before this insertion, its capacity was 0. So let's check that. I'll just copy and paste this code here and little more indentation, and we'll just simply compile that. See, initially the size and the capacity was 0. After inserting this one element into that, size became 1 and the capacity become 1. So as you can see here, it is incrementing dynamically. Okay, that was the advantage of using linked list in your code. And the second advantage of using vector in your code is it gives you the index based access to the element. We'll see that in a moment. So let's just simply print that value. I'm using only one value here so that I will be printing only one index. Okay, let's compile that code. And run that. So it is giving you the first element here. Whatever you inserted 1 in that, so it is giving you that 1. If you would have inserted more than 1 like this, let's say you inserted 2, the same access, and this time you will call it 1, and you can just simply run that code and see that it is giving you 2. So this is the advantage of using vector. You can get index based access. So that's it. Thanks for watching, and make sure you like and subscribe so that you will get the notification for future coming videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is why we return reference from copy assignment operator in C++, or it could be formed as why we should return reference from copy assignment operator in C++. And the answer is to support chaining assignment. And what is that chaining assignment? It's like this. Okay, so if you remember, you might be using this chaining assignment in the case of integer and all that. This is our base class, and this is what I'm talking about. Why we return this operator, why we return base reference here. Okay, why copy assignment operator returns base reference or the object's reference, or why not just simply void or something? Why not anything else, just this? So we'll just go ahead and just run this code so we can see it is running. I'll compile and check this. So what I'm doing here is I'm just creating this b1 with 10 and I'm assigning that b1 to all of the objects. So as you and I'm printing this here, okay? So that's why it is printing all cases 10. Let's say if I am doing it like this, if I'm not returning from reference, I'm returning from the object itself, okay? So this is a return by value. So in that case, this project will compile and we'll see the same result. But what is happening internally here? If you will return like this, and if you remember your traditionally what you was using in integer cases like a, let's say I have some value here like, okay, and b is nothing and c is also 2, and if I would write something like this, so what is happening here? This is perfect code, okay, there is no problem in this code. So what is happening here is you are just assigning c into b, and after that you are assigning whole expression, whatever the expression is, with a in that, okay? So this is a perfect code, and if you want to see the output of this, we can just simply check the output, like b is nothing but this one, and okay, and c is this one, okay? So we can just simply check the output of this one. We'll just compile and run. If see, b is 10 and c is 2, so a is not assigned to b and c both, okay? This is the difference. If you know this is a round bracket and its precedence is more, so this will get evaluated first, so the c will come to b, and now the only object remains here is b, so you are assigning a to b. So it's something like that. That's why this b is only getting updated with 10, not this c. So you can see this output here, okay? And no need to print this a, we are not changing a here, okay? So to achieve this, we need this reference. If you are going to do it like this, so I'll just change it here, like let's say this one and this one. I'm assigning this one here, and so the same as this, okay? So this is little separated code here. b2 is equal to b3 and the bracket and b1, and you are doing it with base. So let's see the result of this. I'm not going to, okay, anyway, just forget about this 4 here. We are not changing 4, so no need to print that. I'll compile and we'll run that. So now try to understand the output here. This is 10, I mean b1 is 10, b2 is 124, and b3 is also 124. So these two values are garbage values, okay? Nothing is assigned to b2 and b3 here. Whereas it should be like b2 should have been assigned with b1, okay? As this b is assigned with a, so this b2 should have been assigned with b1, but it is not happening like this. Why? Because we are returning from the value here. So if you will return from reference, then in that case we'll just compile and check. So in that case, you see here b1 is 10, as it is 10 here, we have set here. b2 is also 10 because this b2 is assigned with b1. So our code is working as it should work in all the cases. I mean, as it works in primitive data types, okay? So this is the primitive data type and this is our user defined data type. So if you want it to work like as your primitive data type was working, you have to return by reference, okay? So I'm pretty much done here. Thanks for watching. And make sure you go and check out my playlist so that you will get the videos like this. Bye bye.